All right, so let's actually now try to test that. So I'm gonna remove FFmpeg. We're removing FFmpeg from the entire project. I'm gonna be recompiling the whole thing, and then I'm rendering the entire thing. And it is rendering. And the most important thing, it produces output fab.av, and that's the final AV file that we generated from scratch. We generated it from scratch, and it is fucking working. The thing about this file, this is a very interesting file. We generated that AV file without any third-party dependencies at all. All of the video is generated pixel by pixel in memory. All of the audio that you just heard generated sample by sample in memory. And the final AV file was assembled chunk by chunk in memory, completely from scratch, without using FFmpeg or anything like that. It doesn't use any compression or any encoding, right? But we did that for the simplicity. And it works. It took us 3 days. It was horrible. I had to do that in fucking Rust. But I did it anyway. Hello everyone, and welcome to yet another recreational programming session with Mr. Zozin. Do you know what is a PPM? PPM stands for Portable Pixmap Format, and it's part of the collection of formats which is known collectively as PBM or whatever. So what's cool about this format is that how dead simple it is. So one of the formats, right, so PBM for example, is literally text. It's literally text, right? So I can kind of copy paste this entire thing. I wonder if it's going to work actually. So let's do test BPM, right? So I can copy paste it in here. I can save it, right? So here is the file. Can I open it with? Yeah. So look at that. It says J. It literally says J. So, and it's literally the J that is in here, right? So demonstrated in here. So that's how dead simple it is. It's just a simple text. And what means is that you can generate such images without using any special libraries or any special third-party dependencies, which is perfect when you're just trying to debug something, right? Imagine like you writing some mathematical stuff and you want to visualize it, but you don't really have any sort of like a visual output. Right, so you're not using any special engines, you're not running in a browser, you don't have any special library or anything like that. It's just, but you want to quickly just visualize something. You can output it into this specific format, and there we go, it's a valid format. And what's interesting is that, like, what's so special about this format specifically? You can come up with your own simple format. Well, it is part of the infrastructure, so to speak. So it came very early in 1988, right, 37 years ago. And it basically was implemented in so many different libraries and in so many different pieces of software that it became not really a standard, but like software knows about it. Software infrastructure knows about this format, and that's what's the advantage of this entire thing. As we already discussed, that software is in infrastructure. If you have something cool and simple that kind of embeds into that infrastructure, you can always take advantage of that. So, and since it's kind of embedded into infrastructure, one of the things you can do, you can use ImageMagick to convert it to PNG, right? So since it is implemented in all sorts of libraries and all sorts of software, ImageMagick is kind of aware of this format. So what I can do, I can just convert it to PNG. There you go, I got a PNG of that J without really proper background, but that's besides the point. Right, so I can already like basically feed it into the software infrastructure, right? So now it's a PNG, right? Since it's a PNG, maybe I can open it in Krita, I can modify it and stuff like that. Look, it's just like the whole infrastructure picked up this simple text file, and now I'm already doing things. This is fucking cool. Right, so basically taking advantage of already established infrastructure. But this kind of idea works only for images. So some time ago, actually, I think 4 years ago, I asked myself a question. Okay, do we have something similar for videos? Right. For example, like if I want to debug something that is not just visual, but also moving, like what kind of format can I dump things into, right? Because like if I want to generate a video, right, I'll probably have to use some FFmpeg or anything like that, right? But is there some like very dumb, simple format that you don't need a library for, that is recognized by majority of the software pieces or majority of the browsers, FFmpeg itself, and also different libraries or something like that? Something like NetPBM, but for videos. Is there something like that? That would have been fucking cool. Obviously, I can just output raw frames and stuff like that, but raw frames, will I be able to open it with MPV? Does MPV support? Maybe it does, actually. I didn't check that, but like I want something that is kind of like all software knows about. And 4 years ago, I found a thing which is called FFmpeg 2. Right, so this is a very interesting format, right? So you can actually find it in here. I actually spent like, I think 6 different sessions playing with that format, right? So, and like developing this project, which is basically a playground for that specific format. And I'm gonna leave the link to these sessions in the description. So here is the playlist, right, so and the idea is, you basically store a sequence of frames in a YCBCR pixel format. YCBCR is just like a basically luminance and just like color deviation from that luminance or something like that. I do not quite remember. Right, so but instead it's basically not really competitor, but it's a pixel format like RGB. Right, you can store pixels in RGB, right? So 3 components, 3 color components, RG and B, or you can store it in YCBCR, right? So it's basically one of those things, So if I remember correctly, you just have a simple header with metadata, just like with NetPBM, and just a sequence of the frames or in that specific pixel format, and that's it. That's already valid FFmpeg 2. Right, it's already valid, and MPV can actually open it and can actually display it. So as far as now, the reason why it is called like that, the part UV in its name just derives from the fact that it's a color space YCBCR used for color encoded in digital media is often falsely mixed up with a color UV, which is PAL, something TV, whatever. The file format does not specify what color. Where does it say? Oh yeah, so here it is. So it's a simple file format designed to hold uncompressed frames in that specific pixel format for the purpose of encoding likely to MPEG-2, which is a special codec, right? So it's sort of like probably intermediate format before you go ahead and encode it with this specific codec. Right, so the problem with this format is that it's video-only format. It doesn't like store any sound, like you can't play sound with this format, but for just videos it does in fact work. So, and I implemented this entire thing which generates animation, right, so in that specific format without using any libraries or anything like that. Let's take a look at it. It's implemented in Rust, by the way. So let's fucking go. It was 4 years ago. It's not Rust, by the way. It's not Rust, by the way. It's safe Rust, but there are some unsafe things in it, right? There are some unsafe things in it. So for the purpose that I will actually discuss a little bit later. Right, so let's actually maybe remove this entire stuff. Let's actually remove this entire stuff, and I'm gonna just, you know, quickly git clone this entire thing. 4 years ago, damn. It was kind of really long time ago. Okay, so let's do a clone. And it's one of these projects where I program in Rust, but I do not use cargo, right? So to build this entire project, what I have to do this kind of thing. So yeah, it's using some C libraries, and it's using them directly without using any special bindings or anything like that. Basically, we provide bindings ourselves. It uses OpenGL. So I don't quite remember what it's using OpenGL for, but I think it has a preview mode where instead of generating the video, it allows you to preview the video before generating it, and we're using literally OpenGL to render this entire thing. So yeah. So and essentially here is the thing, and it has a bunch of, yeah, so here is the preview. It works with sound, even though, as I already said, the format doesn't work with the sound, but it also can generate sound. So we'll get to that a little bit later. So let's actually go ahead and do a rendering, right? So let's just say, okay, render a video. It is rendering a video, and it generated two files actually. One in Y4M, which is the video format, and one is PCM, which is an audio file. It's a raw audio file. So essentially, even like since this particular format doesn't hold any sound, it generates sounds in a separate file, right? So you have to like play them in parallel essentially. So and here it is, right? So it's pretty big. It is not compressed because it's a raw format, right? So you can't really have a good compression if you wanna, you know, have a simplicity. So the more compression you kind of apply, the more complex your format becomes, right? A simple format doesn't apply any compression, like in this specific case. And I can open this entire thing in MPV, and there you go. It's open in MPV. So this is basically the animation. It probably, the encoding is completely fucked up, but that's the animation generated frame by frame, pixel by pixel, and then dumped into this format, and it is playable with MPV. Think about it. So it is basically the net PBM of videos, right? It's 5 megabytes, but I mean, you're probably gonna use this format for just intermediate things, right? Then you're probably gonna feed it into FFmpeg to re-encode it, to compress it, or something like that. But you just want to have something, and you don't want to depend on any third-party dependencies, and you want something that is playable with video player, which in our case, it is in fact playable with the video player. It's kind of cool. So it also generates sounds, right? So, and it generates them also like completely from scratch. As far as I know, we would just like generate sine waves or something. So let me actually see. So here is the renderer, and yeah, so here is the function that is rendering thing. And as we're rendering thing, yeah, so we have a sound. So here, where is the state? So this is the state. I don't remember what state that is. So what is the state? State is not even defined in here. So is that a, where is the state defined? So the state might have been defined somewhere. So what is play? Okay, so here is this. Okay, so we have an entire module for simulation, right? So we have an entire module for simulation. It holds the state of all of the rectangles that you've seen in here, right? So it's for splitting, I suppose, when the rectangles hit the walls, they split and stuff like that. And we also have a beeper that beeps. Yeah, we have a function that takes a note and converts it into a frequency. So then we can actually generate a sine wave. Fill gay rectangular GPA. Completely forgot about that. It's a program that generates gay rectangles because they're rainbow. It's man, it's so fucking fun to look at your old code like this. So yeah, we're generating literally everything from scratch. The video is generated frame by frame, pixel by pixel in memory, and the audio is generated like we're literally generating sine wave. And we sampling those sine wave to produce the audio samples, and we dump them into raw PCM file. That's what we're doing here. So it's like, it's literally everything from scratch. It's actually kind of insane. I don't know why I spent so much time doing that. It's kind of useless, but it was fun. It was fun nonetheless. So, and then we have this like a script, which calls to FFmpeg for you render, gets these two files, and then feeds these two files into FFmpeg, producing the final MP4 to produce a file, right? So because, again, our format doesn't hold any sound, so it's kind of like you have to use a different format to add the sound. So we can actually listen to how it sounds like. So the idea here is that every time the gay rectangle hits the wall, it generates a beep. And they all start beeping and stuff like that. So as far as I know, it's a sine wave, so it's not really, it shouldn't go into like a huge dissonance, but it should be fine, right? So let's actually listen to it. So let's do a final rendering. So we are rendering the video. Then it's going to call FFmpeg, right? It's going to produce FFmpeg, and we have a final video. So as far as I know, it's kind of loud. So let me like turn down the volume, and let's actually open it up. Did you hear that? Yeah, so that's basically what it is. It's too quiet. Okay, let's actually make it a little bit louder. So it's kind of cool. And again, so all of the visuals, all of the audios are generated without using any third-party dependencies, literally from scratch, pixel by pixel, sine wave by sine wave, sampled. Like it's like you won't believe how much from scratch it is. Right, so we're not using any third-party libraries. Like we don't even use in Cargo. Right, so we don't even use in Cargo. And like the fact that this format doesn't support like any audio kind of bothered me for a while. It kind of bothered me for a while. It would be kind of cool to like also like get rid of FFmpeg from here too. Right, it would be kind of cool if the executable just produced like a final, like a file that has audio, video, and you can just open it with MPV and it just plays. Right, it's probably going to be huge, half of a gigabyte or anything, but it's completely from scratch, right? It doesn't depend on any third-party things or anything. That would have been fucking cool. And that's going to be a fucking topic of today's stream. Right, so I was looking through different like containers that could accommodate what I want. And I think one of them is AV, right? So this is a AV container that also actually capable of supporting raw pixel formats. So the description of this format can be found on Microsoft website, right? So because as far as I know, AV belongs to Microsoft. They invented that proprietary format. So yeah, we're going to be using this document as sort of like a reference, right? So we're going to learn about it. But as far as I know, it's actually kind of simple. It's a subset of a RIF format, and RIF format is basically a binary format with like recursive chunks, right? So it's basically a bunch of binary chunks that also can be nested, right? And that's it, right? So you can think of it as a binary JSON in a sense, right? So it has two kinds of chunks, right? So like, I mean, two kinds of things, right? First, a chunk with a specific ID and a list of chunks. So you see, it's just basically nested. It's a tree of chunks, and that's it. There's nothing else in there, just a tree of chunks. Just a tree of chunks, and it can support a variety of codecs, and as far as I know, one of the codecs it supports is raw video. Right, so let's actually see what we can do in here. So I'm gonna go to FFmpeg for you, right? So FFmpeg for you, and let's maybe try to re-encode this entire stuff. So here is the input, right? So and here is an output we supply different sort of like things. So let me maybe reformat the command line arguments like so. So I just want to have like each individual flag on its own separate line. Each individual flag on its own separate line, because it's going to be kind of like easier for me to read. So people often criticize FFmpeg CLI for being absolutely unreadable, which is kind of true, but there is a trick into how you have to read it. So the most important parts in here are the I flag, right? This is I flag, and the things without the I flag. Right. So essentially, as you I already explained that, by the way. I already explained that. So as you provide the flags, you provide them up until the point you put -i. So what that means is that everything you provided before the first -i was related to that specific input. It was related to that specific input. Right. So then everything you provided is kind of reset, and you provide again up until the next input. And everything you provided in here is related to that input. It's related to that input. As soon as you provide -i, it's basically reset again, and you provide in more flags up until you provide the output. Right. And the output is just like input, but without the flag. Right. So in here, we provide two inputs. First one is the video file format. There's nothing related to that except Y, but Y is considered a global flag. It's applied for the entirety of the program, right? So there's no parameters for this input. The second input is the audio file, and here I provide the sample format, which is a floating point 32 bits little endian, right? So the frame rate, not really frame rate, sample rate, 48,000, right? So frames per second, and this is the amount of channels, and here is basically the audio input, right? So here is the video input, and this is the audio input, and then I provide the output, and for the output I just explain how I'm mapping the channels, right? So I'm mapping the zeroth channel of the video to the zeroth channel in here, and the this is the input. So I'm taking the zeroth input, which is that one, and I'm mapping it as a video for the zeroth output. Then I'm taking the the first input, right? So this one, and I'm mapping the audio to the output of this one, right? And that's it. So that's how you read that. You should read FFmpeg flags in these chunks. You should read them in these chunks. So anyway, if I try to supply a V, right? If I try to supply a V, maybe we can even take a look at the like MP4, right? So I do FFprop, but MP4 is a little bit more complex than AV, right? The last time I checked it, maybe I'm wrong, but I kind of want to do AV anyway. So it did a little bit of a compression on the videos anyway, right? So even though the video, as you can see, is half of a megabyte, the one that went through FFmpeg is only, it's less than megabyte. So obviously it got compressed. It got compressed, and in terms of the compression for the video, it used H264, which is basically what you want to do these days, right? So it's a pretty good format, pretty good codec. And for audio, it used AAC, right? So it just compressed it as much as possible, and you got a really nice small video. But this is not something that we can generate easily without FFmpeg. So can we like convert that into raw format? So let's actually see. So here I probably want to say something like the output should have a codec which is a raw video, right? So you can always check what kind of codecs FFmpeg currently supports by supplying the codecs flag, right? And one of them, there is a raw video. So this is one of the codecs that it does support. We can actually instruct it to basically use raw video codec for the video, and let's actually see if it's going to work or not. Right. As far as now, it's not going to work, I think. Could not find tag for codec raw video in a stream 0 codec not currently supported in a container. So MP4 does not support raw formats like at all. So that means we can't even use MP4 for this kind of thing. Okay, so if I use AV, right? So let's actually do AV. AV works, but it doesn't like the pixel format that we're using here. And here we're using UV444, right? Because that's what this specific format is uses, right? So, but it cannot do that. Though, I think it generated the video. We can even take a look at this final video. That's kind of funny. It basically, what it did, it basically interpreted UV444 as another thing, right? So let's actually see what kind of pixel format it picked. Right, so why is it 0 all of a sudden? Oh, it's a MP4, I'm sorry. So AV, and let's do FFprop. So for the video, it used BGR24. Right, so it's like RGB, but reversed, and it's using 24 bits for this entire thing. Right, so it's just interpreting UV444 as BGR24. So that's basically what it did in here. But it actually embedded everything in here, which is kind of cool. Right, so it basically reinterpreted this entire stuff. It basically reinterpreted it. So yeah. And in terms of the video, I think, can we just say, let me see. As far as I know, this can be used as an audio codec, right? So just like a raw audio codec. So FFmpeg codecs, and let me find this entire thing. What was that? So floating point 32 bits. Yeah. So that's the audio codec, PCM, right? So I can instruct it to use everything raw, like this. All right. Let's try to render it one more time. Right, and now what's interesting is that, look at that. So the audio file is 495, and like video file 495, and the audio one is 1 megabyte, and the final output AV is 496. So it's video plus the audio. You can clearly see that, and all of that is raw. All of that is raw. And if you take a look at the FFmpeg, yeah, so it's a raw audio, which is BGR24, which is, it is not, but it's interpreting it as a BGR24. And the audio is PCM floating point 32 little endian, right? So everything is raw, everything is kind of easy to generate. The only thing that we don't know how to generate is a V container, right? And this is what I want to try to do today. I want to basically study a V container format, right? So here is a pretty good description. Like I briefly looked into that and it's rather good. Right, I want to study that and I want to learn how to generate a V container because we already kind of know how to generate raw video. So it's in BGR24, I'm generating in UV, but it's kind of easy to convert like around and stuff like that. And audio, we already have the audio in PCM floating point 32 little endian. So it's just like we already have all of the data. We just need to put it into a container. And I think it's a pretty great opportunity to learn about a V format and also about a REF format. So that's basically the idea for today's stream. Right. That's basically the idea for today's stream. Sounds good? Sounds Gucci? A fucking Tamagotchi? Let's fucking go. All right, so we already have a V format that we want to kind of generate. Maybe we're going to experiment on that specific V format. What do you guys think? I think it's going to be kind of cool. So, yeah. Let's actually see. Let's maybe read about this entire thing. So this feature associated with the page direct show, whatever, we don't care. The Microsoft AVIF file format is a REF file specification. So what is a REF file? Let's actually see. Resource interchange file format. Okay, so it's applicable not only for videos, right? So it's for different kind of resources. Like the Microsoft implementation is mostly known through the continuous format AVI, ANI, ANI, and WAVE, right? So all of them are REF formats. I think I vaguely remember that I already work with WAVE, right? But I don't remember anything about it, honestly. So any format is a graphics file. Okay, used for animated mouse cursors. I think it never really took off. The only file formats that I kind of took off are AVI, right, which is a video, and WAVE, which is audio, right? So does anybody know anything about that? I think nobody knows about these formats. So that's the only ones that took off. But they are basically subsets of a bigger format, which is REF. So it's a V format is a REF file specification used with applications that capture, edit, and play back audio-video sequences. In general, AV files contain multiple streams of different types of data. Most AV sequences use both audio and video streams. We already have audio and video data, so we just need to put it into the container. So a simple variation for an AV sequence uses video data and does not require an audio stream. Okay, so that's understandable. This section does not describe the OpenDML AV file format extensions, and we don't care about that either. Okay, so that's kind of cool. So 4CCs. A 4CC 4-character code is a 32-bit unsigned integer created by concatenating 4 ASCII characters. Right, it's basically 32-bit integer. For example, the 4CC ABCD is a representation on a little endian system as this number. 4CCs can contain space characters, so ABC is a valid 4CC. The AVIF file format uses 4CC codes to identify stream types, data chunks, index entries, and other information. 4CCs. 4CCs. Okay. So REF file format. The AV file format is based on the REF, resource interchangeable file format, document format. A REF file consists of REF header followed by 0 or more lists and chunks. Okay, so the REF header has the following form: REF file size, file type, where REF is a literal 4CC. Okay, so this is 32-bit integer. File size is also 4-byte, 32 bits, value given the size of the data in a file, and file type is a 4CC that identifies the specific file type. Okay, so it basically, the file format starts with three 32-bit integers. We can try to open this file format. That was a mistake, honestly, but I mean, it kind of worked. And that is true. Look at that. So we have REF, This is a ref, then some garbage, and then a v, and we have list. Right, so, and they said that they have list, yeah, so here you go. So you have like a bunch of lists in here. So ref, I suppose the third f actually comes from the value after the ref, right? So it's kind of coincidental, but we can already kind of see the structure of this entire thing. And I suppose the thing we want to do is probably start coding. So stop yapping, start coding. So let's, since the entirety of the project is already written in Rust, so might as well maybe continue programming in Rust in here. So there is one executable here, which is main, and this specific thing has a, that's actually kind of cool idea. Look at that. So it has a sequence, like a system of subcommands, like rendering, previewing, and help. And in here, maybe we can introduce yet another subcommand, which is going to be AV. Right, so something like that. So, and yeah, you can have several main functions as long as they are in a separate module. Do you guys know that? I completely forgot about that. Like, again, I wrote this project 4 years ago. I do not fucking remember anything. So yeah, apparently you can do that. So, all right, so let's create a module called AV with the main in here. Okay, sounds good to me. So we have to have a V or S. So, and let's do a V. And this one is supposed to be something like main, like so. Print ln hello a V, right? From a V subcommand. Hello from a V subcommand. So, and now if I try to rebuild the whole thing, obviously it's not gonna work right away because main is apparently private in here. You have to make it public, of course. So yeah, there's a bunch of warnings in here, and they all come from GLFW bindings. So let me actually try to run a preview because I'm rather curious to unpack for you. So if I do a preview, right, so I hope it's not going to be too loud, so I have to be a little bit careful in here, chat. Just a second. Where is my mouse? Okay. Okay, so it literally created OpenGL window. And how does it output the sound? How does it output the sound? So does it do anything special for the sound? So there's a tabs in here. Just a second. I want to kind of get rid of the tabs. So here's the tab 1, 2, 3, 4. I'm going to replace it with that. Sound. Okay, that's the sound. How to use the sound? Sound. PAC. I think I work directly with Pulse Audio. This is honestly kind of amazing. Right, so, and look at that. This shit still works. 4 years has passed, and this code, which is a multimedia application, it creates a window, it uses OpenGL like accelerated hardware graphics, and it produces sound, and it still works after 4 years without using any cargo or any third-party crates. I would even argue the reason why it works is because it doesn't use any third-party crates, because there is a very small surface area of anything breaking. Isn't that the proof of everything I've been saying this entire time? I think this is straight up a proof. Like 4 years, software still works. Software still works. It's kind of fucking amazing. Cargo lock exists, but does cargo lock protects you from a crate being removed completely from repo? So anyway, it does protect you, but I mean, like, I don't know. Every time, like, a lot of software that uses third-party crates, it's just like after a couple of years, I literally cannot fucking build it. You can say all you want. You can fucking say all you want, like, but I have so many fucking times that I use some third-party crates, something fucking changed, it fucking breaks. And always, of course, when I bring it up, it's me who's just holding it wrong. You know, fuck you. Honestly, Fuck you. I'm not holding it wrong. To write a future-proof, robust software, you reduce the amount of dependencies, fucking period. That's how you fucking do that. That's how you fucking do that. 4 years has passed, still fucking works. So anyway, that's kind of cool. That's how we fucking do that. If you disagree with it, shut the fuck up. Shut the fuck up. Shut the fuck up. This is a proof. This is a fucking proof. So anyways, yeah. Let's actually see. Let's actually see. Look files, fucking simple as that. All right. So do we have src sim av. We need to read the file, chats. We need to read the file. So how are we going to be reading the file? So as far as I know, did I ever use the read the file in this entire project? I don't remember, honestly. I don't fucking remember. Read. I never did. Okay, so let's actually see. Rust up doc. So read. So file. I don't remember. Is there like a read string? I kind of vaguely remember the read to string. So there is a fs read to string. Hopefully it, hopefully it just works. But you never you can never really guarantee that. All right. So, and yeah, we're not using crust or anything. We're not using crust. So we're going to be using more or less safe Rust, but we're not like shying away from using unsafe if it is really needed for future-proof software. Okay. So use stdfs now. So we're probably going to be reading the output mp4. So this is a file path. So it's going to be output mp4, and read to string. So it's going to be fs, read to string file path. And here, I suppose we're going to just return a result, right, but without any special thing in here. In fact, maybe I can just create a result, which is, so this is a t, this is a result t like that. So maybe I have to use std result. Where a result is located, I don't quite remember. Okay, so I'm gonna let the compiler tell me this kind of shit. Right, I'm gonna let the compiler tell me this kind of shit. Okay, so let me see, let me rebuild the whole thing. So I'm gonna build.sh. Okay, so maybe I should go, so explicitly specifying CABI, right? We have to specify this kind of thing. So this is going to be C, this is going to be C. All right, so can I just query replace maybe this entire stuff? Like so. All right. So what else do we have in here? Result, it doesn't have result. It's probably located somewhere in CD result or whatever. So what else do we have in here? Defined in mutable places. Yeah, this is because this has to be something like this. What else do you want from me? Could not convert it. Yeah, I don't remember. So there was some trick that I was using to sort of like ignore errors at all. But I forgot how to do that. So there was a trick, and I think I used that trick in Crust or something like that. There was some sort of a trick. Some sort of a trick. Let me actually see. Yeah, map error. Yeah. I would map an error, right? I would map an error and just log it, but then return nothing. So that's one of the tricks I can do in here. So eprintln, I can say in here error like could not open file, file path. And then I would also print an error in here, but then put a semicolon, and it's basically nothing in here. And in here I can even return something like this. Okay, so then if I try to rebuild the whole thing, so fs Return type expected but found string. Okay, so maybe I can ignore the string for now, or let's actually keep the string in here, and here we're going to print something like a red file file path. So red, and let's put the size in here. So size this amount of bytes, and size is going to be the size of the content, right? Content, I don't know, something length. I think that's the length essentially, and that's what we're going to be doing here. So, and it's not sum, it's actually okay. Yeah, it is actually okay. And in here, one of the things that would be nice to have in here is probably maybe just return some sort of a result, like so. Just result like so. So in here we can just do something like that, and in here we can just have okay. Let's just have okay. So seems to be working finally. Seems to be working. Okay, so to mpeg for you, what do we have in here? Oh, so this one doesn't automatically gives you in help the list of the subcommands. Maybe I should just employ my trick with the subcommands in here. Write a len output a v relative, what is it called? How should I want? Yeah, experiment with a v format. So this one can, why can it fail? Oh, this is because I was trying to make print help more generic, because I wanted to actually have separate std out, and it's kind of funny that I used to do that. It's really kind of funny, though. Yeah. Anyways, so let's try to maybe rebuild the whole thing, right? So we're going to be rebuilding the whole thing, and no such file or directory. What the fuck are you? Oh, this is because I removed dot accidentally. Okay, so what we have, a v, right? So, and it couldn't file, it couldn't find it, it doesn't exist, which is rather weird, right? So because it was trying to open mp4. Okay, so let's just say that this one is a v now, and let's also specifically say that it's in the same folder. It's specifically in the same folder, build.sh. Why did it remove fucking dot? Okay. It didn't. All right, so reading into a string binary file is not something that you wanna do in Rust, right? So you have to. Fucking Jesus Christ, fucking soy language, I swear to God. So how do you like read? So do I just read instead? I suppose I just read instead, right? So instead, for fuck's sake, read to string. Okay, so because it will give me like a vector of bytes, right? So and that's probably what I want to have in here. All right, let's fucking go. And okay, so we read, and that's basically the size, right? So like half of a gigabyte. We just read half of a gigabyte. How quickly can you read half of a gigabyte? It's taking some time though. It's taking some time. But I mean, half of a gigabyte, you can load it up very easily. All right. So what we want to do in here, I want to be able to reinterpret the you know, the sequence of bytes somehow. I want to reinterpret the sequence of bytes. So how can we do that? So in C, it is actually super easy. You just take a pointer. And you fucking reinterpret it. But in Rust, I don't fucking know. So let me see. How can I take a pointer of the vector? So is there something like asptr? Or yeah. Okay, look at that. All right. Jesus Christ, it's just like a web technology is just jumping around. Oh, fuck you. Are you serious? Or is that being constant is like, what exactly is unstable about it? Like why? Well, it doesn't really say that it's nightly or anything. It's just like maybe it being const export is unstable. Maybe that's the case in here. But in any case, so what we want to do, what's interesting is that it's not even unsafe. Look at that. It's not even unsafe. It is safe, right? Because as far as I know, here's an interesting fun fact. Unsafe operation is dereferencing a pointer. Taking a pointer is not unsafe. So you can convert to row pointers and just pass them around as much as you want. Right, but as soon as you try to dereference it, this is where the problem sort of like appears. So anyways, yeah, we can take a content as ptr, and here is basically the pointer, and let's actually see if it is, you know, if it is like that. Okay, so ptr, and then, oh my god. So call to unsafe function. Ah, yes. Well, I mean, we're not doing anything unsafe yet, right? So maybe that's fine, and that compiles. Okay, so I suppose like unstable is this thing being const expr or whatnot, right? So let's actually see. Yeah, so it's a const expr, right? So that means it's compilable at compile, it's executable at compile time or whatever. So that is unstable. So okay, so as far as I know, you have things like transmute, right? So you can do transmute. So reinterprets the bits of a value of one type as another type. That sounds interesting. But what we want to do is essentially just treat this entire thing more like, you know, as pointer as const u32, right? So that's basically what I want to do. That's basically what I want to do. And then I want to save that. So the first value is a ref thing, right? The first value is a ref thing. So, and I should be able to do something like that. And then what I want to do, I want to print that ref. So ref, and this is just a ref. Let's go. Let's fucking go. So dereferencing row pointer, understandable. Can I now just put something like that in here? I should be able to do that, I think. Just like say this is the unsafe operation. Okay, and it's actually really well contained. It's actually really well contained. I'm transmuting. I'm fucking transmuting. Oh, I'm fucking transmuting. Okay, so a v and yeah. Okay, so that's the thing. How can I now interpret this entire thing as hex? I vaguely remember you have to kind of do it like that. I kind of vaguely remember it. A freaking dot, stupid ass Emacs. Yeah, okay. So if each individual sort of pair of characters represent a single byte, ref. So this is double F and it's little endian, so obviously it is inversed like that. So it is kind of inversed like that. So not 100% sure. I want to be able to also display ref more like string. Can we have like a ref str where ref str is so transmuting? Can I work with values in here? Can I work with values? Though here, look at that, they're specifically working with, so this is a source and this is DST. And they're here taking a const pointer to void. Oh, this is an interesting thing. So we can use unit as the void pointer, so to speak, and like interpreting it as a pointer to function. That's what they're doing here, which is really interesting. So maybe this is, yeah, this is our case, by the way. Speaking of, this is kind of our case. So maybe we can do that. But what's the difference between as and transmute? Is there any significant difference in here? Because, like, I suppose for pointers maybe there is not that much significant difference. But for more like for values, right? More for values. Transmit asserts equal size. I see. So in our case, this is not probably going to work. Though size of the pointer and size of the pointer to a byte and size of the pointer to U32 is the same. Actually, I'm really curious. So is it going to work? Let's do transmute. right, I'm transmuting this entire thing. So src, right, I have to provide src, which is going to be basically like a const pointer to u8, and what I want to get out of that is a const pointer to u32, and I want to dereference this entire thing. Right, so, and in this specific case, I probably have to do std mem transmute mem. So that's what I want to do. All right. So did it even work? So expression found const. Probably have to do some shit like this, and it's now complaining about that stuff. Okay, so that's understandable. So, and if I just try to do something like this. Yeah, okay, that works. So we can also use transmute in here as well. We can also use transmute in here. So, but here, maybe I can transmute the U32 to, right, so they were talking about U32 to this thing. But I feel like if I try to just print ref bytes, let's call it ref bytes, it's gonna literally print ref bytes. It's not gonna print it as a string, which is something that I want to be able to see, but none anyway. Okay, so, and this has to be a fish, le fish operator, le fish operator. So what does it say? It doesn't, so it's not even displayable. That's understandable. So I have to make it debug. Right, so, and what do, it's an unsafe, so, okay, let's wrap it in unsafe. Jesus fucking Christ. So, is it specifically designed to be as humiliating as possible? I think it is, right? So I think it's like literally designed to humiliate you every time you want to do something useful with your computer. So that's what it's designed for. Okay, so, and that kind of looks like a ref. And is there any, like, a easy and quick way for me to interpret you know, these bytes as a string slice? Right, so there should be something maybe like from UTF-8, I suppose. So there's a str from, yeah, and you get something like this, and probably the way you do that is just str from UTF-8. And it's probably not going to work because this is literally an array value, right? So it is literally an array value. And by the way, I think this unsafe only needed to be inside in here, right? It's only needed to be inside in here because then it is actually rather safe, right? So converting bytes into UTF-8 is a safe operation, right? It's only transmuting, right? So we're trying to reduce the scope of the unsafeness, hopefully. Right, and it has to be like a slice, so we're converting this entire thing to a slice. Unstable feature, what? Use of, how from UTF-8 is a fucking unstable feature into, are you freaking serious? Is this language finished yet? Or am I, like, what? It's closed. So in 2024, what the fuck? Should I upgrade my compiler? Should I upgrade my compiler? Like, what the fuck? Unstable feature, inherit str constructors. Maybe I just hit some really weird feature, but this is not what I want. So, fuck's sake, Brovsky. Okay, so the thing here is that, yeah, so it's a result. Yeah, maybe I should have unwrapped it. Yeah, I think I hit some really weird thing in here. Should have just used CPP, yeah. But I mean, the project is already written in Rust, but... Anyway, so for more information, what the fuck is inherit str constructors? Like, I'm just creating a freaking string slice. Public API, and it's already done. So maybe I just have to do Rust upgrade. Maybe I haven't upgraded my Rust compiler in a while. Maybe that's the problem in here. Yeah, so it needs a little bit of upgrading. Bro, constructing UTF-8 string out of bytes. 2025. What's so unstable about that? What's so fucking unstable about that? Are these people okay? Or is they just completely fucking nuts? So yeah, okay, yeah. So, but I mean, dude, okay. So I just had the old compiler. Not 2025, 2024, bro. UTF-8, 2024, unstable feature, bro. I'm just like, I don't know. Am I the only one who finds all of this shit weird? Am I the only one? It's just like, bro, replace these two. This is actually a good point, honestly. This is a good point. So there is a safer alternative to doing this transmute, which is you know, just using two nepobytes. Using nepobytes. I'm so sorry. Okay, so two блять, сука, nepobytes. All right. Is it a method? Does it have self? It does have self. Why don't you just... Okay, so another question is just like, why don't you just say, bro, just use ref to nepobytes? Right, you make it sound like this method doesn't accept self. Right, so it's just like, why do you do that? Why do you even report it like that? Okay, so let's use nepotism bytes, and let's put it like that. All right, so did it work? Expected slice. Well, that means we'll probably have to take a slice in here, and it says ref. Chat. It probably has to be leb bytes. Yeah, we managed to read 4 bytes from a file in Rust. Congratulations. Congratulations. And this is safe. This is absolutely, well, okay, this is not even safe. We spent so much fucking time reading 4 bytes from a file and it's not even safe. Anyways, so that's kind of funny. So what we're gonna be doing, so this is ref. I'm thinking. We need some sort of a helper function, honestly. We need some sort of a helper function in here. Now try reading 5 bytes and no, I know, right? Do we have something like chop for CC? So here we're gonna accept the content as a vector U8. So, and I want to accept it as a mutable reference, right? So the reason why it is not a slice is because I'm literally going to be modifying the state. Or am I going to be modifying the state of the vector? That's a good question. So yeah, I want to have it as a slice. All right, I want to have it as a slice of byte. So, and the idea here is that I want to get U32, right? So I want to get like one U32, but at the same time I also want to modify the content, right? So I want to modify this slice in here. I want to modify this slice somehow. So the question is, what's the best way for me to do that? Maybe I'm gonna pass it as a mutable so I can shift shift its base and its count. So that's one thing I want to do. Just a second, chat. I need to pour some water. I'm thinking how I will do that in C. I'm back with water. A little bit of water. Chat. We're fucking back. Yeah, so essentially, what it's going to do. Do I look cool? No, I don't look cool. So what's it going to do? It's going to modify the slice and remove 4 bytes out of it. So that's basically what it's going to do, hopefully. Yeah. So when people suggesting to use this kind of slices and everything, we can try to do that. So here I'm going to dereference this entire thing. I'm dereferencing it. And I'm taking 4 of these things. Right, I'm taking 4 of these things. Can I now just do something like from the bytes? U32 from the bytes. I can, look at that. I can do from the bytes. That's relatively easy. But it accepts specifically an array, not a slice. But maybe that's gonna be enough. Okay, so I'm gonna just try to do U32 from the bytes. Right, so this is a from the bytes, and that's basically it. And we can say that this is going to be our result that we're going to just return later. But now what I want to do, in fact, I want to update this thing starting from 4 up until the end. Something like that. You see what I'm talking about? See what I'm talking about? So in here, yeah. Okay. So what do we have in here? Yeah, this is exactly what I was talking about. So found this one. So if I do just slice like that, it literally doesn't allow me to do this kind of thing, right? So can I? So it's try into, right? Try into. Okay, so we can try to do something like try into. No method try into. Yeah. So std convert try into. Okay, so is included in the produced starting items from trade only be useful. No, maybe not try into, but literally into. What does it say? The trade from is not implemented, so it has to be try into. So do I have to use std convert or something like that? Doesn't work like that. Oh, it's result, by the way, so that means I should be able to unwrap this entire thing. Okay. And now I have to take this kind of slice. Anyways. What's funny is that it's just like all of my suffering with this language is completely invalid because I'm just doing it all wrong. I always do everything wrong. So that's basically the sort of like a feature of all of these cultist ideologies, right? It's never the tool itself that is at fault. It's just like you always holding it wrong. You're always holding it wrong. Anyway. So even though like in C, I would have done that, like would have finished like an hour ago, right? So without any of this bullshit, but it's just like, yeah. So yeah, like I'm chopping this entire thing, right? And now, so this is the content, but I actually want to have this content more like a slice content. So this is a content slice. So because of that, can I do something like content and just like contents as slice? All right. Content as slice. Cannot find ref. Yeah, that's understandable. That's understandable. Okay, so that's very cool. Content as slice. And now I can do ref. Right, so chop for cc, and I can make it mutable. And by the way, don't forget to make that mutable. Don't forget to make that mutable. Okay, so that's cool. And that means I should be able to now do something like that. So, and now to impact for you, what is it? I forgot the name of the, yeah, it is a ref. It is in fact a ref. Okay. Yep. So let me now see. I forgot what I was doing even. So let's continue. We managed to read this shit finally. So the next one is a file size. Let's read a file size. Furthermore, you know, what's the value? So this is that. What I want to do is probably do assert ref. I just want to assert that this is that, right? To make sure. Is it beep? Feels like it's beeping. I can hear it beeping. Now, after that, I can do something like file size chop for cc mute content slice. So this is the file size. And does the file size include everything? This will be interesting actually. So let's do print ln. So red declared file size. So this one is going to be interesting, I think. Look at that. So this is the file size that we read, and this is the file size that is declared within the file. Okay, so let's take a look at this step. So it's probably less than the declared one, and if I subtract one from another, it's exactly 8. It's exactly 2 32-bit bytes. So that means this file size does not include the file size itself and a ref, which is kind of cool, which means that it is probably equal to the current size of the content slice, because we were chopping the for 4 cc's, right? We were chopping 4 cc's, and now it doesn't include ref and a file size. So remaining file size is going to be something like this. So this is a file size. We can take content slice, which is the length, right? So we can do that, and they're exactly equal. Look at that. So which is something that we can also assert. I think this is something that you can also assert as you read this entire thing. So we're not creating like a library for like a proper library for parsing AVs, right? So we're not going to report the errors, the inconsistencies within the file properly, but we can just assert them, just in case that if we're reading some bogus file, it just crashes in here, right? So this is going to be convenient. All right, so this is kind of cool. And all of that is saved, by the way. The entirety of the code is safe. We got rid of the transmute. Isn't that cool? I think that's pretty cool. So what does it say? So content slice. So file size has to be usize, I suppose, right? So can you just do something like usize? Yeah. Okay, so that's totally fine. That's totally fine, and yeah, it's cool. So what's the next thing? We have file type. Let's take a look at that. So let file type chop another 4cc out of the content slice. So let's print it. File type is file type. So we might as well actually print it as hexadecimal, and let's just see what is it going to print. So yeah, so there's 4 bytes in here, obviously, and we want to reinterpret it as like a file type string, right? So file type str. So how are we going to be doing all of that? So 2 bytes. So this is the 2 bytes, and what was that? Str to from UTF-8, right? So from UTF-8 we're taking that and we're unwrapping the whole thing. So maybe it should be file cannot find file type. So because it's not str, this is just a regular one. It says a v. Look at that. Oh, it even has a special. Oh, it even has extra space because it's not 4 bytes. A v is 3 bytes. So to pad it, it put a space in here. Wait a second. So what's the? Where is the space? I didn't see a space. It's kind of interesting. Huh. It's kind of cool. So because the space is 32. Aha! That's the space. So the space is 20, but in hexadecimal. So like the lack of 0x kind of confuses me. Yeah. So like 20 is the space. Yeah. So here it is. That's so fucking cool. That's so fucking cool. I really like that. So by the way, maybe we should have like some sort of a function that automatically just like helps us to do shit in here. Though. Okay. So for maybe display 4cc. So, and it's going to accept the 4cc, which is U32, and we just want to have it as a string, but here is the problem. So if you return a reference, you have to work with the, what is it called, lifetimes, right? So maybe we should actually pass it as a reference in here, so it reinterprets that as a reference to something else. But anyway, so let me see. Maybe that is gonna be fine. I think that may work actually. If I just do 4cc, I just do 20 bytes. I reinterpret it like I take a slice of that, then from UTF-8, and it gives me that, blah, blah, blah. So then I can maybe do some shit like this. So display 4cc, which is the file type. Right, so is it even displayable? Arguments, yes, it has to be pointer, that's understandable. And in here, cannot return reference temporary value. It constructs a temporary, it cannot directly interpret UTF-8. Oh my god, this is such a garbage language. Anyway, so whatever. So we're probably gonna have to do that like directly. We're probably gonna have to do that directly. So what I wanna do, I wanna actually also assert, that this thing is equal to that. Just assert that file type is equal to that. As we read all of these things, right? So we're just asserting them. Furthermore, maybe it makes sense to have constants for all of that. So we're gonna have ref, which is U32, right? So this is ref. And maybe we're going to be slowly building up our AV parsing library or something like that. That would be cool. Also, I feel like we're not going to finish what I planned on in a single session. So it's probably going to be multi-session. So AV, and there's additional space in here. So I'm going to put underscore. So 0x AV underscore. And we're going to put this kind of stuff in here. So we have like special constants to check things against. Yep, so everything, nothing broke so far, which is kind of cool. So after that, you get the data. So let's actually read all of that stuff. So file size is a 4 bytes value given the size of the data in the file, and file type is a 4cc that identifies the specific file type. The value of a file size includes the size of the file type, 4cc, plus the size of the data that follows. Okay, so that makes sense, right? It doesn't include itself and ref, but it includes file type and the rest of the stuff. So data that follows, but does not include, yeah, it already said it. The file data consists of chunks and lists in any order. Okay, chunks and lists of any order. A chunk has the following form. I suppose chunk ID, chunk size, and chunk data, where chunk ID is 4cc. What's interesting is that you just like read the file as chunks of like 4 bytes, So that's basically what it is. That identifies the data contained in a chunk. The size is 4 bytes value given the size of the data in chunk data, and chunk data is 0 or more bytes of data. The data is always padded to nearest word boundary. And word, I think word in the terms of Win API is not 32 bits, but rather 16 bits. Is it not? Do we have any professional Windows developers in the chat? Word is a 16 bytes, not 32. This is what I remember from my school days. I think. Okay, so Win API Word. Because 32 is dword, Windows data types. Yeah, so Word is 16. Yeah, dword is 32 bits. So 32 bit. But just word. Can we even find just word? Yep. Okay, so we can lang ID. Okay, so maybe PD word. There's another one. P word. To word. Thank you, motherfucking Microsoft. Can you see this shit? Can you see? I'm not sure if you can see that, but they put the definition of the word at the end of the page. 16p. Alphabetical. Oh, okay, fine. Alphabetical order. Alphabetical order is not always good for humans to read. But it's just like it's always really weird to me. It's just like all of these AI bros are saying that, like, stop writing documentation for humans, start writing documentation for AIs and LLMs and stuff like that. It's just like, but I also want to be able to learn something. Like, why are you phasing away humans out of the, like, why? I didn't fucking ask you to do that. It's like so bizarre to me. Like, AI bros are so anti-human to the point that they feel like they're part of the death cult of some sort. Have you noticed that? Have you noticed that? They're so fucking anti-human, they're basically a death cult. Right. So it's not like they're afraid of the human extinction. They kind of yearn for it. They want it. Right. So it's just like they really fucking hate humans. So, and it's like so bizarre to me sometimes to listen to like how they rationalize all of that. It's just like, holy shit. So because you take their rhetoric and you replace humans with a more narrow group of people, and then just sounds straight up like a calling for genocide. But if it's not a narrow group of people, but more broadly humans, it's fine. Just think about it. Just think about it. Anyways. Carbon-based phobia, yeah. We're really going to get a robot fascism. Yeah, it's weird. So... what we got? So it's 16 bytes. I already forgot like what I wanted in here, right? So I already kind of forgot. So we have to kind of pad it. So the size gives the size of the valid data in the chunk. It does not include the padding. The size of D is the size of the ID and or the size itself. Interesting. So the chunk is always padded, but the size is not padded. Oh, because it gives you the size of the valid data in the chunk. Right. Valid data in the chunk. I was gonna tell AI bros they have flesh brains. No, you don't get it. They kind of want it. Right. So they do believe that they themselves should extinct, and they do believe that robots should replace them. I'm telling you, this is a death cult. Like, they do realize that they're humans, and they do realize that that is going to kill them, and they want that. Because they believe that this is the next step in evolution. This is literally a death cult. You don't get it. Now I get it, yeah. So let's take a look. Here's the thing. If this is a list, it's also for CC. What we have to do, like, we don't know upfront whether it's a chunk or whether it's a list. So we have to read one for CC in here. So chop for CC, content slice. And depending on what it is, depending on whether it's a list or something else, we have to just treat it differently. In fact, we can just print whatever we got in here. So this is some sort of like a ID, right? So this is the ID that we got, and got some ID, right? So got some ID, and here's the ID. Yep, got some ID, which is basically that, but then we need to take a look at that in hexadecimal, right? So let's take a look at that in hexadecimal. So this is that. We don't really know what it is, but let's take a look at ID str. So ID str, and then, so this is ID to le bytes au chocolat. Le bytes au chocolat. I forgot already how to do that, right? So you have to take the slice of them, right, or reference or something, str from UTF-8, and then just unwrap the whole thing. Yeah, let's fucking go. It is called list. It's literally list. But furthermore, maybe it makes sense for me to just put this kind of thing in here, so it's obvious, right? Yeah. So it's literally a sequence of bytes like list. Furthermore, we can maybe even take this entire stuff, const list, and this is u32, and just like now, as I got some ID, I can check. I can match it actually. ID, is that a list? Yeah, is that a list? If it is a list, we can say got a list. Got list. Here, let's put it to do unknown chunk. And we can print that chunk. I mean, who said we can't do that? So ID X, and since they call it CKID, maybe I'm gonna call it CKID as well. So this is a CKID. So CKID. So this is what we got. Cool, got list. So in terms of list, we have list size. List size is a 4 bytes. Okay, so let's put it like that. Let list size chop 4cc mute content slice. So we got list size. So let's put it something like this. List size. And this is going to be list size. This is not really what I wanted, but yeah. So if I try to do it like that, this is our size, 8 kilobytes. So this is a list. So list type, I suppose list type is also 4cc code. Okay, so here, let list type 4cc mute content slice. And here we can do list type. List type, and I suspect that the list type is something that we have to interpret as a string. Yeah, so let's take a look at that as a hexadecimal. So, and it is something in here. It is in fact something. So which we can maybe put like this. List type str. List type str. We do need to factor it out to some sort of function to the bytes, because this is getting kind of annoying, but it creates a temporary object, and returning that temporary object is not something viable for us. But from UTF-8, so I'll also unwrap this entire thing, also unwrap it. So HDRL, this sounds like a sort of like a video terminology. I have no idea what this stands for. A high definition real life. So it's a real life high definition thing of some sort. I have no idea, but yeah, it's pretty cool. Header, or maybe it's some sort of, yeah, it's a header. Header L. Okay. So list type is a 4cc code, and list data consists of chunks or lists in any order. The value of a list size include the size of the list type plus the size of the list data. It does not include list 4cc and size of list size. Okay, so includes size of, yeah, it's kind of interesting. So as soon as you read some size, it's the size of everything that comes after it, right? So because of that, it doesn't include anything before it and itself. Right, so because of that, it includes list type and list data, but doesn't include list size and list. That kind of makes sense. You know what we want to do? We want to kind of skip it and read the next chunk or list. Right, so and just like print all of them in sequence. Just find and print all of them in sequence. I think it's going to be kind of cool. Right, so how can we do that? We can do that by just taking content slice and just reassigning it to... So this is the size, so that means we have to take list size and just continue. So that's one way to do that, I think. Right, it's going to compile, it doesn't really compile. So list size, oh, it doesn't like that it's not usize. Okay, so as usize, maybe for like show 4cc should return usize. I'm not quite sure, but I mean, ooh. Yeah, it has to be u32. God damn it. As usize. Why can't I index with u32? Mozilla. I know that Rust Foundation is not part of Mozilla, right? So it's just like Notch does not develop Minecraft, but everyone blaming him. Okay, Mozilla. What the fuck, блядь? Why can't I index slices with U32, сука? I'm sorry. For system where usize is U16, I guess. Ah, okay. I'll explain it. Okay, so content slice, value assigned to content slice and never read. Understandable. So one thing we probably want to do in here is maybe just do that shit in a loop, right? Fuck that. Just like literally, you know, keep reading motherflippers. Keep reading those motherflippers. Let's go. Okay, so it read 1 and it got an unknown chunk, which is a really weird chunk. So what the fuck is this chunk? Le chunk. Did I skip everything correctly? But I'm not quite sure. So, So this is that, and we want to not printable award. Yeah. It's not particularly printable. So for CC, and maybe I just skipped it incorrectly, but I would expect chunks to be reasonable in a sense. So is this thing even like, how to say that, aligned by 4 or 16? Yeah, it's aligned by 4 at least, right? So it has a divisor 4. It's divisible by 4. You skipped the list twice. Did I? Did I skip the list twice? What do you mean I skipped list twice? You skipped the list type and skipped... you skipped the list type, okay. Then skipped the size of the list. The second for CC. Well, I mean, yeah. List size, list type. Right, so we got list, list size, list size, list type, list type. Okay. So, and then we got list data. List size includes list type. No, it doesn't. List size is 4 bytes. And list type is 4cc, which is also 4 bytes. What are you talking about? There is 8 bytes in here. This is the first 4 bytes and this is the second 8 byte. What are you talking about? What are you talking about? No. No. It doesn't include. It's 2 separate 32 bits. Bro. Don't debate me like that. You also skip it again when you reassign. Ah, I see. Finally. So, but you said second chop for CC. So you were pointing at this piece of code when the problem was in this. You still debated me. You still misled me. You still misled me. All right. So what we have to do in here? Okay, that makes sense. Thank you. Thank you though. But you still misled me. He's not debating. All right. So can I do size of those lighting? Yeah. Is this size of do we have this kind of thing? We have this kind of thing. Right, so size of, yeah, so it does exist. So we have to subtract this kind of thing, right? Let's debate high quality, yeah. Ooh, this one's cool. Look at that. We got 2 lists in here. We got 2 lists. Can I want to like align them more. Fuck, I didn't want to click that. I want to. I can never remember the format of println because it's too different from C. I want a pad. I want to do left pad. If I take a look at the println format, so this is std format. Okay, so here it is. How do I specify width? Okay, so I specify width by putting something in here. So can I say 8? Is that something I can do? Okay, that kind of work. This is roughly what I want, actually. This is roughly what I want. So it's just like make it aligned like that. All right, that's cool. So the chunk that we have problem with in here, it's this one. And let's actually do something like that. This one is going to be chunk ID str. This is a chunk ID str. Chunk ID str. All right. Chunk ID kilobytes. All right. So what is it complaining about, by the way? So unreachable expression. That's fine. Wait. Why do I have junk in the... Well, I mean, it's a Microsoft format. That explains it. So, yeah. Anyways, so yeah. What do we have to print in here? Junk mail, yeah. So println, let's put it to do in here. Let's put it... what the fuck is this shit? So chunk... Maybe I'm gonna put it like that. So this is a chunk ID, chunk that. Okay, so that's very cool. Then in chunk we have to take chunk size, right? So this is a chunk size, which is a chop4cc content slice. We do that, and let's put it like that. So this is a chunk ID equal to this. Then chunk size equal to chunk size, and let's see how big it is. All right, so that looks fine. By the way, I don't really like that it's not aligned properly. Can I put a space in here? Yeah, look at that. Look at that, scheiße. Right, so chunk ID. So this is a chunk, and here's the chunk size. And we'll probably also have to skip that. And then chunk data. Chunk give the size of the valid data. It does not include padding, chunk ID. So yeah, we have to pad the whole thing. So let's put it this way: pad size. So here we have size. I suppose use size, and we return use size. So we pad by what? Width, some sort of like a width in here. So essentially what I want to do is just like I want to take the size, divide it by width, and multiply it back by width. So that's how it's going to align it, but it's going to align it to the lower boundary. It's going to align to the lower boundary, right? So it's basically like a floor. Truncating. So we want to align it like upwards, right, to the next one. So because of that, I have to add width, but -1 in case size is already aligned, so that -1 is going to just like bring it down. So that's roughly what we want to do in here. So, and as we're going to be skipping this entire stuff, it's going to be content slice equal to content slice size, but this one has to be pad. Motherfucking Emacs. Okay, so 2 bytes. We have to align it by 2 bytes, I suppose. Upwards, right? So and just like this. Alright, so is it compilable? So it didn't compile because this has to be as use size. As use size. Okay, cool. Now, I suppose what we want to do is just continue the loop. How many chunks can we find in here? All right, so index 4 out of range slice of okay, cool. 4cc actually failed because we reached the end of the file. So you know what we're gonna do? We're gonna actually do while content slice length is greater than 0. We successfully traversed the entire file. Now this padding looks like shit, by the way. I want to get rid of it. just a second, chat. So let's get rid of that. It doesn't make sense anymore. Yep, we traverse the entire file. So here we have list HDRL, list info, then junk of 1 kilobyte of junk, then movie, which is, yeah, this is the entirety of the file. So kilobytes, megabyte, yeah. this is the entirety of the data. It's a list movie. And then you have IDX, which is probably some sort of an index, right? So all of that is just like a meta information. I suppose the main data is contained in movie. Swap chunk size and ID, please. Well, I mean, this is how the format is defined, but I mean, I get your point. Just a second. So maybe I can even put it like that. Okay. Yeah, that makes sense, I suppose. That makes sense. Kind of cool, isn't it? It's kind of cool. So, and if it's, can we just, so 1, 2, 3, 4, just align it like that. Okay. Okay. And if here we can do, what's the biggest size in here? What's the size here? It's 9 characters. Okay, so let's say actually it's going to be 16. And because of that, this one is also has to be 16. I'm obsessing over like a very minor thing. I apologize for that, but yeah. So maybe this one is too much. What about just 10? Yeah. So if I'm just chat, it's fine. It's fine. I'm gonna get it. Yeah. There we go. So this is what I want to do. Does it look cool? Chat. That looks like shit. I mean, it obviously is gonna look like shit. But here's the thing. Lists is a sequence of chunks, isn't it? What that means, we can actually, if we encounter a list, we can call this entire piece of code on the data of that list recursively. And maybe we can even indent those things according to the levels, so we can see the structure. So I told you, this thing is basically binary JSON. Like, why don't we use this shit instead of JSON? Why don't we use like this instead of JSON? I think that would be actually better. Obsessive compulsory print formatting disorder. Yeah, I guess that's what I have. I'm sorry. But I mean, like, the better formatted the thing is, the faster you can read it. So it's just like for your own benefit, right? So I completely made that up, but anyway. So dump, dump content, right? So dump content, and here we're gonna accept the content like this, I suppose. Right, and it's gonna be just like something like that. So let's put that stuff in here. Yeah. So this is going to be separate function, and I want it to be recursive, obviously. Dump content, and so because of that, yeah, I have to pass the content slice. And funnily enough, I want to be able to modify the inner copy of the slice in here. That's what I want to be able to do. The inner copy of the slice. Or do I? It's an interesting question. So I should probably accept it as this one. So every time I do this stuff in here, I have to pass it by like this. Yeah, that's what I want. That's what I want at the end of the day. And this one is a fan, obviously. Right, so let's see. Does it compile? Does it compile? It doesn't fucking compile because it's not called content slice anymore. It's just called content. And the reason why I call it content slice is so it does not, collide with content that owns the data. Right, so this is the string that owns the data. And this one is content. So I don't really know. Maybe I should call this thing bytes, and content is just bytes, and then we replace content slice with just content. Is that better? Right, so this one like owns the actual bytes. This one just like it's a window on those bytes. Right, that's the difference between them. So what do I want? Shop for CC content and expects mutable but got mutable. What the fuck are you even talking about? Isn't... Ooh, because this thing is a mutable pointer to slice. Yeah. Damn. All right. So, and this one has to be mutable as well. Ugh. Ah, and since I'm doing it like that, this is so stupid. Chat, Rust is stupid. Have you noticed that, by the way? Have you noticed that Rust is fucking stupid? And it's kind of sad, in all honesty. Rust forces you to refactor. Yeah, it's like all of a sudden you just start refactoring some instead of doing useful work. It's just like, it's kind of insane. What's funny is that I never had to experience that in Crust. As I was developing the B compiler, yes, Crust makes you do a lot of like weird stuff. It doesn't have a lot of things implemented. It doesn't have associative containers and stuff like that. But I never hit this sudden refactor everything phase. Right. So, and anybody who developed anything serious in Rust, not just a bunch of hello worlds or glued together a bunch of libraries. No. Something actually serious in Rust. They know that they're just working on something, and all of a sudden they can hit this phase, like, go ahead and fucking refactor everything, this instance, otherwise borrow checker not gonna allow that. Like, everyone knows that phase, and it's just like, oh my god, I just need to finish something. No, go refactor fucking everything, pleb. So that's basically experience with Rust. When I was programming in Rust, I never had that. I had all sorts of inconveniences, right? So, like, lack of useful things, lack of useful data structures or anything like that, but never, through the entirety of the development of the B compiler, I had this go refactor everything phase. So we usually create a local slice in functions like that. Yeah, so I probably have to create a local slice. I agree with you. So yeah, it's kind of interesting. So the thing we probably have to do in here, by the way, is that we have to pass this thing like that, and then make this variable, this parameter rather, mutable. Why are you not choosing Rust for this? Because it's already written in Rust. Okay, so whatever. So what we're gonna do in here is something like that. Right. So it's basically my local copy of the content, but the copy is stored within the parameter. That makes sense, hopefully. And because of that, since I get this like a local copy of it, I'm just modifying it. But I'm not modifying... Okay, so this one is interesting, actually. So maybe that's exactly what I want, then. Maybe that's exactly what I want. Okay, and I can mutate it. Yeah, there we go. So I just needed to vent a little bit before solving the problem. You see, you just let it vent, and the problem is automatically solved. But yeah, Crust, like in Crust, I never had to refactor everything because in Crust you're using row pointers, and row pointers disable borrow checker. Usually it's the borrow checker that forces you to go and refactor everything. But without it, it's just like it's fine. It's actually fine. Honestly, the next Rust, and this Rust is gonna actually fail. I'm telling you. So the next Rust is not going to have borrow checker. It's like it's a reference to the famous phrase that the next Haskell is not going to be lazy, right? So my prediction that the next Rust is not going to have borrow checker. The next Rust is nah. New pose unlocked, maybe. That's actually pretty convenient pose. Just a second. Yeah. Perfect. Clip that. Screenshot that, rather. Over the chairs, yeah. So Sweet has invented a concept of dependency lifetime and no escape types that have the same safeguards as the borrow checker, but way less restriction. As far as I know, D had an interesting development in terms of borrow checking, like lifetimes. So they have a disableable borrow checker, so which is kind of cool. I do approve of that idea, actually. Okay, here's the thing, chat. Excuse me. Now we can actually have two separate slices in here. Look at that. We can do from 0 up until the list size, right? So let's call it content size rather. So this is the content size, and I can say, okay, so here's the content size, and this one excludes the content size, right? And we just call this thing recursive. Fuck you. Oops, sorry, content. There we go. Look at that. Look at that. This is kind of cool. It's kind of cool. So you dump content, you just like go recursively into that, and then you do something like this. And we'll probably also want to have some sort of a level, like how deep, how balls deep we are into that. So in here, what we'll probably have to do before printing is just something like this, from 0 to level, and print just 2 spaces per level. I think that's reasonable. Unfortunately, I can't do shit like that in Rust. But I have to do it like that. Okay, so dump content, and this is 0. Dump content, and every time I go level deeper, I'm gonna do something like that. So I wonder if it's gonna be too missing in. Oh, you literally can't. Man, okay, so in Jai you can actually do shit like that. If you want to just like perform like something n times, you can just do it like that. And the reason why Jai allows you that is because it has a default variable, which is it, which refers to the thing that you're iterating. So I kind of miss that. This is kind of a genius idea. I really like that. So, but in Rust, in a filthy Rust, you have to do this kind of shit, unfortunately. We have to do that on each iteration, I suppose. Huh. That's the structure of the thing? It's literally the structure of the thing. This is kind of cool, right? So, and here is the movie which contains the data, and it's the sequence of chunks, but the chunks are kind of weird. Chunk ID 00DC. What the fuck is that? 00DC. AV. And it's like ASCII. That's the thing. Sparse AV failure diagnosis. Maybe it's garbage. Who knows? But anyway. So let's actually continue reading. Video and audio. Probably it's video and audio. Right, but why do they have such a weird names? Why do they have such weird names? I don't really know. So that's basically what we'll have to generate in here. AV files identified by the 4cc AV in ref header. All AV files include 2 mandatory list chunks, which define the format of the streams and the stream data respectively. Which define the format of the streams and the stream data respectively. An AV file might also include an index chunk, which gives the location of the data chunk within the file. An AV file with this component has the following form. Okay, AV list HDRL, right? So it's a header, I suppose. HDRL. Here it is. It's HDRL. And movie, yeah, that's the data essentially. So do we have movie? Here is the movie, and yeah, it's basically a sequence of data chunks of some sort. And here's the index 1, right? So index 1. It's kind of interesting. The HDRL list defines the format of the data and is the first required list chunk, so it has to be the first one. The movie list contains the data for the AV sequence and is the second required list chunk. They literally have to, this one have to be first and movie has to be second, but this is not true. We have a info. So this shit kind of violates it. Oh, it's a second required, right? So it's just required. It doesn't have to go after that. So AV files must keep these three components in a proper sequence. Okay. So the open, whatever, I don't care about that. The HDRL and movie lists use subchunks for their data. Okay. The following example shows the AV ref form expanded with the chunks needed to complete this list. HDRL have main AV header. So what do we have in HDRL? Okay, so this is that AV header, then list strl, strh, and strf. So strl is okay. So this is the list essentially, right? So there's a bunch of strls though. There's a bunch of strls. And there's a bunch moving. Okay, the header list begins with the main AV header, which contains an AV chunk. The main header contains global information of the entire AV file, such as number of the streams within the file and the width and height and so on and so forth. So HDRL starts with AV. Very interesting, very, very interesting. So how I want to take a look inside of the AV chunk. I want to take a look inside of it. So I'm actually really glad that I decided to print the hexadecimal value now, because I can do the following thing. I can do AV, which is U32, and I'm going to put it in here. And now, if I encounter a AV chunk, I can do some special stuff in here. So I can match chunk ID. And is it AV? I suppose it has to be maybe... Yeah, let's capitalize that. Let's capitalize that. The main, so AV main header. So this is the AV main header. Let's put it like that. AV main header. And on top of this entire thing, I want to print literally bytes of the content. So this is going to be content and content. I want to print it like as a debug. This is going to be debug. But in here, we'll have to take the content and we'll have to slice it. So this is a padded, but padded we don't have to do the padded size. We have to use this one, right? Because that's the useful size, as they say. So this is that one. It's a useful size. So we're gonna just print it. If it's something else, we're gonna literally ignore the whole thing. What do you say? Required by this formatting, something as use size. What do you say? Oh, I probably have to take the reference. Yeah, that's true. Okay, what do you want? So that means if it's something else, I have to ignore it. There we go. So, AV. So what is that? Is that a text? It doesn't look like text. It's definitely not text. I want to embed the content in here, but then I feel like it's going to be a little bit difficult, right? So because we can just always print the content of the chunk. We can always do that. But I feel like if it's the content, like a lot of content in there, it's not going to be particularly useful. So, and also if I want to print the content, I want to print it in a hex editor format, right? Imagine a chunk, and there comes like a XXD style where it just prints this kind of thing in hexadecimal and stuff like that. But it feels like I'm going to spend a lot of time doing that, and it also has to be like padded properly. It has to be padded properly. So do I want to spend time doing that? Or anyway, so is there any information? Oh, whoa. The main header chunk consists of an AV main head. Ooh, now we're freaking. Ooh, okay. Let's fucking go, I guess. So what we want to do here is actually, we're going to be reinterpreting this entire thing, right? So this is literally going to be the transmutage of the thing. So let's call it maybe like this: AV header, v main header. And do I want to have types for these things? How do I want to even approach all of that? So by the way, first of all, the representation has to be C, right? So let's establish that it has to be C. So because it has to be padded differently. By the way, does anybody know what's up with if like explicitly saying that the representation has to be C? Does Rust pad structures differently? Does Rust pad structures differently? I feel like, but and the real question is, why would it pad them differently? What's so special about padding the Rust like differently? It's kind of weird in my opinion. It's kind of weird. I think it does not guarantee layout. Ah, so it's that bad. Oh, it's okay. Oh, okay. It doesn't even guarantee you shit. Oh, I kind of vaguely remember that Rust doesn't even have like a proper memory model, like at all. So yeah, more like rearrange. Oh, it may rearrange them even. Okay. It may even rearrange them. I see. Okay, fair enough. I guess fair enough. We want to move away the user of a system language from the computer as much as possible. Understandable. That's a noble thing to pursue for a system language. Fucking. Anyway, so we want to do something like that, right? So, and for all of these things, let's say for CC is going to be dword, right? So how do Rust people do packed structs? That's the neat part. Because packing structure is a very platform specific thing, so it's very unsafe. Like, this is so funny. Like, are you developing a system language or a web language? Like what exactly? Like, it feels like Rust sometimes has an identity crisis. Are you system language or not? So, fucking made up your mind already. So this is going to be v32. Anyways. So bit field. Oh, by the way, does Rust even have bit fields? Like this is not a system language. Don't. Oh, it's a separate crate, of course. It's a separate crate. Honestly, if Rust wasn't trying to be a system language, I would have no problem with all of that. And I think Rust should abandon an idea of being a system language. Seriously. Because I've seen web developers absolutely loving Rust. They absolutely love Rust. And honestly, all power to you. Like, if you love Rust and stuff like that. It's just like, I think Rust should just abandon an idea of being a system language. Just stop being a system language, honestly. Also, fucking introduce garbage collector. Introduce a garbage collector. With a garbage collector, by the way, you may never have use after free, and you, because of that, you may finally drop borrow checker and become more usable. Honestly, just do that. But they're never gonna fucking do that. Because that space is already fucking saturated with C#, with Java, with all sorts of languages. Like, they... I'll do a simple thing. Rust is a... Yeah, so it's just like, it's trying to be a system language, but I mean, if you're trying to be a system language, why are you trying to market it to web devs? And there is nothing wrong with marketing to web devs, but it's just like, don't try to be a system language then. It's that fucking simple. But anyways, so we're gonna have it here. Let me see. Oh yeah. So let's go replace semicolon, something like that. Let's fucking go. So it doesn't like this kind of thing. Okay. So you know what I want to do now? You know what I want to do? I want to assert something. So here's the SK size. Yeah. We print in that. So this is basically bytes. But then, so we'll already have a SK size. I want to take a look at the size of a v header. What is that? A v main header, right? and it's going to be equal to size of header, right? So it's that. And maybe let's realign things like so. Let's realign things like so. Size of header, so size of, and a v header, main header, like so. All right, let's fucking go. So what was that? Avich, right? Avich. Avich. Yeah, let's go. 64. Aha. So the size of the useful part is 56, but the size of the header is 64. And at the end, I do remember seeing something. Aha! Reserved, motherfucker. Okay, 64 minus 4 multiplied by 4, 48. Oh, that's kind of... So why does it say that the useful size 56 then? Did I do a fucky wucky chat? That's kind of weird. So it's 64. If you pad 56 to the next sort of thing, it's going to be probably 64. It's probably going to be 64. Wouldn't be? So let's take a look at the padded thing. You already passed 4cc. You already passed 4cc. I don't fucking understand what you're saying. Okay. So, oh, you mean, okay. So that was not a useful message. I'm sorry. That was not a useful message. Okay. Now I'm thinking about different things. What am I thinking? I'm thinking that I want you to print like a debug information. So derive debug. Derive debug. Okay. So this is the bytes. Let's print the bytes. So this is the header. It's I need to convert it to size anyway. Because of that, I need to make sure that the sizes line up. So we'll need to think about the sizes a little bit more. Okay, so we chopped the size, and a size must contain these things. So let's have something like this. Padded. So ASCII size padded. So ASCII size padded. Let's put it like that. Okay. So the bytes. This is that, and ASCII size padded. Equal. So the 4cc is chopped. Okay, whatever. Oh, you mean header itself has? Oh, for fuck's sakes! Why did they put it in here? Microsoft. What? Freaking. Okay, so yeah, that was a more useful message. Thank you. Like, I just forgot that I have this thing in here. Freaking Microsoft. Fuck you, Microsoft. Anyway, so Avich, what's that? Okay. It's already padded though. So do I have to remove another 4? And CB is it's a size of the structure, man. Okay. Now everything lined up. Thank you so much, guys. Thank you. Really appreciate it. So Avich, all right, and now they finally line up. Okay, so what I want to do in here then, we need to assert that. So we need to assert that if it is Avich nesting. What nesting? I don't understand. Anyway, assert. Let's freaking assert that. The size of the structure is equal to the useful work, to the useful size. ASCII size, right? So it is equal to the useful size. And this is where we want to probably do reinterpreting. So we're gonna take the content in here, right? So here is this, and maybe we can even take the as a pointer, right? We're taking it as a pointer. We're going to be transmuting it. We're going to be transmuting it. And we want to transmute that into a pointer to this structure. And we want to dereference that structure and get the header. And I think transmuting, in fact, is justified in here. I think transmuting is justified in here. So, and in here, header Twitch needs to make backstitching better on mobile. Yeah. So, header like this. So I'm gonna remove that, and like that. Oh boy. Alright. So, and transmute. Maybe I'm gonna do mem. Test the mem. Alright. So use std. Fuck. What does it say? So it's because it's not use size. As use size. Transmute function accepts 2 arguments. Ah yeah, so we're transmuting the source, which is going to be const u8, and I'm reinterpreting it as a different. You could clone this move occurs. Yeah, it doesn't like that it's moving, which is understandable. Okay, let's do the clone. And you can't clone it because it's not clonable. Okay, listen. Can I just... How can I convert to a slice like that? Can I do something like this? Can I reinterpret pointer to a constant reference? Is that something I can do, by the way? I can. Okay, that's perfect. Vich. Aha. Perfect. We got the structure. We got the fucking structure. That's cool. Can it pretty print that? Rust debug pretty print, because I want to, like, you know, have the fields in a separate. Aha, so it's a hash. It's a hash. So let's put a hash in here. All right, Vich. Ah, yeah, there we go. Now we're freaking talking. So this is what we managed to read. So microsec per frame, maximum bytes per second, some flags, total frames 360. Total. The amount of streams is 2. This is correct. This is actually correct. Suggested buffer size. Width and height is correct. Okay, I'm super happy with width and height because that's basically like a checksum. You can consider that a checksum, and this is a correct width and height, so we parsed the AV header correctly. We parsed it correctly. Can I indent the whole thing somehow? Is that something I can do? Right, so because I want to indent it to the padding in here. Does anybody know how to you know, customize that? So pointer reference in Rust as identifying behavior if in, yeah, okay. So so this is a debug, indicates the alternate form of printing, the alternate form pretty printing, okay. Like I want to just change the is there any parameters for pretty printing? Pretty printed. Okay. So pretty printing with that. I feel like there's no parameters for pretty printing. I think that this is not something that you can do, unfortunately. But I would love to just like indent it a little bit in here. I would just love it to indent it so it looks a little better. Though, so pretty printing. Yeah. That is sad, chat. This is straight up sad. I guess we're not gonna be formatting it like that. I guess we're not gonna be doing that. But anyways. So what's gonna be the next thing? What's gonna be next? So this is the main header. AV stream headers. So one or more strll list follow the main header. strll list required for each data stream, and in fact we have 2 of them. So here's the first strl, and this is the second strl. All right, required. Each STL list contains the information about one stream in the file and must contain a stream header strh. Here is the strh. And a stream format chunk strf. Here it is. In addition, STL might contain a stream header data strd and stream strn. Okay, so the stream header chunk strh consists of a vstreamer header. So this is the thing that we have to do now. All right. So honestly, I did a similar thing in C, and in C it was a little bit painful because I could not just format all of this stuff. But I think like Rust kind of makes that part a little bit better. I think it makes that part a little bit better. So I'm already streaming for 2 hours, honestly. I'm already streaming for 2 hours. I think I'm gonna call it a day. We're gonna continue on the next day, and we just like fully parse and understand this format, right? And we'll see how we can generate our own. So, sounds good. Gucci, Tamaguchi. So let's do subscribers off. Right. So we're almost there, right? So we're almost there. We identified the higher level structure of a V file, higher level structure of a V file. So now we need to parse the headers and stuff like that. And yeah, so we'll probably go towards the data stream in Movi chunk, right? So we have the Movi chunk. And I suppose they're just like, as you guys already said, it's just like a chunks that are interleaved video and audio. So we already have video and audio, we just need to embed it in there. So yeah, but we're gonna continue tomorrow, right? So don't wanna stream for too long today. Okay, that's it for today. Thanks everyone who's watching right now. Really appreciate it. Have a good one, and I see you all on the next recreation programming session with Ahu and Mr. Azuzin. I love you all. Mwah. This is the next day, and let's continue where we stopped. So I don't quite remember where we stopped. Does anybody remember? Okay, so I remember the module was AV, and we started to look at like the next header and stuff like that. So I remember that one of the problems that I had yesterday was that I couldn't align debug structure. So it's not a make, I have to just build this entire thing. Yeah, there we go. And then if I try to do FFmpeg for you, and it's just a V. Yeah, so I didn't like that I couldn't align this entire stuff like with 2 spaces and everything, because it's just this entire thing doesn't allow me. Off screen in the Discord we actually discussed how you can do that, and the idea I came up with is to just like render this thing into a string, split the string by lines, and just print each individual line with the indentation. So there is no other way I can see to do something like that. So let's actually bring it in here. I think it's going to be useful. So where do we use the structure? Let me actually see. So here's the structure, and I'm just like literally rendering it like that. So to render it in a string, we can just use something like a format, right? So, and it just renders it like that. So then we can split it into lines, and we can just like iterate each individual line like so. And so if I try to print it, I can actually print it like that. So that should be actually cool. Okay, so as you can see here, it's not indented in any way. And this is because I didn't recompile anything, right? But it's still not going to be indented. But it's not going to be indented in a slightly different way. It removed that dot. Like, why does it do that? Emacs is kind of weird lately. I do not quite understand why it is doing this kind of stuff, but so yeah, there we go. So it works. But so what that means now, I can just add 2 spaces in here, right? So I can literally add 2 spaces. And if I look at that, as you can see, it is indented properly. So that's one way to indent this entire thing. That's one way to indent this entire thing. Isn't it cool? I think it's actually kind of cool. But though it will be better to indent it even more. So it feels like it's inside of the chunk. So here is the chunk, and inside of that chunk here is the structure itself. Right, so I think that's a really good way to do that. So, but since we're going to be doing that probably for the rest of the structures as well, right? Because the format, the AV spec on Microsoft website actually defines all sorts of structures, right? So it says that some chunks have to be reinterpreted as these kind of structures. We probably will have to do that for a lot of different things. Like for example, here is the so this is a vStream header, then we have bitmap info, wave format X, and so on and so forth. So we're going to be actually rendering a lot of these kind of things. So it would be nice to maybe factor it out like to something. Factor it out to something. So the idea I came up with, also off screen, is to just have some sort of a struct, which is called like indent. Right, and it is a generic struct, right, so which accepts something that implements the debug trait, and it's an internal value, right, it's an internal value, it wraps that internal value, but on top of that, it also stores how much you want to indent each individual line of this entire thing, right, so, and essentially in here, instead of doing this kind of thing, you would just print this entire stuff like that. So this is going to be the header, and in here you would do indent, right, so the value is going to be the header, and then indentation, it will probably depend on the level in here, right, so here is the level, right, here is the level, and we already multiply level by 2, but I actually want to have the next level so it feels like it's inside of the chunk, so something like that. And for this specific indent, you simply implement the debug trait, right, so you just implement the debug trait. I think it's kind of a cool idea, actually. I really like that. So that way we can just wrap any debuggable structure into that indent, and it will indent it however we want. So that's an interesting approach. So we'll have to do, I'll have to implement custom debug for indent. So here is the generic parameter, and we can say that this generic parameter has to be debuggable, like so. So let's actually see if we can do that. So it complains that debug is not available. It has to be, yeah, it has to be taken from here. So I would like to just import std_fmt, because I'll have to use more types than debug from this entire thing, and it's nice to just like prefix them. All right, so what else do we have in here? So this is fmt, and this entire thing also has to be fmt, and this is fmt. All right, so what else do we have in here? So, and it wants to have the fmt methods, right? So we have to implement fmt methods. Like so. It's kind of a weird way. It's doing like a really weird thing in here, but maybe we can just do result. This is fmt error, and if I remember correctly, formatter is also coming from fmt error. So we should be able to do this kind of thing. Result takes 2 generic arguments was supplied. So 1 generic argument, and this probably comes from this thing, which means that I should take the result from here, right? So we should take the result from here. Okay, so what else do you want from me? So has no field indent. Did I call it something different? Indent. Indent. I apologize for that. Okay, so indent does not implement display. Yeah, so because I wanted to have debug, not display. Thank you so much. And that seems to be working, and it's actually already crashing in here. It's already crashing in here. So the way you implement this FFmpeg is like debug thing, is that you take the formatter, and the formatter is a write thing. So that means you can just use things like write_ln, right, to write into that FFmpeg however you want. Right, so, and whatever you write is going to be then displayed depending on what sync is, whether it's a std out or maybe you're rendering into a string, it doesn't matter. So the exact sync into which you're formatting this entire thing is abstracted away. And here we can do literally that thing, right? So we can take a value, right, and just like format it into a string. In fact, we can maybe destructurize indent in here. So in indent, so I can take a value and indent. Right, and I just destructurize itself, and then I can format value like that. Right, so I can format value like that, and I can split by lines. So this is lines, and for each individual line in here, I can just do stuff like that. So, and in here, depending on initial indent in here, I can just like align things differently. So let's do print, not really println, I have to do write_ln. And we just need to write like n indents in here. So one way to do that, like for example in C, I already demonstrated how you would do that in C, is that you would have this kind of thing. where that means the width of the field that you're trying to print in here, right? So, and you can just put indent here as the width, and then empty string, and that will just put an empty string with the width of indent, right? So Rust allows you to do kind of a similar thing, but you have to do that in their different syntax, right? Which I do not remember. Like, I just did that today, right before the stream, and I do not fucking remember it anymore. Right? Because like it's so freaking different from C, and it's like I tried way too many different technologies, like I do not fucking remember. So I kind of, yeah, so first of all, I have to actually look for std_fmt, right? So the documentation responsible for that is std_fmt, if I remember. Yeah, so it's this one. So never seen destruction self like that, but makes sense. Well, I mean, yeah, self is just a variable. You can destructure any variable like that, so it's, yeah, it makes sense. So the only reason why I destructure it like that is so it's easy to use within their formatting thing, yeah, like so, right? Because Rust doesn't have a proper string interpolation, right? So you can only use names in here, and the name that you can use in here is either existing variable name or the name that you kind of bound in here. Right, that's the only thing you can do. SandyX, thank you so much for the sub. Right, so the only reason why I destructurize it, it just makes it easier to do stuff like that with their weird string interpolation, which is not a real string interpolation. So yeah, you kind of do it like that. You kind of do it after a colon, right? So you must have, yeah, you must have an empty string like that in here, empty string, which is going to be something like this, and then you put a width in here. But then can I just put indent in here? I think you can't put indent. Right. So yeah, you have to use the $, like after that, to indicate that this is what you want in here, and then you can render it live. Fuck's sake. Anyways, so let's try to do that. All right, so this is right ln mismatch types. Oh yeah, like this entire thing returns results, so I have to put a question mark in here, and in here I have to do OK. All right, and that seems to be working. Look at that. So does it indent? Yeah, so it does in fact indent things properly. So there is an extra new line, which probably comes from me using println in here. So I probably have to use print. Right, so I probably have to use print. And what's interesting is that, so the problem here, by the way, is that even though I didn't specify use pretty printing, this is how you indicate that you want to use pretty printing, it still uses pretty printing in here. Right, so essentially in the debug implementation in here, we need to somehow catch that the user provided this hash, right, and just behave differently and depending on like what exactly we want to do in here. And as far as I know, it is available in the formatter itself, right? So the formatter itself has something like alternate, yeah, so alternate, right? So, and it determines whether the hash flag was supplied, right? So, and in here you can actually check, right? So if FFmpeg alternate was supplied, just do the pretty printing, the usual pretty printing. If it was not supplied, just like render it as is, just render it as is. So this is going to be FFmpeg, and I just want to render self. Can I render self like that? I'm actually really curious. Maybe I should be able to render it, but not really self. I want to render value, right? So I want to render value, and that should be it. Okay, so let's actually see if it compiles, right? So value, yeah, like this. It's a debug situation. All right. So, and if I take a look at that, yeah, as you can see, it is not pretty printed at all. Not pretty printed at all. Though, since it's an indent, maybe we can indent on pretty printing thing anyway. Right, so that could be nice actually. Right, so just like, yeah. So let's actually see. Yeah, so here's unpretty printed, but it's still indented as you asked. But then in here, where we use indent, I can now say, okay, use pretty printing, and that should be pretty printed. Okay, so this is how we do that in Rust, by the way, if anyone was interested. Can you hack Discord to make it embed MKV files? I don't know. So sounds like you will have to use FFmpeg for that. And using FFmpeg in today's day and age is kind of scary, because for doing so you can get cancelled on Twitter. So I'm not really sure. Like, do I want to take the risk of using FFmpeg? Anyway, so yeah, so we have this kind of stuff. So we have a pretty convenient indentation mechanism here, and we're gonna continue using it. Okay, so what else do we have in here? So this is just avich, right? So this is avich chunk, and then we have stuff for each individual stream, right? So this is, I suppose, strl stands for stream list, right? And we have two stream lists, and we have one chunk in here. All right. So, and within the str list we have stream header and stream format, I suppose. So for all of these things we probably have some sort of structure. So let's actually continue reading the this stuff. So we already did the main header, right? So now we're dealing with stream headers. One or more strl lists follow the main header. Exactly. So here's the first strl, here's the second strl for each individual stream. An strl list is required for each data stream. We have two of them, video and audio. Each strl list contains information about one stream in the file and must contain a stream header chunk, strh. We do have strh, look at that. And a stream for a format chunk, strf. Do we have? Yes, strf. We also additionally have chunk and vprp. I have no idea what that is, but this is only for one chunk. We don't have vprv for the second chunk though. And what's up with all of the chunks though? Some of the chunks are actually kind of big. Maybe they are for some sort of like a padding. Not really sure. And by the way, it was generated by FFmpeg, so it's kind of interesting. Like, what exactly FFmpeg meant by these chunks? Chunk. All right. The stream header chunk strh consists of a v stream header. Right. So, and we already have it. As far as I know, here's the v stream header. So this is how it looks like. So. FCC type and handler. I'm not really sure if I can easily work with all of that, but yeah. So let's actually go ahead and rustify this C header. Let's actually do a rustification. All right, so this is going to be a name. This is going to be a name like so. Rustification is coming. So we already have 4cc. D word is U32. So one thing we'll need is word and also rect. Fascinating. But anyway, so we need to have a word. Let's put a word somewhere here. Maybe, I suppose word is U16. Right, that makes sense to me. How can we crustify, not really crustify, but rustify this entire thing? So let's actually put this kind of stuff in here, right? And just like, and also put a colon in here, like so. And there you go, we rustified the whole thing. We can also query replace this stuff with that stuff. And that seems to be about right. Also, like, there's some problem with spaces, but I don't know a magical way to get rid of all of them. Though one magical way could be just query replacing double space with just a single space, and maybe doing that 2 times, right? So to 2 times and re-indenting everything. That looks more or less good. That looks more or less good. Okay, so can I rebuild the whole thing? It doesn't know what is rect. This is very interesting question. What the fuck is rect? So RC frame. So specifies the destination rectangle for text or video stream within the movie rectangle specified by DW width, DW height members of AV, blah, 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 blah. But what's the type of this thing? What's the type of this thing? I'm really curious. Okay, WinAP rect. WinAP rect. Okay. So it is just rect. So it's 4 longs. Chat, it is 4 longs. Just 4 longs is 1 rect. Understood? 4 longs, 1 rect. 4 longs, 1 rect. All right. So what do we have in here? It's gonna be le struct chocolate and Okay, so this is going to be that, and comma, look at that, long. And the question is, what is long? What is fucking long, mate? What the fuck is long, mate? Okay, so VNP long. Data types. So it's in alphabetical order. Okay, long PTR, long. It's a 32-bit signed integer. The range, okay, 32 bits, so that means we can quite easily say, all right, long 32. Okay, so we're gonna like slowly re-implement the entirety of WinAPI declarations, right? Okay, and it is compiling. Yeah, that's pretty cool. That's pretty cool, actually. So let me see. One of the things we do with a v header, a v main header, is that we also just check its size, and I think it's kind of a cool, you know, trick that we're doing here, just like sort of like a sanity check, right? So it's a signed one. Wait, fuck. God fucking damn it, mate. Can I do S? Oh, it's I. God freaking damn it. Isn't it kind of weird that like signed is I32? In Jai, signed 32 integer is S32 and unsigned one is U32. I think that makes more sense than I32. It's just like I integer, like well, why? Signed. S stands for signed. U stands for unsigned. So yeah. Thank you so much, Minkafri. Rewriting Windows, hell yeah. Well, I mean, I'm rewriting Windows API declarations on Linux, by the way. And I'm not even using Wine. Right, so because what I'm doing is just like I'm recreating the Microsoft format. So yeah. So thank you so much, Dilmon. Technically, integer includes negative. Ideally, it should be I32 and W32 whole numbers. Well, I mean, we're talking about computers, not math. So if we want to be like mathematically accurate, this is not integers either because it's not an infinite set. Right, if you want to go that route, it's still not accurate. But anyways, got him. Math rabbit hole, yeah. So S makes more sense in my opinion. S makes more sense. All right, so what do we have in here? We need to find where all of that stuff happens. Is strh. Where is strh? Okay, here it is. Here is its chunk ID. Here is chunk ID and const str. I'm gonna call it strh. It's u32, and this one is a v stream header. A v stream header. A v, yeah, stream header. A vih. Here's a vih. So strh. So many subs today. Thank you so much, Memphis25 Faust. I hope I'm pronouncing it correctly with the message wowzers. Trousers, wowzers. Okay, thank you. All right, so what I want to do in here, I just want to do size of, and I'm taking a v stream header. So it feels like for the sake of consistency, I also have to capitalize it like that. But I think it would be better to capitalize this thing differently, like so. Yeah, because it's a little bit more readable that way, I think. Just saying. So ck size as u size, and here is an interesting question. Is it going to actually pass? I feel like it will not, right? Because it has a different size, and it will be nice to know what exactly is the difference between them. So does assert accept like formatting? I think it does in fact accept formatting, so I should be able to do these kind of things. Right, so I literally just wanna see their values. You know what I mean? Just show me the values. Though might as well, instead of this one, just use ck. Can you Emacs just jump here? Okay, thank you so much. Ck size. All right, is it going to tell me? 64 is not equal to 56. Right, so that means we have to exclude some of these things. Right, so, and thank you so much for this upkill, Devin. And we probably have to exclude the same stuff that we were excluding from the other header in here. So as you can see, this is the, you know, 4cc. So this is a 4cc type, so this is probably something that we have to exclude. And FCC handler, I'm not quite sure what the fuck they mean by that. Right, so what exactly do they mean by that? I'm not really sure. Because it's a regular chunk, so the next thing has to be the structure. But I can, if I just disable this part, and by the way, this is kind of important. I should have actually done something like this, because like it needs to be padded properly. It needs to be padded properly. So rect, oh yeah, so if I'm going to be using nested structures as well, I have to do that on a rect too. Okay, so right, what do we have in here? And it's still not that. But if I remove this thing, so FCC type, it's still not that. So I have to remove this thing, and only then it's going to pass. Right, so it's now not implemented yet. But the question is, like, why FCC handler? This is supposed to be the size of the structure. This is supposed to be the size of the structure. So, like, what's up with that? I'm not quite sure. Maybe we can take a look at the description and just like, what the fuck is the FCC handler? Let's see. Try to not align it. Okay, how can I pack it? Okay, Rust packed struct. All right. So maybe they have to be packed, but I mean, no, bro. Yeah, so here it is. So an attribute specify the alignment, which can be either C. Oh yeah, so I can just say, can I actually list those things? Packed as a C, pack 1. But I'm not really sure if it has to be packed. Does it really have to be packed? So wrapper packed expects literal integer as an argument, but they say that you can put C. Okay. Which is like, okay, so this is a fucking LLM. All right, so okay, so packed 1, C packed 1. So what n specify? I cannot change, but now, oh my god, could you please fucking, could you stop? Stupid fucking AI. Holy shit. I don't care. Like, give me the actual documentation. Okay, so packed wrapper. Not wrapper 2, but wrapper. Other wrappers. Rustonomicon, of course, because it's dangerous. This is the most important wrapper. Okay, so packed. Okay. Cool. Packed n, where n is a power of 2, forces the type to have been aligned at most n. Most commonly, without an explicit n, repacked is equivalent to repacked 2, which is forced to strip any padding. And okay, so it strips any padding because it's okay. So now it makes sense. Okay, now it kind of makes sense. And if I'm gonna be doing this kind of stuff, so this is packed wrapper and all right. I feel like I'm doing something weird, like I'm not really sure what. I cannot move out of the shared, so it doesn't like something, so it wants something about this derived macro expansion move occurs because value has type rect, which does not have a copy trait. But where is the clone? What the fuck are you even saying, bro? What the fuck are you even saying? Is that because of the debugging here? So the move occurs somewhere here because of... Excuse me, what the fuck? Okay, like... Is the move occurring here? I'm not even sure. Like, why do I have to think about any of this shit? Yeah, so derive triggers that. For fuck's sake, bro. Like, I don't care. Do I have to do some shit like this or whatever? So it has to be, so I have to explicitly say something like ref or whatever. Bro, I really don't fucking care. So shit, what a fucking, oh my god. Anyways, so I still okay, let's go back. A V header is not packed. It is like, it has nothing, okay, it has nothing to do with what I'm working on right now. This header is not even used anywhere. Well, I mean, it's used somewhere, but it's not, it doesn't matter right now. Okay. So, but maybe it does matter, so, but whatever. So it's still 64, packing and... Okay, why did I listen to the chat? Who said packing and unpacking and shit? It has nothing to do with any of that stuff. All right. Okay, so it didn't change any, like at all. It didn't fucking change. FCC handler is supposed to be a fucking size, but it is not. That's the real question in here. It has nothing to do with packing, unpacking, or some other header, like fucking chat hallucinating worse than LLM. What is the FCC header? What the fuck is the FCC header? Optionally, so that's the most important thing. That's the actually useful information. Optionally contains a 4CC that identifies specific data handler. The data handler is the preferred handler for the stream. For audio and video streams, this specifies the codec for decoding the stream. So it's kind of weird, actually. It's kind of weird because it is not compliant with the format of RIF. Because RIF, if it's a chunk, it's supposed to have that size in there, right? It's supposed to have that size. But at the same time, yeah, that's bizarre. Is that even the right definition? Is that even the right definition? Because it doesn't feel like the right definition at all. But anyway, I probably have no choice. I probably fucking have no choice, but just exclude both of them, right? Just simply exclude both of them and see if any of that stuff makes sense. Did they really EEE their own spec? Is it EEE in? I'm not really sure if it's EEE in, but anyway. Okay, so here is the header. Here's the header. I'm transmuting this entire thing into a V stream header, a V stream header like that, and let's indent this whole thing. All right, so, and I just like want to see if it makes any fucking sense here. strh. All right, so this is a bunch of flags and it doesn't make any fucking sense. So doesn't make any sense. So some sort of a start in here. Though, wait a second. Wait a freaking second. So this is the main header. So this is main header, does make sense. This one, yeah. So rect don't make any sense. So the stream header chunk consists of an AV stream header. The stream format chunk, yeah, so something is really fishy in here. Though, okay, W length makes sense because this is audio and the audio is 48,000 samples per second. That one makes sense, which means that this is audio frame. This is audio. So, and it's a length. And this is 60. I'm missing something about stream header. I'm probably missing something about stream header. Okay, so the stream structure contains information about one stream in a V file. So for type that specifies the type of the data, so FCC type, contained in a stream. The following standard AV values of the format audio are defined. And I don't see any of that information in here. I really don't see any of that information in here. Odds, mids, TXTs, vids, we didn't get any of that stuff. So we didn't get any of that stuff. So that means we do need this thing. This thing. You should try parsing it as a 4CC, I didn't think, just saying shit. Okay. So the problem here is that the sizes just don't line up. The sizes simply do not line up. And what I'm comparing this entire thing, like, but it has to be aligned anyway, and 56 is already aligned anyway, so it's not a problem whatsoever. I can disable this assertion. I can disable this assertion and just like hope that maybe it's gonna get interpreted somehow. It's gonna get interpreted somehow. So FCC type. So rate kind of, this is correct, by the way. This is correct. So this is W length. And if I take a look at W length, so specify the length of the stream, the units are defined by W rate, W scale, members of this stream header. You know, I want to be able to just ask, like, interpret some of them as text maybe, or whatever. And maybe I could. Maybe I could, for example, FCC type. If FCC type is 4C, I can always say something like U84. Who said I can't do that? I can do that. Right, and we get this kind of thing, and this looks like a text, right? So looks like a text. How can I just ask it to? This is 4 bytes, but also interpret it as a string. Is there any way in Rust to do that? Probably not. I'm just asking too much from Rust. I'm just asking too much from it. So what was the FCC handler? So again, it's kind of working. And FCC handler is 0, by the way. FCC handler is 0. It's kind of working, but at the same time, it doesn't, like, the sizes don't align. The sizes don't align. Only defining yourself the debug trait. Yeah, we already have a custom debug trait, actually. We already have a custom debug trait. Maybe we can do something in it, but we just have to know. Yeah, we have a generic one in here, right? So we have a generic one. And it's kind of annoying that, like, I would like to maybe put some sort of format compile time information, but I can't really do that. So yeah, I'm pretty sure there's some sort of a third-party crate that implements all of that, and it's like it has a huge ass community. It probably has some sort of a cute mascot. They probably have a very annoying person running their social media. It's a whole freaking corporation that just does one little thing, adding meta information to the fields of the structure so you can print them nicely. That's just very emblematic of the Rust community. So because it is usually like that. Like, people take the very minor market niche and they're trying to blow it up into some sort of like a huge ass corporation or whatever. It's just like, yeah. Holy shit, they have in their own community, and it's just like it's a small little thing. Anyways, so yeah, so the question is like really interesting. For the AV header, I do have to skip this thing, but here I should not, and the sizes do not align. The sizes do not align completely. So what the fuck is going on? What the fuck is going on? So the stream header consists of alright, the stream header chunk. Stream header chunk. And the thing is, so where is the stream header? Even though it kind of like stuff does make sense, right? Stuff does make sense. SK size. And this is the padded size. All right, so this is the size of AV stream header. And we can put like a padded in here. SK size, CK, not SK, CK chunk size padded. All right, and it's already padded. That's the problem here. It's already padded. So what that means is that when I'm reinterpreting the pointer to the beginning of this chunk with that specific structure, right, I'm actually overshooting. I'm literally overshooting. I'm literally overshooting, and that's really, really weird. So why is it size like that? Maybe... But yeah, maybe it does have something to do with packing. Maybe it does have something to do with packing, because we have two words in here, right? We have two words. Okay, let me try to pack it manually. W priority language packed, and it's going to be D word. In fact, I can just say that it's two of these things, two of these words together. Hopefully that will pack it. All right, so did it work? No, it didn't. For two, I'm sorry, I'm an idiot. It didn't change. It really didn't change. So there's only D words. Okay, what if it's just one D word? Can we just count that? Right, so let me see. So I wanna copy paste this kind of stuff. So this is how many 32 bits we have, right? So 12 of them. 12 multiplied by 4, 48, and rect is a long, so it's another additional 4 plus 4, 64. Everything adds up to 64. But another interesting thing is that because of the junk chunks? Maybe there's something about junk chunks that kind of solve that. This is really weird. Like, what the fuck is going on? Like, am I missing something? No, this is not really junk chunks. Right, this is not really junk chunks. So this is strh, strf, right, and there's a bunch of junks in here and whatnot. Huh. Is that a correct structure? Because it feels like maybe it's incorrect structure? Maybe the structs are wrong. Maybe. It could be actually wrong struct, but it says that's what it is. Maybe try this. What is that? A vstream header. Well, it's the same, isn't it? Okay, so here at least we have FCCCB. What's the difference between these two? What's the difference between these two? Okay, so where did you get that? Where did you get this stuff? So this is 4cc, D word. I googled it. Okay. So what's the difference between them then? A vstream header. What's the actual difference? So sync 2. Wait a fucking second. Excuse me? Motherfucking excuse me? What? Microsoft. For fuck's sake. This is a short. Old short versus new long, yeah. So, okay, let me try. Thank you so much. So we might be actually onto something, believe it or not. All right, so where is the rect? Let's actually replace them with shorts. So this is gonna be short, type short. So, and I suppose it's just like it's signed one, so it's a S16. i16. I'm sorry. Okay, so in here, we don't have to pack anything. It's just that. Yeah, so this is going to be 4cc. Thank you so much. Thank you, whoever Googled that. After school chan. Thank you. Holy fuck. And look at that rect. Yes. 800 by 600. 800 by get wrecked. Yeah, thank you so much. Yeah, I just got wrecked. So that was the actual problem. Flaps, you can talk now. So the problem has been solved. So let's continue. All right, so we figured that out. So now we know what kind of shit we can expect from these docs. All right, the game's on, I suppose. The game's on. We know what to expect. All right, so what do we get? So there's a bunch of... So I don't really like these warnings. Can I just say allow the dead code, like literally for everything, allow? So what else do we have in here? So non-snake case. Yes, of course. Don't... it's none of your fucking business. Okay, compiler, listen, compiler. It is not none of your fucking business how I name my variables and types. Shut the fuck up. I decide how I name my functions, variables, and types. It's none of your fucking business. Your responsibility is taking all of that stuff and translating it down to executable instructions so I can run it on my machine. Don't fucking tell me how to format things, how to name things. Stay out of that. Just saying. Just fucking saying. Okay? So allow non-snake case. This should be default. This should be fucking default. Alright, so what do we have? So this is strl, and so rate, I suppose, is 60, which means that this is a video. Right, this is some sort of a video. And here rate is 48, which is audio, right? So this is a very good rate for the audio, and rect, as you can see, is not applicable for the audio. And the sample size is 4, I suppose this is a bytes, and this is because it's a floating point and blah, blah, blah. So I would love to just like literally see this thing as a string, but I mean, Rust will not allow me to do that very easily, unfortunately. Unfortunately. So a new pattern, struct str4 with a custom. Oh, this is a cool idea, actually. This is a cool idea. Let's fucking go. We can call it 4cc. By the way, let's call it 4cc. So it's gonna be u8 and yeah, this is gonna be a struct like so. 4cc. Damn, broski, damn. So yeah. Let's try to do that. And every time we do 4cc, yeah, we're gonna be doing it like that. And this is 4cc. 4cc. So thank you so much, Soviet Meerkat. Thank you so much, Red Santar. With the message, computers are so fast is a phrase that can be used to justify both over-optimizing software and not optimizing it at all. True. That is true. Honestly, I feel like humanity as of right now acts like cavemen around computers. They kind of discovered these magical devices, and they just like literally go ooga booga around computers without completely fucking understanding what they do and how they work and how to utilize them. It's just like, it's literal ooga booga for half of a century. It's mega annoying. Yeah, exactly. It's mega annoying. People form literal cults around computers and around programming computers and stuff like that. And you guys know what the fuck I'm even talking about. They range from programming paradigms towards AI. It's just like, it's like literally cavemen around like a magical device going ooga booga, and it's like that for half of a fucking century, almost a century actually. It is insane. It's like we're not ready for the technology that we created. So it's like a fire, yeah. So how long did it take for humanity to actually like start using fire more like responsibly and more efficiently? It's just like how much time? I don't fucking know. I don't fucking know. Probably 200, yes. Yeah, so... Anyways, so let's go to the compilation errors. So this is a copy, it doesn't like something. Can I just remove copy out of that? So debug is not derived. Yeah, so let's actually have a custom debug for the force. So I'm gonna implement debug for 4cc. Right, so 4cc. Yeah, 4cc I said. 4cc. Let's go. So FFmpeg, this is what we have to get. So this is gonna be that. And in here, what we're gonna be doing in here, I suppose I want to actually interpret this thing as like a hex and a string. That's what I want to be able to do. So from UTF-8, so this is what we have in here. So basically from UTF-8 I take self. All right, I can literally take self actually. All right, and just construct UTF-8, and this is going to be a string, and then I can do U32 from the bytes and just also supply self, and then this is the bytes, and this is str, I suppose. So can I now do write? Maybe just write into FMT, right? This is the thing, this is the bytes, and then we get something like str, like so, boom, boom, like that, and yeah, so that's gonna be it. So, and if it's not UTF-8, I want it to crash. I think it's reasonable here to crash. Okay, so str, no operator found because it's a comma. Okay, so what you don't like, it has to be FMT. Okay, that's understandable. What else do we have in here? So self found for CC, I want to do something like that. Expected found for CC. So how can I call that thing for CC? This is bytes. This is what should have been called bytes actually. So, but we can just call it from bytes. Is it going to work? So this is the pointer expected. Okay, that's understandable. Can I dereference it now? Okay, so expected but found for CC. So this has to be bytes. And we're almost there. And let's. Not bad. Okay, okay. So I did it. At least it didn't crash though, right? And look at this thing, shit. We can literally identify them. Vids, ouds. Thank you, whoever suggested to have like a custom thing in there. I think it's actually kind of cool. And by the way, here I want to actually have like this. Right. So we can properly see everything. Right. So here is the ID. This one is kind of weird, but I mean, at least it didn't crash when I tried to like do from UTF-8, which is kind of surprising, honestly. Though, yeah, I don't know. We can do some interesting stuff. Is that if it's gonna crash on doing from UTF-8, just don't print that part. So, but whatever. I think it's totally fine if it crashes. Yeah, this is cool, right? So you can easily now identify whether it's vids, whether it's not vids, and so on and so forth. By the way, those constants that I'm comparing things with, I think I should call them with small letters because that's their literal sort of like names. UTF-8 Lucy, why? Nothing breaks. Okay, so what do we have in here? This is that, and what else do we have? Unreachable pattern. There is no value for strh, but we do have a value. It's just constant. Because we have a VH. Okay, so are you happy now? Constant should have uppercase, non-uppercase go. Okay, so. Man, look, I just want to call them whatever I want to call them. Like, why? Why are you forcing me? Because the reason why I want to call them, because this is their literal string representation within 4 bytes. It makes sense. It just makes sense, right? It's just, this is their literal representation. I want to call them like that. Freaking let me call them like that. It's just convenient. Don't hold my hands. Don't treat me like a child. I have almost 20 years of programming experience, almost, not there yet. I think next year I'm gonna have like 20. Right, so because according to my best knowledge, I think I started programming when I was 16, so yeah. Anyways, you know what I'm saying? You know what I'm saying? Start treating me like a child. So this is vids and this is outs. Okay. We managed to parse this stuff. That's really cool. So Zozin just found a safety issue in the official Microsoft crate. Nah, don't want to deal with official Microsoft anything, honestly. Oh, even though I'm kind of dealing with official Microsoft something right now, but I mean, I don't want to. So I already have enough of it, so I don't need more. So strf must follow the stream header chunk. The stream format chunk describes the format of data in the stream. The data contained in the chunk depends on the stream type. For video streams, the information is bitmap info struct, including palette information if appropriate. For audio streams, so yeah, now we have to have like this conditionness, right? So if the header was audio, we need to remember that, right? If the header was audio, we have to interpret it one way, and if it's not, we have to interpret it the other way. Okay, so let me close all that stuff because I don't think it's useful. So wave format. So this is going to be bitmap. And I hope it is correct, right? So we hope this particular part is correct. So let's go ahead and just define this thing. So I'm going to have bitmap. Map. Bit. Map. Bitmap info header. Okay, so this is going to be that. I'm going to remove this kind of thing. And let's rustify this mother flipper. Boom. Boom. So here I'm going to query replace double with 1 and one more time. Just one more time, just in case. And I can reindent it. Look at that. Isn't that beautiful? I think it's freaking beautiful. Query replace that with that. All right, so now we have to say that it's debuggable and it's actually something like this. All right, that's pretty cool. So we have bitmap header. If I try to compile this entire thing, is it going to work? Yeah, it is working. Cool. So the other one is for wave. Wave format. Cool. So let's copy paste this stuff in here. Boom. Can I ask, okay, can I ask maybe ChatGPT to automatically do that stuff for me? It's actually faster to do that manually, honestly. All right, so one thing I like to do sometimes with LLMs is that when I need to translate one code to another language or style or something like that, I just say, okay, so you see that? It should look like this, right? And then I start feeding it the other chunks in here. Okay, so now translate this chunk, and it just translates it. And then another one. If it makes mistakes, I say, no, for this one, you have to translate it like that. It says, understood, and I keep feeding it chunks. And that way, I kind of automate like translation from one language to another, or from one style to another, and so on and so forth. Right, so you see what I'm talking about? This is what LLMs are actually useful for, I think, in my opinion. We can give it a try, honestly. We can give it a try. So it's, especially if you have a lot of like this kind of text, it becomes rather convenient. I have code in C that I'm translating to Rust. Here's chunk in Rust. So when you have like not that many of these things, it actually takes more time to explain to LLM what you want to do rather than doing it yourself. Right? So because of that, it's just like not particularly convenient. All right. So, and then it should be like this, right? So I'm going to do Rust, and yeah, I'm gonna be feeding you the rest of the code, and you translate it for me. No yapping, just code. understood. Okay. So, and now we can go to some existing mode. So, what we're going to be using? Okay, let's use GPT-4, not GPT-5. All right. So, understood. All right. And now, so this is a bitmap, and now I can just like take this thing and feed it into that. So, this is going to be C. Yeah. All right. I would have done that manually faster, honestly, but maybe we already kind of pre-prompted it. I can always go back to it, right? And maybe copy paste another structure in there. So this is what LLMs are usually useful for, but you have to like see a trade-off, because like I spent too much time to fucking prompt it in the first place. So sometimes like it would have been faster to do that manually, but if you know that you're going to be doing that a lot for all of these chunks, maybe it makes sense to like pre-prompt it. Yeah, you have to instruct them. Like you're still programming, that's the thing. Like you didn't eliminate programming, you just like now programming in a fuzzy stochastic language, right? Which is not what you want to do in a lot of cases actually. In some cases maybe it's all right, but in a lot of cases, this is not what you want to do. You want to have a formal language, right, in which you're like precisely describing things. Right, and you're still coding. It's just like in a shitty language. You know what I'm saying? Because natural language is not a good language. It's just like a not good programming language. Programming in English, yeah. Like English sucks as a programming language. Don't listen to Andrei Karpathy. English sucks as a programming language. English sucks as a programming language. And I'm pretty sure Andrei actually knows that. Andrei actually knows that. He just needs to sell AI stuff. And that's why he said that. English is too context sensitive. Yes. It's just like not suitable for what we're doing here. It's just not. Well, for this kind of things, it maybe is, but... Well, here's the thing. You can build LLMs not only for English, and not only in even natural language. Like how many people build LLMs that are for formal languages? But if you're building an LLM for a formal language, you might as well just do that in a compiler style where you have like a strict grammar and like a deterministic translation, right? So, I don't know. So, but anyways. So we got this kind of thing. I hope it didn't hallucinate anything in here, right? So it translated everything more or less properly. Okay. Okay, so that seems to be working. So now we have to kind of maintain this state as we parse this entire thing. So that's the thing. We need to start maintaining this state. And the way we're going to be doing that, right? Dump. I want to rename this thing to something like dump AV instead of dump content, right? So because that's what we're doing, we're dumping AV, right? And we are basically going through the chunks. The chunks that we care about here is the HDR chunk. I suppose, yeah, here is the HDR chunk. If the chunk here is HDR, what we can do is maybe just have a separate thing here called HDR. So pub fn dump HDRL, right? Because that's what we have in here, HDRL. So, and inside of the HDRL, we're going to be expecting the header and then strl and another strl. And then junk. Like, I'm really not sure what's up with all of these junk things. But anyways. So this is immutable content, which we're dealing with in here. So this is U8. And yeah, we also have a level of this entire stuff. So this is HDRL. And inside of it, we are kind of expecting another thing. So by the way, can I just have a special padding thing? So because I want to have something like extract padding, which is useSize. And when I'm trying to print this padding in here, like so, I can just put padding level multiplied by 2. I think that's a good thing to do in here. You know what I'm saying? You know what I'm saying? Something like that. So, and by the way, this is a list type. And this one is interesting because this is a chop for CC, right? So this is chop for CC. But it doesn't return you for CC as this specific type. I want to call this thing more like chop U32, and I want to be able to construct for CC out of U32. I think there should be a way to do that, believe it or not. I think that's a cool idea. So let me do something like this, U32, like you chopping this kind of thing in here, and on top of that, we're going to be doing implementation for CC, right, from, so fn from U32. You accept a value U32 and you get self. So something like that. So, or does Gustavo, thank you so much for the sub. Thank you, thank you, thank you. Does Rust have onions? It has enumerations, right? So which are like onions, right? So because you can have full, and this is going to be full, 32, and then bar could be string, and so on and so forth. And it's just like, you know, onions them, right? That have onions, yeah. European onion. So this is chop for CC. This has to be actually chop U32. So we're going to do all of this stuff. So what else do we have in here? So we don't have padding, or at least padding is not printable. So what we have to do in here is implement padding. Implement, what's that? Display for padding. It's going to be FFmpeg display for padding, and it's probably going to tell us to get the, what is it called, method. Right, so let's put this method in here. So this is FFmpeg, this is FFmpeg, this one is like that, FFmpeg error, and let's put this stuff in here, and here we can do write FFmpeg empty padding, as empty is just this, padding is whatever we have inside of padding, believe it or not. So we can even destructureize it. Padding self, like so, and that's it. So that allows us to display things like that. So this is unused, this is unused, this is unused. What else do we have unused? There's a need to be mutable, shut the fuck up. All right, so when the padding works, by the way, so having this kind of padding works, and I suppose we don't even need this stuff anymore. So now every time I need to pad something, I can just do it like that. Right, so I can remove that, boom, boom. So this is that, and this is just padding, level 2. Right, chunk, list. So here we are doing padding with indent, so we don't have to do anything special in here. All right, so is it still working? Yes, in fact, it is still working. So inside of this thing, I can always just try to maybe multiply by more than 2, right? So just to test, let's multiply it by 8, specifically lists. And lists should go off the chart. List, we don't have nested lists. Is that what's going on? Oh, this is kind of interesting. So, oh yeah, yes. Okay, so here is the list going off the chart. So this is a good example, by the way, right? So this particular padding strategy is working. I really kind of like that. I really kind of like that. So because you don't have to think about like this weird syntax, you just contain it within this trait, and that's it. Also, you only have padding in here, so that makes sense in my opinion. That makes sense. So and in here, by the way, we can do the for what is it called? For CC from uint. So essentially, what we can say. So this one could be for type, but it's a for type for CC, and it's going to be is for CC, and this one is going to be for CC. So for CC from U32, and this is just a list type. This is just a list type. And now we'll have to implement this thing. All right, so for CC is not implemented display. Oh, this one is interesting. So for CC, we only implemented debug, but we didn't implement display. And I wonder if, can we just like implement only display for this thing? And it will debug just reuse this thing. That's a very interesting question. Right, I have implementation of display. And then can I say, okay, derive debug. And will debug then do the same thing as display? Probably not. It's panicked with not implemented because it failed in here. Yeah, okay, so we'll have to implement this thing first. All right, so I need to convert that to lebytes. Right, we converted that to lebytes, and lebytes is going to be like literally 4, which means I can just like do self, and I think that's the entirety of the implementation. Okay, so where are, yeah, so for CC, for debug didn't work out, unfortunately. It didn't fucking worked out. So, but I want it to be literally the same. So the only way I can probably achieve that is by literally implementing a custom debug trait, right, which just forwards this entire thing. Well, I mean, I can always do something like self. How can I interpret it as a display? Right, so can I do FMT, FMT, but then I can explicitly say use the FMT, which is from the display. How can I reinterpret it like that? Does anybody know Rust in here? Yeah, it goes into infinite loop, so you can't easily do that. But I mean, one thing I can do always, obviously, FMT, and it's just like self. FMT display, okay, so FMT display FMT, but then I have to supply self and FMT, right? And it, okay, so that works. Okay, so that I can always not use the method syntax, the dot syntax. I can explicitly just say, okay, so that makes sense. All right, thank you. Thank you so much. Thank you, thank you, thank you. So because I want debug and display to be the same thing, right? So because it does make sense in here. So list type, just a second. So list, here it is. And in here, what we have to do is just print this entire thing like that. Right, so this is the list type, and this is a 4cc. List type 4cc. Okay, that's pretty cool. That's pretty cool. So interestingly, maybe we can even get rid of that. So something like this. Yeah, look at that. So here is the padding, and then here is the 4cc, and we just like interpret it as 4cc. Yep, that's pretty cool. We can always have some shit like 2, U32, which is self, maybe even taken by reference in U32, where we just take lebytes, right, and we do from lebytes, and it's going to be U32 from the bytes. Here's the bytes, and we just return this entire thing. So is it going to work? Yeah, so you have to dereference the whole thing, and that seems to be working. So honestly, I mean, we can just pass it by value, right? So there's no need to even work with any of that stuff. So, all right, from U32. So this is one thing I wanted to fix in here super quick. So then another one is going to be, so CKID str. So this is just that. CKID str is simply for cc from U32 CKID, and that's it. So that simplifies that part. That simplifies that part. And that's about it. Okay, so we're slowly building up a framework for parsing a V. So in fact, this may become some sort of a library for parsing a V, which is kind of cool, I think. Right, so all of that seems to be working. All of that seems to be twerking. Okay, kind of cool. So, but anyway, now in the chunk, just if we encounter a regular chunk, and that chunk is specifically a v-header or HDRL, right? HDRL. What we have to do, HDRL, we have to do something like a dump HDRL. So that's what we have to do, dump HDRL. So how are we going to be doing all of that? So this thing is, yeah, it expects the content and it expects some other thing and so on and so forth. So we have chunk size. We have chunk size. And we also have chunk padded. We can take the content starting from 0 up until chunk padded. So I'm going to take the padded one. So I'm going to take the padded one and level +1. So we dump in HDRL and then we do content, content like so, which is, yeah, starting from CK padded like so, up until the end. So then we actually automatically do that. So I don't have to do that in here, honestly. I don't have to do that in here. So effectively, what we do is that we go kind of deeper. We go kind of deeper. And so that code is probably gonna move into dump HDRL. So that's probably what's gonna happen. So yeah, let's actually go ahead and try to compile. Dump HDRL. So what does it say? This statement is surrounded by body. Okay, that's understandable. So what do we have in here? So it has to be a reference. Understandable. Cool. So it says something. Yeah, it's unreachable. Unreachable patterns. So I'm actually surprised. Why does it think that it is unreachable now? No value can reach. No value can reach here. So what did we have before? Wait, that doesn't make any sense. Because we don't have HDRL. Okay, so yeah, so it just simply doesn't exist. That's why. HDRL, because I literally don't have this thing in here. So maybe there should be some sort of a way to construct 4cc out of string literal. That would have been kind of cool. So then I don't have to like depend on these kind of constants in here. So HDRL is this one. Right, so it's a main. So what is it called? Is it called, yeah, HDRL begins with the main header. Yeah, so it's a v and it's a main header. Right. So well, I mean, it's understandable. It's a v header. Okay. So that's interesting. So now, what do we have? You know what I'm thinking? We should have a similar thing called chop chunk. You know what I'm saying? You know what I'm saying? Chop chunk. Chop chunk, chop chunk. And it kind of asserts that the chunk is not list. That's what I want to do. You know? So we have chop U32, but then let's actually have something like chop chunk. It accepts the content by immutable reference, like slice to U8 by immutable reference, and it shall return you a chunk, but the chunk will have like an ID of some sort. In fact, it probably makes sense to introduce a chunk type, right? So it makes sense to introduce a chunk type. So chunk, and so what do we have? A CK ID. So we have an ID of the chunk, which could be 4cc, right? So I think it's reasonable. And also we have a size, but I mean, we can just store a slice in there. It could be just a slice. So we can say that it's like a content in here. And here comes the fun part. I want to refer to this freaking content as a reference. I fucking hate this language, honestly. I truly fucking hate this language. It's such a fucking stupid ass language. Who knows what that means? Who knows what that means? That means the code is about to get 1,000 times more fucking annoying. You know why? You know, you can't just store reference and structs because fuck you. You can't just store reference and struct. You have to explicitly start specifying a fucking lifetime because, again, fuck you. For even thinking to do something like that. Oh. Lifetimes will be everywhere. And it's just like, I don't fucking want to do that. Like, I just don't want to fucking do that. But I mean, okay. Or you can just clone. Bro, like, why the fuck do I need Rust if I'm gonna be cloning? I might as well just program in JavaScript at this point. Arc and so box and so, like, again, like, why the fuck do I need Rust if this is the thing I have to do? I might as well just use Java or C#. Like, why? Anyway, so maybe it's gonna be fine. I don't fucking know. So that means I have to. Maybe it can just like derive it automatically. I don't fucking know. Can I just do something like that? I can never fucking understand. It's so stupid. All right. So expected lifetime. Like yeah. You can't fucking do that. All right. So and in here, I suppose the lifetime is the same as the lifetime for this slice, right? So that's what we're doing in here. Yeah. It's the same, it's the, yeah, let me see. Anyways, so what we're gonna be doing in here, I wanna chop U32, right? So I'm chopping U32. And I'm passing the content in here. Passing the content. Okay, so that gives me the possible ID, right? The possible ID. We can assert now that this ck ID is not equal to list. It is in fact not equal to list. So then I can do ck size, right? So this is basically the size, and I just like chopping this out of the content. And might as well actually, that doesn't have to be a like prefix like that. It could be just an ID, and here it could be just a size. So, and now if I want to have like a chunk result, I can maybe do something like this. So ID is going to stay like that. The content is, okay, content starting from 0 up until size, and you have to be careful, right? So we're probably gonna include the padded part. Like, okay, so let's try to pad it. Size, padded, right? So padded. Pad size as 2, right? So that's what we have to do. So this is a size as usize, and this one I can just say this is usize as well, right? So that's fine. So padded by 2. So this is padded. So I'm gonna take this part, probably. I'm taking this part, and then I'm gonna do the skippage. And I'm going to skip actually the padded part. Right, so size padded, because as per specification of AV, right, as per specification of AV, and here is the chunk. So something like that. Hopefully it may work. Right, so let me see. ID mismatch type. Okay, so that's understandable. Oh, it's 4cc. Okay, can I just do something like 4cc from U32? That means I won't be able to easily convert it. Okay. 4cc from U32 and its ID. All right, so what else do we have in here? Expected chunk. Okay. Fucking Can you be fucking normal? Okay. Mismatched type. Okay, so now this one has to be like this. Okay. So what does it say? It's a private. It doesn't have to be public, honestly. Fucking. This is not a serious, like how is that a fucking serious language for any serious system development? Like, for fuck's sake. Like I don't fucking understand. Like I'm not doing any useful work in here. I'm just shuffling characters around. Anyways, so dump HDRL. Dump HDRL. So chop chunk. Okay, so this is that, and this is that, and I get the chunk, right, of some sort. So this is a little chunk, and inside of the chunk, so what I expect this chunk to be, I can actually do something like 2u32, right? I mean ID. And I can just try to print it. Let's try to just print whatever we got in here. So this is going to be that. And so this is padding, right? So this is a padding and it's a level. Why are you putting $$ in here? Right? So, and this is more like HDRL. And I just want to see the thing in here, which is going to be chunk ID. Just chunk ID. All right, so let's go through the content, find blah 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 blah. Okay, so it's going to be mutable, and this one has to be like that. All right, so but it didn't. Why did it go further? HDRL. It never actually catch. It has to be a list type. Here is the thing. I'm in the wrong place, chat. I'm actually in the wrong place, but I mean, yeah. So. List type. So this is the list type. So that means here what I have to do, if list type is equal to HDRL, we have to dump HDRL. I mean, I might as well just copy paste the whole thing. HDRL. Otherwise, just do something like that. Okay, cool. Okay, so here is the avich. That's very cool. So, and we can even, yeah, so we go through these things sequentially, and according to the spec, the next thing right away has to be avich. It has to be avich, which means that we can literally assert that this thing is avich. Just assert that. And inside of avich, we can just look at this header, right? So where is avich? So this is kind of cool. All right. So here we are asserting another interesting thing, that the size of the chunk, and the size of the chunk is in fact content length, is equal to the size of the AV main header. Then we are literally transmuting the chunk content, right? So we're just looking at it as a pointer, right? So we're transmuting that, we're indenting this entire thing, we have level and everything. Yeah, so that's pretty cool. So yeah, let me see. So it's semicolon, understandable. What does they want from me? ID is for CC2, U32. That's fine. Cool. So we're already working with all of that. That is very fucking cool. So we probably don't need to do this +1. We can just indent it as is. So that is very fucking cool. Okay, now I'm chopping the next chunk. I'm chopping the next chunk, and in here, let's see what we've got. So this is going to be padding. It's a level multiplied by 2, level multiplied by 2, and in here, the second thing we're gonna do chunk ID. Right, we've got so after that, I didn't see shit, honestly. It's not equal list. So yeah, after that comes the list. Comes the list. And that means now I need to have a similar function to chop chunk, but chop list. So I can explicitly now expect and assert something. What is ID for CC and not U32? For CC and U32 is the same thing. It's just like you interpret and view it differently. It's literally the same thing. Don't think about it. So chop list, and it's going to be something like that. And in terms of, honestly, there's not that much difference between, well, I mean, there is some difference between chop chunk and chop list. Yeah, so we have to introduce something like list, and we probably have to prefix them with a v and stuff like that. So we have type list. Is there something like a type? Like, how do you have a symbol which is a keyword? How do you escape that in Rust? Does Rust have some cool shit? R type. Okay, so R type. Is that how we do that? Okay, I'm gonna trust you on this one. So this is gonna be type, and for the type, let's also keep a 4cc in here, and also there is a size which is basically content, right? So it's kind of similar to that. Okay, so what we're gonna be doing here is kind of a similar thing, honestly, kind of a similar thing. So this is gonna be chop list, return a list. So we get an ID, and it has to be equal to that. It has to be equal to that. So then, where is the list? So we have size, and we got the size. We don't care about being padded, and we need to have the type. All right, so there's the type. So, and the type, I suppose, has to be something like 4cc. So 4cc from U32. So we get this kind of thing. Type and this one is interesting. Yeah. So here we chop U32s. Here we chop 3 U32s. So that's basically what manifests the list. So in here is the list. ID. By the way, we can always construct 4cc out of ID right away. It's not that big of a deal. It's just like then later here we can assert something like that. You can convert between them, doesn't matter. Okay, so that allows me to do something like this, right? So this gives me ID. Then I can have type. I hope that will work. So here, this is just size of the entirety of the list, and we just return the list. So this is what we have in here. So chop chunk and chop list. Chop chunk and chop list. So list, this is that list. All right, what does they want from me? ID has no ID. That is true, actually. So, so mutable content is already mutable. And okay, so that seems to be working. That's pretty cool. So that's the main difference. I'll probably also need another function that basically returns either chunk or either list, which means that maybe we can combine chunk and list into enumeration, right? So it could be a union at some point, but we're gonna do that a little bit later. So we now fail somewhere here. So there we go. So because we tried to use chop chunks somewhere where it should not be chop chunk. Okay, so it has to be chop list. So this is the list, and this is the list, and in the list we got type. We got the type, and do we even see anything? So I probably want to do something like HDRL list, so I can clearly see what is going on. Yep, so here is HDR list, and the type of this list is strl. So strl, and yeah, and by the way, we can probably even We can probably even assert that. Do we have strl? Let's have const strl u32 like that. So what do we have? strl. So the thing I want you to do in here, I want you to assert. I want you to assert that this thing is strl, right? This thing is strl. So after I asserted that this thing is strl, I need to go deeper. So I need to expect strh and strf. Right. So what I have to do now, I have to now do something like dump strl. So in here, I'm just going to do content of that inner strl. So, and there could be several of them, I think. Actually, yeah. So as you can see, there could be several of these strls. So that means when I'm dumping this entire stuff, I kind of have to look ahead. So there should be something like check, right? It should be something like check, but not necessarily, actually. What we can do, we can run all of that stuff in a loop while we have some content, right? So essentially it could be content length greater than 0, like so. Then we chop in the list, and then we're processing that dump strl. So that's how we can be doing all of that stuff. That's how we can be doing all of that stuff. So pub fn dump strl, and this is kind of similar, right? So the most annoying thing in here is that I can't do like that. It will complain about some stuff in here. All right, so dump strl, yeah, it takes this stuff, so we have to do plus level 1. Yeah, so it says a warning, and then it will demand me to remove mute. Right, well, I mean, it didn't demand me to remove mute, which is nice, actually. I really like that. Okay, so it fails in here. So, and inside of strl, we have to have strh and strf. Both of them are kind of important, right? And that's the thing I was talking about. Is just like, depending on the type of strh, the strf has to be interpreted differently, right? So we finally get to this point where we can actually do that, right? So we can actually do that. So we already can compare a vih, so that means I don't really need this stuff in here. So let me see. Lib AV format in FFmpeg, which parse AV format, was authored by Fabrice Billard, well known as being the QEMU author. As far as I know, he's also a FFmpeg author. He started FFmpeg. I don't know if he still actively contributes to FFmpeg, but he also started it. So there's a website of his, where there's a list of all of the projects he started, and yeah. Didn't he started it? Right, so interesting. This is a legendary person, honestly. Not that many people, like, he's not super famous. Not that super famous. Like, people, like, right people know him. Right people know him. But he's not really that well known to wider tech audience. Right. He's not really that known to wider tech audience. But at the same time, he started so many projects that are mainstream, essentially. Things like QEMU, FFmpeg, TCC. Well, okay, TCC is not that mainstream, right? But a lot of things that is just like freaking crazy. So QuickJS, yeah, QuickJS. Speaking of, like, it's insane, and it's really interesting how he's not really that well known to normies, which is kind of cool at the same time. I want to be like that, honestly. So yeah, this is really cool. But anyways, so I think I need to give the link to his website in the description. Yeah. So let's continue. Chat. So a v.rs. So strh, right? So now we need to parse strh, and as I parse this strh thing, I need to do the similar thing, actually. Right. So strh, I can copy paste this code. So I'm slowly moving that code to a different place where I have more control over the situation. So this is the assert. This is the assertion that I want to make. Then I take a header. So this is a v string header, strh, and I'm just printing this entire thing. So yeah, this one doesn't need to be. Okay, what else do we have in here? So level, it doesn't have to be a pointer. I do agree with that. So, and let's bring all of that stuff in here. So what else do we have in here? CK size. So this one is simply replace chunk, replace CK size, chunks, content len. That's what it is. And it's obviously not going to work. Okay, so let's get rid of that message. It's not really useful anymore. We already know how all of that stuff works. Chop chunk, difference in mutability. So, all right. And in fact, we got everything. So it indents too much, I think. So why does it indent so much? I'm not quite sure. So this one indents like that, and this is strf. So this is FCC type and strf. FCC handler. It kind of went too far. What am I I'm transmuting the wrong thing. I'm supposed to transmute this thing. So it's gonna be chunk content as point. Yeah. Now we're talking. So why is it so? Oh yeah, I know why. Because this thing is inside of the main header. That's why it's more indented. So, and this is vids, by the way. And this is what I was talking about. So now, now, chat, come down. Const vids u32. So now I can assert that this is vids. If header FCC type 2 u32 is equal to vids, I have to now treat the next chunk as bitmap header. See what I'm talking about? I have to now treat it as a bitmap header. And if it's not, I have to treat it as something else. By the way, I feel like we have to factor out conditional parsing. Yeah, so this is what I was not able to do with just recursively doing things. Right, so, and I have to like explicitly reorganize the code. So we need to factor out this code into a separate function. So something like chop struct, right? Chop struct. Let's quickly do that. I think it's kind of, yeah, I think it's kind of important to do it like that. So strh, is that a good idea to do it like that? So because I'm doing this kind of stuff, right? I'm doing this kind of stuff, and I'm not really sure if I want to do it like that. So let's do a different thing. Let's have a function. I don't really know how to call it. So, but it's gonna accept the chunk, which is just chunk, and yeah, it has this kind of shit. And it's going to return the type. Right, so we're also gonna accept the type we want to put in there. And it's going to return maybe a reference to that specific type. All right, let's call it transmute chunk. Transmute chunk. Something like that. I don't know why it's public though. So, and this is what we're going to be doing in here. So it's just two simple things. We're going to be asserting, yeah, it's just like literally T. Yeah, look at that. This is cool. It actually kind of fits perfectly into what I'm doing in here. Yeah, so it's unsafe, and I do mem transmute. So that's cool. That's actually super cool. So that means I can easily do things like transmute chunk, stupid ass Emacs, transmute chunk, a v header, and I just put chunk in here. And it's just much more readable in my opinion. So chunk ID is this ID, and that allows me to transmute that chunk to this header. Okay, so that seems to be working. It doesn't really work. Well, it has to be le fiche operator. So chunk partially moved. Motherfucker. Okay. So do I have to like pass it by a reference then? Do you want me to pass it by a reference? I can pass it by a reference. What the fuck do you want from me, motherfucker? I mean, what's wrong with moving that chunk, honestly? Like, what's wrong with moving it? I don't understand. But I kind of want to copy that chunk. Okay, listen. It's a very lightweight thing, in all honesty. Yeah, 2ID is moving chunk. Fuck. It's 2U32, I mean. Why do I have to think? This is and we're talking about primitive types. Bro. I just checked a fucking primitive. I converted one primitive type and it's already partially moved. How is that a real language? This is not a real language. Like, I just... Like, I'm speechless, honestly, by how... Like, I don't want to use bad words. And it has nothing to do with safety. Like, why is that partially moved? Stupid ass language, I swear to God. Anyways, yeah, so we got there. All right, so we can do transmuting here. I should start using this kind of thing a little bit more. So this is a transmute struct, transmute chunk, a v main header, and that's the chunk, right? So, yeah. It's a primitive type. Like, moving of primitive types should not be a thing in Rust, in my opinion. Like, so it's just like it shouldn't be a thing. But why is it a thing? I don't fucking know. Okay, so if it is a vid, right, we can now start chopping different things in here. Right, if it is a vid, I'm expecting strf first of all. Right, so let's actually go here, and this is that. That's basically what we have. So strf, well, partially named constant is not defined. Okay, so let's print ln. So to do, and this is that. So padding, I'm gonna put that in here. Padding level multiplied by 2. And what I want to do in here, I would just want to take a look at ID. Right, I want to take a look at ID. Yeah, remove that. So, and it's strf. Let's take a look at strh. Const strf u32. All right, and then where's the to do? Cool. But honestly, I think strf chunk comes regardless of whether it's vids or not. Yeah, so I think that is true. So if it is vids, we have to interpret that thing as that. So header now is this one, transmute chunk. This is header and this is chunk. Okay, so now I'm going a little bit deeper. Stream header, and this is that. Okay, what else do we have in here? Yep. Okay, so bitmap info header minus why? It is correct. Well, I mean, why is it a negative one? Interesting. But I mean, it's kind of correct, but it's negative changes origin. Bitmap hides R-1 in Windows. I never knew about that. But in any case, thank you for telling me. Huh. Alright. So there's a main header. This is the string header, string that, and blah blah blah. Okay. So interestingly, I feel like strl. So when I'm calling dump strl, I think I need to actually print that this is a list strl, right? So it has to be padding level 2, right? And this is a list, and that list is going to be that, which is simply this. Yeah, I want to be able to see that it is in fact strl. And they're on the same level. So here comes the header, then strl. Inside of it we have header for the vids, and here is the vids. And now strh, where is it? I'm in the wrong place. strh, strh. And by the way, this stuff should actually go away. All of that doesn't matter. All of that doesn't matter. So strh, where is strh? So bitmap, this should go away, and we should crash somewhere in here, hopefully. Okay, so what do we have? It doesn't show the whole stack trace, so we have to, can we do rust backtrace? Why is it behind an environment variable? I don't quite get it. I don't quite get it. So this is that, begin environment panic, dump, okay. Oh, is that because I never built it with debug information? That's why it's never showing me? Okay, so one more time, chat, one more time. All right, so finally it is showing me something. So it doesn't jump there. 241. Yeah, what fuck are you saying? All right. So strl, if you take a look at strl, there should be then strf, and we did get strf, and that should be it. So one thing we want to assert in here, by the way, I want to assert that there's nothing else in here, right? So content, like we consumed the entirety of the content, didn't we? Right, so we consumed the entirety of it. And I suppose that is not going to be true, is equal to 0, because there's some junk in there. There's some junk in there. Honestly, I need to separate dumping and parsing, because as of right now, what we're doing is more like parsing than dumping. So more like parsing than dumping. I'm a little bit tired, chat. I need to make a small break. So let's make a small break. I'm gonna make a cup of tea and we're gonna continue doing this kind of thing. So there's two things I want to be able to do. I want to be able to just dump the tree of the things, of the chunks and lists, and also parse. And I'm just kind of doing all of that stuff simultaneously, which is not a good thing. I need to decouple these two processes because I want to be able to flip-flop between these things. Like I'm looking at the structure, just overview of a structure, and then try to parse this entire thing. Right, so we are back, my friend, we are back. So what we need to do, by the way, we need to be able to not only chop specifically list or specifically chunk, we need to chop anything, right? So we probably want to be able to do something like enumeration. And how can we call these things collectively? What's the collective name for both chunks and lists? So ref format is based resource interchangeable manner, consists of ref header followed by 0 lists and chunks. Okay, so what's the collective name for both lists and chunks? List or chunk? List or chunk? Chist. Chlist? I don't know. List or chunk. And this is gonna be chunk. So collection, it's still too long. You guys suggesting too long. Node, okay, this is a good one. Sure, this is a node. And this one is going to be list. And this is going to be like that. Something like that. Entry, might be an entry. Entry. So let's go with the entry then. And here we're gonna just chop an entry. Chop entry A, content, mutable, reference to U8, and you get the entry which is A. Okay, so that's cool. What we have to do, we have to now combine together these two things somehow. We'll see how it will go. So yes. So the first thing we do, we chop an ID, and then here is an interesting part. We are comparing whether it's a list or not list. If it is not list, all right, we do that part essentially. We just do that part. This is not a list. And in here we have to return entry chunk. If it is a list, we need to find chop list. Chop list. We do this part. All right, like this. A little bit of a copy pasting, but that's totally fine. We're gonna soon compress all of that code. Okay, so you see what we're doing here, and now we can implement chop list and chop chunks in terms of these things. Just in terms of these things, because we already have this code. Yeah, that's kind of cool. All right, let's try to compile this entire thing. Seems to be compiling, right? So it's failing with this stuff, which is totally fine. So I probably want to just compile it. All right, just compile it, just to see if everything's fine. So chop list. Where is the chop list? Now what I can do, I can just match. Match chop entry content, and here if I encounter entry list, I just return list. Otherwise it's just unreachable. So that's it. So we kind of factored out these two implementations into a single function, and where we factored it out now it's implemented in terms of that function. So it's much better, I think. So now you can choose whether you want to specifically expect list, or you don't know what you're expecting, so you just chop an entry in that case. You just chop an entry. Okay. So let me see. So this is that one. We chop in an entry, but in this case it has to be a chunk. So we just return le chunk. That's it. So, and does it compile? Yeah, it does compile. So now we can actually sort of like choose. So it should become very easy to implement dump content now. I think it should be super easy. So let me see. So let's call it something like dump a v as tree. Something like that, right? Dump a v as tree. And if we take a look at a v, right, it has a header, it has list, and it's kind of difficult to say, right? So we say that it is a v, and then it's just a sequence of entries that we're just parsing. Okay, so that's fair enough, I suppose. So in here, we're going to be accepting le content, all right, and we just do chop entry content, and we just do a match. Is that a list or is that a chunk? All right, so entry chunk, and this is your chunk. Is that a list? And this is your list. In case of a list, you have to go like inside. So I want to actually copy this kind of thing. So here is the list. We say that it's a list. You have list size. So this is the padding. So list size is essentially list content len. That's what it is, list content len. And then we have list type, which is list r type. That's what it is. So, and that's about it, I think. And after that, we do dump av s3, and we're just using content, but with the level +1. So this is how we recursively can parse all that stuff. Okay, so, and for the chunk it's going to be slightly differently. So this is le chunk, and it makes it super easy to just iterate that. So we slowly building up a machinery for iterating those chunks and everything, which is kind of cool in my opinion. So chunk ID. So this is the padding. So then we have to have chunk length, which is chunk content length, right? Chunk content length. Then we have chunk ID, a chunk ID, and I think chunk ID specifically, whereas the struct for the chunk, it's already for CC, so that means I should be able to just do it like that. So it's a chunk size, chunk ID, like so, and it doesn't need to be like a recursive in here. And as we parsing, yeah, so there could be several of these things in here, which means that we have to do something like content len greater than 0, and we just like recursively repeat this entire thing. So that's how now you can iterate a binary file recursively. So we've built it enough machinery to just be able to do that. So we accept slice of bytes, and using chop entry, we just recursively like traverse it. This is kind of cool. It is really kind of cool how we build this machinery. I really like that, honestly. Like, what the fuck? It's rather convenient. So chop entry, right? Chop entry chops U32, then we check the kind of type. Like it's rather convenient. Like, what the fuck? And it's actually progressive, right? So it's not pre-parses everything. We progressively just parse those things. It's kind of cool. Damn, broskis. Damn. So, and in here, what we can say in here essentially is just like a dump av s3. So I just provide, what was that? The content, right? So the content, and I provide the entry, and then I can just compile this entire thing. Obviously, something didn't work out right away. So type, if I remember correctly, type was already for CC, isn't it? I didn't catch that. Yeah, it's already for CC, which means that I don't have to do this kind of stuff. So, and this is more like list type. Okay, so we're almost there, I suppose. Take it by a mutable thing. There we go, that seems to be working. All right, that's really cool. It's really fucking cool. Okay, so FFmpeg for you. Let's go here. FFmpeg for you, V. And yeah, something didn't work out right away, and I'm really curious what exactly. So it kind of worked more or less, but I didn't expect that it's going to fail in here. So it failed. It couldn't get some stuff. So let's see where exactly. So it's 14. 298. So yeah, something didn't work. Something didn't work. I'm surprised. So we managed to parse this thing, but then, damn, this is going to be annoying to debug. It's going to be annoying to debug, but at the same time, yeah, so you tried to... It should have stopped, honestly, at here, essentially. Shouldn't it? It should have stopped at here, right? Because if it's 0, you should not go there. So then this is the list content, and we go recursively into that. Yeah, it feels like it simply failed to stop. Right. It failed to stop in here. So does anybody know what's up with that? Right, so it was parsing this thing, right? It even found like a chunk, and then it is supposed to stop in here. It is supposed to stop in here when it reaches the content length equals 0, but it didn't. And then it failed, tried to get index out of the slice of length 0. Yeah, so that should have been prevented. So condition in here doesn't work out. Like, I'm not sure what the fuck is going on. So let me maybe try to do something like this. Just to get an idea. You know what I mean? Just to get an idea. All right. Okay. So yeah, I would expect to... I don't get it. If you add all length of chunks, does it equal total size of first block? I don't know. All length of chunks. Well, it should probably. I'm missing something stupid, chat. So this is not the problem, right? So I'm just missing something very stupid. Yeah, it doesn't add up. Like, okay, it's cool, but like I'm missing something in here. I forgot to do something. So it's just like it's not about that. What did I forget to do? What did I forget to do? That's the most important part. So I get the idea. It's not a list. That means it's a chunk. I chop another one. Okay, I pad it, and then I skip the content. Did I forget to skip the content anywhere? I don't think so. Right. So this is totally fine. This is list. If this is list, well, this is chunk. If this is list, I chop this content. Then I take the type of the list, so the size and the type of the list. Is that true? List size and list type. Okay, so list size and list type. Right, then I'm taking the type, and this is the size of the content, right? So size of the content, and this is the rest of them. So I skip. So this, everything here is correct. So ID in here, this skips the padded one, but it doesn't. Okay, so this one is correct. So everything is correct in here. Something like I don't like, it's something stupid. I'm telling you, it is something stupid. It managed to successfully do that, and we kind of ended up with 4 bytes in here at the end, which doesn't make any fucking sense to me. So here's the size. Is 68. Yeah, it is aligned. Everything is aligned in here. Yeah, so list, might as well even for, man, like I hate issues like that because they're extremely annoying to debug. Like I don't really know where I just forgot some character or something like that, because this should not happen. This just should not happen, but it's happening, so that means I did something very stupid, and it's just like, where did I make a mistake? And it just drives me crazy. Like it's insane. Right, so we consumed that, consumed that, yes, consumed that, reached that. Annoying, fucking annoying. So like I'm already phasing out. So what did I forget? What did I forget? So everything is fine in here. So this is ID, size, type, fine. Oh. Chop list or entry. So size should not include one thing in here. Okay, so you feel free to continue talking now. I found it. Told you, something stupid, something fucking stupid. Like I knew it. I fucking knew it. Right. Forgot one thing. Forgot one little thing. Okay, so let's continue. So that's pretty cool. So now we have an ability to just dump them, and then the rest of the stuff here is more like parse. Right, so here I would like to call this thing more like parse, parse AV. So the thing about parsing AV is that the first has to be list, right, list HDRL. So that means here I have to do chop list specifically. I'm expecting list specifically. So it's going to be list. Where do we do chop list? And in this specific list, I'm asserting list R type to U32. What the fuck is that? HDRL. Okay, so here we can do that list thingy. I should be able to maybe just print this thing. When I format the list, I should be able to just like, yeah, print that. But maybe I can. Maybe I can just use the debug in here. Just a second. Can I just do println and padding? So this is the padding level 2 and Emacs, go here and then just do list. I should be able to do this kind of shit. By the way, speaking of, maybe this is literally what I should try to do here. I want to try to do this thing here instead, where I just level 2, and this one has to be chunk, but as debug shit instead of all of that stuff. You know what I'm saying? Chat, you know what I'm saying? Yeah. This one is going to be list. Can I do that? Is it going to look good? What are you saying even? Oh, it doesn't exist anymore. Whatever. I don't care. This is gonna be a throwaway code anyway. Okay, so there's no debug on the structure, of course. Derive debug. List derive debug. Okay, you happy now? That's shit. It's shit because it prints the content. This is not what we want. Okay. Though it would have been kind of cool if it's like maybe just contracted the content, so to speak, but I don't know. So we have to do that stupid shit. And I want to reuse this ability to print those things nicely. I want to be able to reuse this ability, but then anyway, so because it's rather convenient. So that means I probably have to create a separate printer for all of that stuff. Anyway, so parse AV. So far I'm going to be probably copy pasting. I'm just copy pasting. Well, Emacs, yeah, thank you so much. All right. So there's going to be a list, and here I just want to print that list. Yeah, might as well, since we're calling it dump. Let's call that dump a list. We accept the list. We accept the list, and this is just the list. And that's what we're doing here. Yeah, so I think that's fairest thing to do in this specific case. So this is the list, and dump list level. So print that at that specific level, and also here we accept the level, of course. Yeah, I think I figured out what I wanted to do. Dump chunk. This is the chunk. Chunk a level is size. So this is what I want to do in here. Dump chunk level. Okay, this is the thing. Alright, I wonder if it's going to compile though. So parse AV, let's disable that. It's going to compile. Doesn't compile. Because why? Moving. It doesn't like that I'm moving things. So which means I probably have to pass that by a reference. Because that's your problem, right? That's your problem. So, and since all of that is a reference, right? So we have to pass that by a reference like this. Yeah, that was your problem. Okay, so that's fair. It's fair, that's fair, that's fair. This is kind of complicated reference juggling, I'd say. Kind of complicated reference juggling. So now in here, I can just do dump list, the same level. You don't have to worry about that shit. Okay, cool. Fuck yeah. So here, dump HTRL, this is more like a parse HTRL. So, and it's inside of a list. So parse HTRL, and I just provide the list content in here with the level +1. And that's it. Yes, finally, the code is moving in the direction that I want. The code is moving in the direction I want. Cool, cool, cool. So parse HTRL, and this one has to be parse strl. So parse strl, and here is the transmitting. Nobody gives a shit. Cool. Interestingly, we might actually return both of these headers, because why not? We can even return them as references of sort of like the same lifetime as the content in here. So this could be something more like a v stream header, and yeah, it will depend on the inner type, so it has to be or that, but let's not do that. Okay, so it's kind of like idea for the future, but let's not do it right now. Let's not do it right now. So we are parsing HTRL, right? We're parsing HTRL, and it's a list, so there's several of these things. So there is always just one header in here. So avich, right? There's always this avich thing. We're checking for that, obviously. We're obviously checking for that. Fuck. So this is just avich. So it's more like this, right? So parsing the chunk, we're checking its ID, so it is in fact avich. So that means we transmute its content, and we also print this entire structure so we can see it. And then we continue the rest of the stuff, and it's actually lists of all these things, right? So it's a sequence of lists of strls. So this is the that which up in the list, and this is where we want to kind of dump list. So this is list level like so, and then we parse strl. Yes. Okay, so that's cool. It's cool, and this is where we kind of stopped doing all that stuff. So now I can switch between parse HTRL. Alright, so it's content, and parse HTRL is the entry. No, it's more like parse AV. Yeah, so it has to be parse AV then. Alright, so let's go into the parsing mode. So semicolon, that's fine. Dump, it's just a reference, that's understandable. Here, when I chop in the content, I take it by a mutable reference. What else in here? It's not, it's actually this, it has to be that. Okay, so finally, cool. So when we parsed, here's the HTRL main header, then we're starting to have a list, strl list, which is like a sequence of pairs, stream header, then bitmap, and then it failed. Hopefully it failed where expected it to fail. Emacs, shut the fuck up. 249. Actually, yes, I think this is where I expected this entire thing to fail, which is great. All right, so here is the thing. You have str h. We parsed that. Where did we parse that? Here. So here it is. We parsed that. So chunk. So here is the chunk. Then we take the next chunk. We make sure it's strf. We part strh, strf, strh, strf, and there's additional things that we really don't care about. So that assert should not be a thing. So that means next time it should fail in here when it tries to parse the next one. Yeah. Okay, so let's see where exactly it fails. I wish it could jump in a correct place, but it's incapable of doing that. 244. Yes. It failed in here. It failed in here. So what I need to do, actually, I probably need to transform this entire thing into something like that. Right, so if it's vids, it's that. Now there is a second one, another one, which is not vids, but something else. But what is it? The question is. So let's put it this way. This is gonna be FCC type, and FCC type. Oh, I mean, I can just do it like that. So header FCC type, and just so if I remember correctly, FCC type is more like a 4cc, right? So it's a 4cc. So let me take a look at the 4cc. So where's the 4cc? Yeah, it is in fact 4cc. So let's actually see what is it equal to. It's equal to odes. Perfect. Actually fucking perfect. So let's find vids. So const odes. Odes u32 like this. So and if it is odes, it has to be waveform format X. Do we have wave format X? So we already converted it. Okay, cool. So to do, so this one, odes, is it odes? So now, let's put it like that. Doesn't have to be like this. Okay, so this one is wave format X. All right, so you see, we're sort of distinguishing them. So in here, I think this one has to be unreachable, right? So because we do not expect this thing in here. We do not expect this thing in here. Okay, so what do we have? What do we have? What do we have? That is very fucking cool. Look at that. So here is the list strl, so vids header, and then bitmap. The next strl, and something went wrong. That is fascinating, actually, and I feel like what went wrong in here is related to the bitmap, right? So strl out, and yeah, so wasn't this structure actually it was converted by LLM? Speaking of, it failed exactly at the code that it was generated by an LLM. What a fucking irony, isn't it? What a fucking irony. So, and much later, after we already kind of like copy-pasted it in here. Vibe coding moment, exactly. So, the size of the structure doesn't line up, apparently. The size of the structure doesn't line up, and the question is like, what the fuck is going on here? It's a good question, honestly. So let me see where exactly it fails. So it fails in here. So what we can do in here, I feel like we need to print some message in here. Right, an expected chunk size. Expected size of structure. This expected, but got actual. Okay, so expected is equal to the size of, right? And in fact, we can do something like expected, all right, it's gonna be let, and this one is actual, let actual, like this, and we don't have to do this stuff like that. Right, so an actual could be, by the way, just as usize, who said it cannot be, so it will make it a little bit easier to work with. Yep, so we'll get something like this. So it will now probably give us a little bit more information, hopefully. Okay, let's go. Expected, and it didn't like something. What do you... Panic message contains unused formatting placeholder. Are you freaking serious? But it's... You can't use string interpolation in assert. What if I do it like that? I still can't do that. Like, what the fuck? Excuse me. Does anybody know what's wrong? Like, do I have to explicitly, I mean, expected action. Is that what you want from me? Yeah, that's what it wanted from me. It's so stupid. Anyway. So, expected size of a structure 20, but get 40. That's a rather huge margin, honestly. Like, what the fuck? Excuse me. Are you pointing even at the right structure? For audio streams, the information is wave formatted structure. Yeah, so that's the thing. And if I take a look at that, wave. Okay, so let's double check. It's a wrapper C and everything, so that's totally fine. Word, dword, word. Okay. So bizarre, isn't it? Actually fucking bizarre, mate. So let's do the following thing. Wave format X, where is that? So let's put to do in here so it breaks in here. And inside of that transmute situation, transmute, let's for now remove this assertion. Let's do a little bit of unsafe code, because the thing I want to do, I want to at least see the structure and see if it makes sense. So here it is. So it makes sense. Samples per second, 48. Makes total sense. Makes total sense. I don't quite get it. So CB size. What the fuck is a CB size? What the fuck is a CB size? So there's also format tag and some other shit. So yeah, that's kind of bizarre. So expected size of the structure 20, but got 40, which is, maybe it's fine, honestly. So maybe it can, yeah. How it is like a base class. It is, so thank you, some Windows. Thank you. So I think we have an incorrect thing in here. Expected, so the actual size has to be less or equal to the expected one. No. Expected has to be less or equal to the actual. So we should allow it to extend. Is that correct? I think that is correct. So expected is the size of the structure, right? Size of the structure. It can be less than the actual size because it could be actually bigger, right? It may contain more stuff. It's like a base class. Check CB for the current used size. Yeah. All right. So, and yeah, now it fails in a completely different place. And CB size is 22. So, but the actual size is still 40. I think it's a fair thing to like assume that like it can be bigger, right? Yeah, I think it's good. So we got a bug in we caught a bug in our code, which is good, which is always good. Okay, where it fails, not implement. Okay, perfect. So it failed like perfectly in here, so that's totally fine. So where does it fail now? Unreachable code. That is cool. So what it was trying to do. So this is more like 322. So parse a v. When we are parsing a v, parsing HDRL, and so within the HDRL, did I close the code? Yeah, I closed the spec. Okay, so we should kind of stop at this point, I feel like. I think we should stop at this point. Or another interesting thing, like HDRL contains always a vih and then a single strl list, right? Actually several strl lists. And I suppose after that, if we get something else, like it doesn't matter. It doesn't really matter. So and in here, parse HDRL, I would have to do something like this. So it's not finished yet. So when the structure is included in wave format extensible structure, this value has to be 22. So when the structure is included in wave format extensible, this value must be at least 22. But what's interesting is that the chunk of the chunk is the size 40. We do have 22 in CB size, but the chunk with the file is 40. So that means there's some padding garbage in there. Must be. So that's kind of interesting. I don't know. But in any case, it looks fine, right? So if we take a look at this entire thing, it kind of looks fine. So sample rate 48,000, fine. Bits per sample 32, fine. 22. So it does sanity check. Extensible is 40. Extensible is 40 bytes, so it's exactly extensible. All right, I see. Okay. So we can always so extensible. Let's actually get the extensible. Here is a trick. Will LLM properly translate it? That's a good question. So this is a C code. Like if I ask it to do something like that, will it do it correctly? Ooh, this one might be tricky, but maybe it will figure something out. AGI achieved internally. Holy shit. I mean, not bad. Wait. Yeah. Is it not bad? Huh. So, yeah. So wave. And GPT-5 is out. I'm pretty sure I don't have an access to it. But anyway, so what is GUID? So samples union and some other stuff. Define GUID, please. Is that a good definition of GUID? Could that be a good definition of GUID? That's an interesting question. All right, let me see. WinAPI GUID looks correct. I'm gonna trust you. You seem to be like a Windows. Oh, it literally is. So here is the usage of LLMs that I'm fine with, honestly. Right. So I think it's a pretty good application of LLMs, just generally, because I don't want to be retyping all of that stuff. Right. And since they pulling out the data out of the knowledge of the whole internet, they kind of like can fill in logical spaces that I didn't put in the prompt. Right. So this is a good usage of LLM in my opinion. All right. So we can now, yeah, so we can try to recompile this entire thing, and obviously trait cannot be derived for unions. Okay. Fuck. Well, that didn't really work well. So sample union. Yeah. Don't forget to thank I'm not finished yet though, so in terms of unions, can I just say it's a enum and will that work? It kind of does work, but I mean it doesn't like that I use this kind of stuff, so I'm gonna make it shut the fuck up. Why they have a separate option for different kind of elements of style? Think about it. Somebody out there has been obsessively creating each individual feature like that. Why would you spend time doing any of that stuff? Who was paying for that? Like, what? Why not? True. I mean, burning corporations' money is always a noble pursuit. I have nothing against that. But anyways, simple. Samples union. Okay, so I think, yeah, that's it. And now here is the interesting trick. Please, for the cases of unions, define them like this. Okay. So, and this is going to be Rust. So the next time it encounters something like that, it's going to try to use this thing. Okay. So if we're going to copy more, hopefully it will pick up that correction and now just do that more correctly. So, yeah. I actually want to do a stream. Like, I have this project marked and I kind of feel like rewriting it in pure C, but I'm freaking dreading to do that because there's a lot of code in here. At least Lexa, it's half of 1,000 lines of code, but the main application is it's just like almost 2,000 lines of code. It's a simple application, right? So 2,000 is nothing. But rewriting it fully from scratch in C, I'm kind of dreading that. And I'm thinking, can I use this approach to rewrite this application in C? Like literally what I demonstrated. Start chunk by chunk and say, okay, translate it to C. Then, no, don't do it like that. For situations like that, do it like that. Okay, next chunk. No, for this one, do it like that. And just copy and slowly, iteratively translate it to a different language. That would have been an interesting stream, actually. Kind of vibe coding, but I mean, like, I carefully monitor what exactly it generates. So, and I think for these kind of translations between different languages, I think LLMs are just like perfect. Sometimes that is slower than writing set. True, but if I have 2,000 lines of code, right, it's gonna start up very slow because I'm gonna be prompting a lot. But as I build up a corrections for the LLM, I think it may go faster. I think at some point it's gonna go, okay, so here's the next chunk, copy pasting, next chunk, copy pasting, next chunk, and so on and so forth. So, but you have to copy paste them in a right order so you can slowly build up the application from scratch. So having some sort of a tool that analyzes the control graph and lets you just go into the code from the bottom up of the execution would be actually kind of cool. Teaching the LLM correct vibe coding. Yeah, kind of. Kind of. But anyway, so we'll see. But it's obviously, I don't know if it's a good idea or not. I'm kind of want to experiment, right? So you know what I'm saying? Just kind of want to experiment. So where is it failing? So it's failing in here and stuff like that. So let's actually see if it's extendable. So where do we transmute this thing? Okay, I'm transmuting it like that. But now I want to do the following thing. If header, so CB size, right? So VC size is equal to 22, at least, right? So greater or equal to 22. Try to transmute the chunk to extensible, right? So this is the new header, and print it like that. Right, otherwise print it like this. So let's give it a try. So we already moved it, fuck. Okay, can we... Transmute is used in not that many places. Okay, can we not consume this chunk? Would that be a good idea to not consume this chunk? Let's actually see. All right, so this one requires that. Okay. Okay, that worked, I think. Nope, because that one is actually 48. You need to check for in the formatting, probably. I feel like I'm wasting time with this thing. So let's not do that. Extensible, yeah. So this is not what I want to do right now, that's for sure. I feel like I'm wasting time. Okay, so where is the enrichable code? Here is an enrichable code, and 70, 291. Okay. So it tried to chop a list, but then it kind of failed. Here's an idea. what if we just try to chop an entry and we specifically matching it against a list? So it's going to be entry list, here is your list. And we're specifically looking for strl. And if it's not strl, if this thing not this string, we can just break, right? So we can simply break out of strls. So here we are just parsing list of strls, right? So we can do something like that and just break out of this thing. Right, and now if it's something else, also break out of strl. So something like that. I think it's a fair, right? If you have some garbage afterwards, I think it doesn't matter. Okay. All right, so everything seems to be fine, and we actually went out of the parse HDRL, which means we managed to parse HDRL. That's cool. That's very cool. So after that, we get movie, and movie consists out of the subchunks. So let's actually see how it looks like. So instead of parsing, let's dump the entirety of the thing. So here is HDRL. So then we actually get some info. So we probably will have to skip some of that shit, right? We'll probably have to skip. And then we get movie, which is just a sequence of different chunks. All right, so if I try to maybe expect list, so movie is a list. Movie is a list, so I can do chop list. Let's go here. Chop list, and I'm doing that out of the content. And here I get the list. Get the list, and let's just dump the list. Let's just dump the list. Level. Just want to see. It's mutable. Info. So what I need to do in here, I kind of need to keep skipping entries, both lists and chunks, until I encounter list movie. That's what I have to do, right? Because I can try to maybe chop another list, and I'm pretty sure it's going to break, saying like unreachable codes. Yeah, so it was not a list. By the way, for those unreachable codes, let me actually do something like this. Not chunk, right? So, and another unreachable here is not list. Yeah, so now if I do something like that, it says unreachable, not list, which is fair enough. Fair enough, fair enough. So the idea here, parse AV, is that now I need to chop an entry. And I'm specifically looking for an entry that is a list, where the type of that entry is movie, specifically movie. And if it is, I should do parse movie. So which is like a list content level +1 or whatever. So and after that I want to break out of, let's call it search movie, right? So here we're just like searching movie, search movie, like so. So if it's something else, if it's any other thing, just ignore it and keep looping like so. There we go. Yeah. So another interesting thing we can do in here, in fact, is maybe dump them every time we encounter them. Like at least dump them, right? So because it's kind of interesting, right? So it can be chunk, and let's just dump entry. In fact, we can also introduce dump entry, like literally dump entry, which just dispatches between them, so it's a little bit more convenient. So I could do something like entry, let entry like that, then dump entry, which is entry like level, And then in here, I don't have to dump anything. What do you think? Is that a good idea? I think it makes sense, or it's so dump chunk. So let me see, so dump entry. This one obviously has to be like this. So this is an entry, entry, this, use size. And then we're gonna just like dispatch match entry, entry list, list, chunk, dump list, list level, 3-hour stream. Yeah, that's true. Well, I kind of underestimated how much time this will take, which is a pretty common thing, honestly, if you think about it. It is rather common. So we need to get the value of movie. Or honestly, we probably have to just have a mechanism that allows me to construct the IDs from string literals, right? So something like that. So I should be able to do that. Okay, so let's just dump this thing. Let's just dump it. So what's the value of movie? It's this one. All right, so const movie u32 like that. Let's go back. RSV search movie. So inc. Okay, come on. Okay, if it's movie, parse movie, parsing movie. It could be something like this. Movie to do. So we have yeah, to use 32. Got it. So this one, yeah, this one doesn't matter. Cool. Parse movie. Get it. We got it. Ladies and gentlemen, we got them. So we got into parse movie. We fell into that thing. So, and what's interesting is that that's basically it, in the sense that after movie you have index, right? So this is a huge chunk movie which contains all the data. Look at it. Its size is half of a gigabyte. So we found this chunk. Its size is half of a gigabyte. After that you have IDX, IDX1, and IDX1 is optional. We can basically ignore everything after movie. We can ignore everything after movie. We're almost there, chat. We're almost there. And here is an interesting part. Movie is a sequence of these chunks. Some of them are WB and DC. And we already had a hypothesis that they're basically video and audio chunks, right? So the video and audio. So we can read more about them. But if I understood correctly, like, you can, I don't even fucking know. Like, do you just keep frames on them if it's a raw format? Right, do you just, like, we'll see how it goes. We'll see how it goes. So just a second, I need to pour some water. I need to pour some water. So mods, ban everyone. Fucking ban everyone. Okay. I'm gonna make a hypothesis that 00DC is video and 01WB is audio. Yeah, because of the size purely. So purely because of the size. So okay, so let me see. So there's no really garbage in here anywhere, so that should be fine. Oh boy, so cool. So AV header stream data movie list. Following the header information is a movie list that contains the actual data in the streams. that is the video frames and audio samples. The data chunks can reside directly in movie list, or they might be grouped with rec lists. The rec grouping implies that the grouped chunks should be read from disk all at once and is intended for files that are interleaved to play with CD-ROM. So as far as I know, we don't really have the rec anywhere. Yeah, so there is no mention of rec. Maybe we should not worry about that. Okay. So the 4cc that identifies each data chunk consists of a 2-digit stream number. Ah, this is the number of the stream. Oh, I see. I see. So, and which one is which? Right, so I think first one, the zeros one is a video and then audio. Yeah, we first had video and then audio. So that means I was right. This is video and this is audio. Okay, so but how are they stored? Oh, they also say you can just have uncompressed video frames. DB. Oh, it's fucking compressed. So it says DC. So it's compressed. Compressed video frame. But how are they compressed though? So that's a good question. So, all right, the first identify that each data chunk consists of 2-digit stream number following. So that means you can't have like more than 100 streams, if I understood correctly. So you can't have more than 100, right? Otherwise you won't be able to like identify them. Right, so information chunk. So compressed frame, uncompressed frame, palette change, audio data. Okay. For example, if a stream contains audio, the data chunk for the stream would have the 4cc00wb. Well, I mean, in our case, the stream for the audio is the second one, so that's why it's 01wb. Okay, video data chunks can also define the new palette entries to update the palette. During the AV sequence, each palette change chunk. Okay, so we don't really care about palette changes, right? So we don't care about palette changes. And AV index, it's IDX1, which is, as already said, optional. Okay, so here I want to do a little bit of a sanity check. I want to grab the first video chunk and the first audio chunk. And I want to compare them to the data files that we generated originally. For those who watched this series from the beginning, you probably know what I'm talking about, right? Because FFmpeg for you is generated 2 data files, right? It's generating 2 data files. The first one is like U4M, and the second one is PCM, and all of them is just like a raw data, except maybe the video file. Oh fuck, I fucked it up. I should have not opened it. Okay. So except video file, because as far as I know, it just has what is it called? The header for the format, right? So it has the header for the format. So, and I just want to see if this is literally raw data. Let's fucking go. All right, so how are we going to be working with all of that? So parse UV. So we're going to go into parse UV, parse movie. And I just want to do chop chunk. I'm taking the content by a mutable reference, right? So something like that. So yeah, hopefully let's actually off. All right, so labs are now free. So yeah, and by the way, since now you can construct 4cc's differently, I think the time has come to actually introduce the you know, an ability to construct them out of the string literal, right? I think it's kind of important. So for implementation 4cc, and yeah, so from str, and this is going to be just like something like this, str, and I think it should be like option, right? So because it might not be something that you can you know, construct like that. Okay, so let me see. So this is going to be So, all right. So I see what chat was actually talking about. I see what chat was actually talking about. So it's this person. Let me take a look at them. Yeah, okay, I see. So invasion of Ukraine is a huge tragedy. It is a huge tragedy, especially for Ukrainian people. And I do understand that. I do understand that. But you also have to realize that I'm currently live in Russia. So talking about it too much for me is putting my life at risk. So you do fucking realize that. You do fucking realize that. So, and on top of that, what we're trying to do in here, we are trying to do a recreation programming. And in fact, a lot of people from Ukraine watch me right now. So, and I actually privately received some messages from Ukrainians telling me that my streams help them to cope with the hardships of war. So, you're actually not doing any good. In fact, you're making the situation worse because, like, again, you're interrupting the session, which also helps Ukrainians. So, like, it is a huge tragedy. It is a huge tragedy. But at the same time, you're spamming. You're just spamming the chat. And I honestly have no choice but to ban you. But maybe I can actually give you a timeout. Let's time you out for maybe 4 hours, right? So then on the next session, you can come in and maybe, you know, change something in your behavior. Maybe also start enjoying programming, right? Yeah, I'm gonna give you a chance. I'm gonna give you a chance. So if you really want to be banned, come to the next session and start spamming again. So I think it's fair. I think it's fair. So anyways, I'm doing fine. Thank you. Thank you so much. So yeah, wars. Fucking terrible thing. Fucking terrible thing. It's like, they're like, wars are like natural catastrophes. But they're not natural. That's the worst part of them. They're entirely man-made. And this is kind of disturbing if you think about it. It's just like a natural catastrophe, unless it's not natural. And it makes it feel like you can prevent it, but you as a regular human, you can't really do anything. It's fucking soul-crushing, absolutely. But anyways, so let's actually implement this thing. So it can be self. All right, just an attention seeker. Well, maybe. But maybe it was a good thing, right? So because the war in Ukraine is kind of slowly phasing out of the informational space, and it's kind of important to remind people that hey, it is still going. People are still dying. So yeah, it's kind of important to remind people. So maybe it's all good. So maybe there was something useful in this spamming. So STR doing MV tomorrow. Should I actually make another session? So the problem here is that this session is going to be too long, maybe. But maybe it is fine. Maybe it is fine. Look at Tokyo Spliff. He's making like a 10-hour session without any breaks. Right, but he's on a nicotine, so he has an advantage. So, but anyway. Okay, so feel like Tokyo Spliff. You don't know who the fuck is a Tokyo Spliff? Google up Tokyo Spliff, really. So I can't really access YouTube right now because, like, I'm in Russia. Tokyo Spliff. Just Google up this individual. His stream is on YouTube, and he's making a shooter, right? So completely from scratch, right? So using OpenGL. Does he use OpenGL? I thought he was using also Vulkan at some point. So yeah, check him out. Definitely check him out. So he's like doing 10-hour session. Both. So he has like 2 renderers, one for OpenGL and Vulkan. Okay, that makes sense. Like I've noticed a lot of game developers like now have like 2 renderers for both of the APIs. So yeah. So maybe it's fine for me to have long sessions, right? So more than 2 hours, especially if we're at the end, we're gonna achieve something tangible, like being able to generate a V file without FFmpeg. So yeah, but I wanna kind of do the sanity check of the data chunk, right? And then we're gonna do another session where we finally generate the AV file, right? So yeah, that's gonna be the plan for the day. That's gonna be the plan for the day. All right, anyway. So I want to get bytes out of the string. I want to get bytes out of the string. Rust up doc. Let's fucking go. So str2. Do you have like 2 bytes? You do have 2 bytes, I think, but it's a sister. Okay, so it's just bytes, and it's freaking. All right. So there is a as bytes. That is good. That is freaking good. Okay, so I can do as bytes. So this is as bytes, and then I can do something like from the bytes. I can do something from the bytes, like so. And yeah, that could work, but at the same time, it is not going to work because so it's a bytes. U32. Yeah, this is what we're trying to come. In fact, what I want to do here, honestly, is just like 4cc. That's what I'm trying to do. It is a slice, right? It is a slice. So that means I should do something like try into. Okay, and it is a result. So what I'm thinking is that we can try to do like maybe, yeah. How do you convert into, I think it's just okay, isn't it? So result, okay. Yeah. So it's literally that, result, okay. So, and I can just map it with, can I just do 4cc? Is that something that I can map it like that? Yeah, I can, look at that, I can, holy fuck. That's so cool. So parse movie, and this is unused. Yeah, that works. Hell yeah. So yeah, so 4cc, where's the implementation of the 4cc? So you can literally do it like that. Damn. So you take a slice, you try converting it into array of 4. It may fail, but you convert it to option, and there you go. So you got this kind of thing. So try into will return some sort of a result or whatever. But yeah, that's totally fine. Okay. So what I want to do as I parse a v, well, I mean, so here is the chunk. So this is the chunk I got in here, and maybe I can dump the chunk like so. Chunk at this specific level. So this is a semicolon, that's understandable. So, and here is the chunk 0dc. Honestly, I will need that from str, but I don't need it right now. Like, I'm not really sure why I decided to just like create it. Like, I will need that from str in the future. So, but right now I don't think it is needed that much. So I'm gonna call it like this. So this is just that, but also this one is U32. I might as well just make it as a constant. So in this, another one, yeah. So we dump the chunk, and I want to assert that the chunk ID is equal to this. It is equal to this. And let's still dump it. I didn't want to dump it, but dumping it is a useful thing. So what you didn't like, oh, this one is 2U32. So, and not implemented yet. Okay, so everything is fine in here. Everything is fine. So, and 0DC is a video. It's a video chunk. What I want to be able to do, I want to dump that chunk into a file. So do we have anything in FS like write? We do. And it accept, okay, it literally accepts bytes. Okay, so FS write first video chunk, and it's going to be binary data, and I just take the content of this entire thing. So, and this may fail, it returns the result, and so let's just unwrap this result in this specific case. Then let's get the next chunk. We may also, so this is a file path, let file path like so. We can just say generated file path. Okay, cool. So this is the first chunk. So then let's dump this chunk. So here is the to-do, but maybe having a to-do is fine in here. Okay, generated first chunk. By the way, we can pad it. Level 2. So it's going to be constantly regenerated, but that's totally fine. Okay, so we generated this chunk. The next one is 01 WB, which is that one. So, and here is the chunk 01 WB. So actually dumping it would be nice before we assert that, so we can actually clearly see it. And in here, what we do is the first audio chunk. Okay, so that's really cool. And we generated like 2 of them. And to be fair, this is basically done, right? I don't want to parse it any further. So it still says unreachable code, but where does it say that? So it went further. So after parse movie, so it went somewhere in a weird, okay. Excuse me, okay. So yeah, we parse in movie. So this is HDRL, right? This is HDRL. Then we're searching for the movie, and then we're trying to search for the rest of the stuff, but we don't care about the rest of the stuff, so we don't have to do anything in here. And that's fine. So what we just did, we took this huge ass AV file, right? And we extracted the first video chunk out of it, 1 megabyte, and first audio chunk out of it. Isn't that cool? I think that's pretty freaking cool. Now, we have raw format in here, right? Raw video format and raw audio format. And we can actually kind of compare them, right? Just to make sure that, like, yeah, that's what it is. That's what it is. Are they equal or they're not equal? I don't freaking know. I expect that the first video chunk is not the prefix of this file, because this file also contains a metadata at the beginning. It contains metadata, so it's not going to be correct like that. But the audio chunk, I think it will be equal to the will be prefix of the PCM. I think it will be. The pixel data is different. As far as I know, the pixel data is just like it's UV444, but it's interpreted as BGR. So I think that's what it is. But we're gonna start with comparing specifically audio. I'm really curious about audio. All right, so I can maybe comment out all of that stuff. And honestly, I think I need to factor out this entire thing. Okay, so let's do something like this. Probe out. Let's call it hack AV file. Right, so this is going to be file path, and this is just str. And I'm going to move this entire code in here. And here we're going to be just like hack a v file. So that's what we do. So hack a v file. So I'm developing from the bottom up, right? So there is a actually, you've probably seen me doing two approaches on my streams where I do top bottom development and bottom up development. So right now I'm doing bottom up development. So I'm doing top bottom development when I roughly know how to do that because I already implemented it multiple times. So like, for example, parsers. Parsers are really do top down, but when I'm exploring formats, right, parsers specifically of the languages, right? So in one of the previous stream, I actually demonstrated that really well, but I forgot which one. So in here, I'm just like, don't know what exactly where I'm going. So I'm developing a lot of hacky things, and then I group them into more useful thing and sort of like a bottom-up approach, right? So that's what I'm doing right now. So this is a hack AV file. Let me try to rebuild this entire thing. So this one is supposed to return results. So what else do we have in here? So this one has to have OK at the end. So as far as I remember, when he concatenated FFmpeg said it will be interpreted as, yeah, so it will be interpreted as BGR24. All right, so in this one, let's put it like that. Okay, so red, but then it didn't dump anything, so that's totally fine. So let's do parse, and yeah, it did them like this. Okay, so now what I want to do is compare chunks, and it's going to be like a separate function. So fn compare chunks, like so, and let's also return results. So the whole module, by the way, it's actually rather big. So it's 400 lines of code, right? So there's a lot of stuff in here. So just for parsing and exploring AV, especially look at these structures. Look at these structures. Okay, so compare chunks. So the first thing we need to do, so video file path, and it's going to be, we're going to start with the audio file path, and it's somewhere here. Audio file is a PCM. Okay. PCM. So, and the audio chunk path, and this one is a first audio chunk. Like this. All right, so let me see. Audio file fs read audio file path. Is this how we use fs read? Yes. Do I want to do it like that? I'm actually not sure. Yeah, I do want to do it like that, honestly. So could not open the file that, but maybe not. Okay, so I'm a little bit tired right now, so I'm gonna just do unwrap. Just gonna do unwrap. So audio chunk, and this is audio chunk path. So is this compilable? It is in fact compilable. It read both of them. Okay. We can try to maybe print a couple of them. So audio file, and we can just take the audio file and slice like first 10 elements in here, and here's the audio chunk, just to see what is in there. So this is audio chunk, and in there, if I understand correctly, we have floats. Okay, yeah, so I know about it. Yeah, so this has to be something like that, and this is more like a debug, so it has to be more like a debug. Well, I mean, that was not particularly useful. In fact, if you take a look at the video, it starts out like silently, right? It starts out silently. The first second is quiet, which is, I guess, correct. So I don't know. Hard to tell actually. But both of them are 0, right? So as you can see, So let me maybe put that into 100 of them. Yeah. What if I print the entirety of the chunk? So let's print the entirety of the chunk. How big of a chunk it is? Does it contain... It's all zeros though. It is all zeros. At the second. Is it exactly a second? Because I'm not quite sure. Like if I take a look at the length, so how many of them do we have in there? 48. So this is not a second because this is samples. Right. This is samples. And we have 48,000 samples per second. 48,000 samples per second. So what we have to do instead, I feel like what we have to do instead, we have to extract the entirety of the audio to actually make sense of it. Yeah. So let's go back to hackav file and we go into the parsav. Parsav, and then we find movie. All right, and let's specifically dump, yeah, let's actually dump the entirety of the thing. So let me think. I'm thinking about having a function which is like dump all chunks with ID, where I say, okay, take all of the chunks that have this ID and dump them into extracted audio bin, something like that. I think that's going to be a good idea, actually. So, and in here, what it's going to do is just going to iterate until the end and just dump them. So, and we also have to supply the content in here, right? So take this entire content, find all of the chunk with these IDs, and just like dump them in there. Yeah. So, but the question is, how is it going to do that? Good question, good question. So we might be doing that incrementally. So it doesn't have to be public, by the way. So fn mute content u8 level use size. So have you researched which video format is easiest to parse before diving into? No. So let's continue. I'm gonna do it something like that. And so here I'm extracting the chunk. I don't care about dumping the chunk, but one thing I care about is if it's the ID, right? So we're gonna grab the ID in here, which is U32. So if it is the ID, I want to save it. So I need to be able to open the file. Open file. Oh, you can also open file buffered right away. Fucking nightly. Fuck you. All right. Might as well. Okay, so can I have like a buffer? I'm gonna buffer it myself. Maybe I can do something like U8. And can I have something like a default? So if it's that, I think what I want to do is I just want to just write it in there. As far as I know, I can like literally do write into a mutable buffer. Right, I can do mute buffer, and I can just write the content of that specific chunk in here. Yeah. So how can you write? So you have a write. This is the IO. And it has, yeah, this is what I want to be able to do. So, which means that I want to be able to do write chunk content. Then I want to be able to do fs write. The file path, do we have a file path? Yeah. So here is the level. and then the file path. File path. File path chunk content unwrap, and then print. We generated that. Okay, so let's try to compile. So it didn't compile. Parentheses. Yeah. So we have to import stdio like this. And it worked. It complained about a couple of things. What are you? Oh, it didn't like that it's mutable. Understandable. So what else do we have? Audio file, unused variable. Oh, it's a compare chunks. Well, I mean, yeah, so all of that doesn't matter. Unused variable, unused variable, unused variable, but apart from that, this one, yeah, let's unwrap. Well, in this specific case, we're writing into the vector, so it doesn't matter. Okay, so we generated the audio. Okay, so this is extracted audio, so let's get rid of all of that stuff. And this is not correct. So 1.4 megabytes, but the actual PCM is actually 1.1 megabyte. So it is not correct. Which raises the question like, wow, I think, So I need to trace back. So here is that, parse AV, parse movie, dump all chunks. Just a second, just a second. 1 megabyte. Why is it 1 megabyte, by the way? This is incorrect, but it should not be 1 megabyte either. You're writing chunk content. You're right. Thank you so much. Yeah. And it's 0, by the way. So well, yeah, because it's first one is not audio chunk. Okay, so I'm a little bit tired, so bear with me. So while content length is greater than 0, we chop in le chunk. We chop in the chunk. If it's audio chunk, we are appending it, and we're repeating that until we get to the end, right? So we just concatenated all of them together. All right, let's fucking go. So 1.1 megabytes and 1.1 output PCM. Size checks out, more or less, but let's actually check the precise size. But that doesn't mean anything, does it? Right, so let's do SHA-256, extracted audio, and output PCM. Absolute paddling. Fuck yeah, that's so cool, actually. Yeah, so, and I didn't use any libraries or anything like that. I just like extracted the original audio out of the beats. And I'm saying I didn't use any library. In fact, I developed one. If I polish this entire thing up a little bit, I can sell it as a V library, a V parsing library. So possible collision. Dude, SHA-256. Shit. I spent 2 days writing that. Like, I'm not losing to a SHA-256 fucking collision, okay? Okay, so this is that, but let's actually also extract the video format, right? And by the way, comparing is not a particularly useful thing, right? So let's remove the compare function, right? So it's not a really good approach to comparing. So, all right, audio, yeah, so all of that stuff is going away too, right? So, and what's cool is that now I can say, okay, now also dump the extracted video. right? Since I kind of passed a copy of a slice in here, right? So I can just like reiterate the same chunk over and over again, right? So I'm just iterating it twice, and I'm saving separate sort of channels in separate files. All right. So at which time you will stream next session? Probably the same time as today, right? So this is my like roughly usual time, plus minus an hour. Follow me, like follow my Discord channel, the Discord servers, because I make announcements there. Oh, you probably don't use Discord, right? So you're not into Discord. So really sorry about that. Maybe we should start maybe like announcing again on Blue Sky. Maybe it's a good thing, but I don't know. I kind of feel like don't really want to spam too much on Blue Sky. Anyway, so let's freaking go. Let's try to talk about this entire stuff. And okay, so yeah. Okay. This is the video, which is, but this is a human readable size, which means it's rounded. Right. Isn't video compressed? No, it is not. Because I mean the size of the IV is for, like half of a gigabyte, so it's obviously not compressed. All right, so let's actually take a look at not human readable. So all right, yikes. But right, so this is the size that we extracted, and this is the size of the file. But look at the difference between them. Look at the difference between them. The difference is rather interesting. So that specific format, U4M, and the description of that format is actually in here. Let me see. So here is the repo where we're doing all that, and description is in here. It actually implies a metadata. So it has a file header, and each frame, each individual frame also has additional metadata. So frame data and like frame metadata. To actually properly compare these things, we need to strip off all of the metadata. So that's what we have to do. Join Discord just now. Okay, cool. So what is your Discord identifier? Just let me know, and after the stream I will give you VIP, or yeah, xmerky. Okay, I remember that, xmerky. All right, cool. So how can we do that? Let's do the following thing. Let's take a look at the rendering. So this is how we render things. This is how we render things. So this is the video sync. And video sync, here it is. So video sync is a buffered write. So here I was not lazy to use buffered writers and stuff like that. And video output file. Okay, the thing I want to do in here, I want to do something like raw. And this one, video output path, raw video output path. Okay, so here. So I call it raw. Let's call it output raw, like that, because raw comes here out to the output, raw here comes out to the output. So video sync raw. And as you can see, here is the header, and it's literally text header, by the way. It's kind of interesting. Wait, is this real? Just a second. Fuck, it's probably not gonna open easily because it's half of a gigabyte. All right. Can I maybe go to here? This is not what I meant. Output Y for M. Even Vim cannot open this file. Fuck me. Yeah, I probably have to use head. So it's already dead. Head and 100 or something. Oh fuck. 10, but whatever. Linux is hard, okay? Okay, so anyway, so video sync, where is that? So save frame. Okay, so we do frame. So we put, we literally put frame in here. So frame, file header, detailed frame headers. So, and this is just planes, right? This is just planes. So this is like a, per frame, we just like literally starts with frame, right? Case, match case. So following the header is any number of frames coded in YCB format, YCB plain order. Each frame begins with a 5 bytes frame followed by, okay, so here is the thing. Each frame is stored as 3 planes. Is it going to also store them like that in the raw data? I don't know. Okay, so here is the sync row, and it's a mute implementation of write. So we're writing into the usual sync, but for sync row, we just don't write that frame there. Might as well actually just do something like that. And I think that's it. I think that's basically what I want to do in here. So video sync. So we pass this stuff, save frame, and that's it. Okay, cool. Let me try to just rebuild everything and go to the compilation. So what is it? So here I have to put video sync row. All right, cool. So what I want to do in here, so in terms of rendering a final AV, so this is how we, this is how we render the final AV. I need to restart the whole process over again. So let's do render. So we render in the final video, then passing it to FFmpeg. It combines all of that together. Right, so raw video cannot be written to AV, output files will be unreadable. So that's understandable. So we have a raw part in here now. So extracted, let's actually regenerate extracted as well. And if I take a look, by the way, at non-human readable stuff, look at that. Raw is exactly with zeros at the end as the extracted one. Look at that shit. So this is the metadata, right? So this is literally the metadata. Okay, so there's a hope. Yeah, exactly. There's a hope. There is a cope. So 2 mpeg UV, and let's try to AV. Let's do AV. So extracted the audios. Okay. So if I take a look at their not human readable stuff, okay, so this is the raw part. The audio is totally fine. Now the moment of truth. SHA-256. Fuck you. 256. This is the raw, this one, and then extracted video bin. Holy shit! Holy shit! Okay. I actually confirmed that it literally stores them as raw bytes. This is fucking cool. Damn, broski. Hell yeah. So I generated some raw data and I then put it into FFmpeg, got a V file, and then I extracted it manually back, and it like all checks out. Which means like I fully understand how a V container works. And I can now generate that AV container myself from scratch. But I already streamed for 4 hours, so I'll have to do that on the next stream. Right. So let's just leave everything as is. Right. I'm not gonna touch anything. Right. And tomorrow we're gonna try to do the reverse process, knowing, like having all the knowledge about AV format and having all of the machinery that will build up to parse it to actually generate it. So this is very freaking cool. But instead of VCBACR planes, we'll have to generate BGR24, which is actually easier, right? Because with YCBCR things, you have to work with these like formulas and shit. Right, so yeah, so I generate code in RGB already, like I already have RGB, but just for that stupid format, I have to convert it to YCBCR, and this is the formula of the conversion. Like, there's no fucking way I memorize it or understand what the fuck it's doing. It's just like, you only have to copy paste. This code is only copy pasteable. Look, this is how you convert RGB to this color space. Like, I think we found it on the internet. It's just like, this is how we do that. And I'm pretty sure everyone who's working with this color format in FFmpeg, in MPV, or anywhere, they just copy paste the same piece of code over and over again. I'm pretty sure nobody fucking understands what it is. Maybe some people do understand it, right? So the physical process behind all of that stuff. But majority of the software engineers probably don't try to even understand that. So yeah, code transformation are not meant to understand. Yeah, I suppose. Right, I suppose. This honestly feels like maybe some sort of a matrix multiplication. I think I kind of vaguely remember that there's one codec, FFmpeg, that kind of does, like, it works in a similar space, and it does transformation in a simplified manner. So FFmpeg, technical description of FFmpeg, yeah. So this is a very old format, right? So it's not particularly great. Yeah, and this is how they do it. It's UV. Right, it's not CBCR, but it's UV, and it does code transformation between RGB and UV through this matrix. So it's kind of different, but yeah. So conversion from RGB color space to the FFmpeg color space is achieved using the following simple matrix multiplication. Taking the inverse of 3 by 3 gives you that. This is clearly different from the standard techniques for color space conversion and was probably chosen due to its mathematical simplicity rather than its perceptual performance. Perceptual. This is such a fucking nice way to say that this is a hack. Right. Like, it's chosen due to its mathematical simplicity, rather its perceptual performance. It is such a fucking polite way to say that, and I kind of know why. Because it was written by British people, right? So look at the color, look at the written of color. It's clearly written by British people, and they're trying to be like sophisticated and fancy. And this is just like, an American would just say, this is a hack. This is just hack. But British, they have to like do this kind of sort of things. Anyways, that's it for today. Thanks everyone who's watching right now. Really appreciate it. Have a good one, and I see you all tomorrow, where we're gonna try to generate a freaking AV file. So see you all tomorrow. Love you all. Mwah. This is the third day. So let's try to finally generate a video from scratch. So what I want to first do, I want to analyze our video again. So here we are hacking the video. Okay, so I want to do dump AV as tree. Let's just look at what we have in here. I'm going to just rebuild the whole thing. Right, so, and let's just do AV. And this is the tree. What I'm interested in specifically is the values of AVIH, strh, strf. Right, so because I feel like what we're going to be doing, at least to simplify the whole thing, is just literally copy pasting these specific headers. Right, let's go ahead and do that. So where's our AV? And this is dump AV as tree. AV as tree. So, and in here, I suppose, depending on what we have in here, so I can even do a match, chunk, what is ID to U32, and AVIH, if it is equal to AVIH. We do in fact have AVIH. Right, and the things I'm interested in here are strh and strl and so on and so forth. I'm not interested in strl because this is just a list, right? I have no use for that, but I'm interested in strh and strf, right? So it's going to be strh, and so this is, I suppose, stream header, and strf is the stream format, right? So that's what I'm interested in. And yeah, this one is rather interesting because I just remember that strf depends on what you have in strh. So traversing things like that is not going to work, right? So because, yeah, one thing depends on another, so we have to go back into the parsing mode yet again. Okay, so that has to be parsing, not just a regular mindless traversing, because the problem with just traversing is that it's kind of stateless, right? So it is kind of stateless, so but you need to kind of maintain this state. So okay, as I parse HDRL, right, as I parse HDRL, inside of this HDRL, I get the AV header. Okay, so that's understandable. I then print that AV header, then I do that, and so on and so forth. Like I already probably print everything that I need to print in here. I just print. So the only thing I probably want to do is just like not parse. Okay, so yeah. So I don't know. Spend too much time doing like not really useful work. What I want you to do, I want to just like regenerate everything, and here are all of the headers that I want you to have, right? So I just didn't realize that this is what I want to do anyway. Okay, so let me maybe like grab this entire stuff, right? So I'm gonna just like literally reuse the same headers. So this is our AV header. So, and maybe how can I even approach this entire stuff? I might as well make it something like a default AV main header, right? And we're gonna do it like that, and I'm gonna just make it equal to like that. So is it even possible for me to just like literally copy paste it from the code and use it like that? That's the real question in here. So obviously this is reserved as 0, and I wonder if I can do 0 yet. I probably cannot do 0 yet. I probably cannot do 0 yet. So let me actually do something like rust up. So just a second. Rust up doc, just super quick. Oh, I probably should have not put ampersand in here. Should have not put ampersand, and here I want to find 0 yet. I feel like I won't be able to use 0 yet because it is unsafe. Is it not? Freaking, yeah, unsafe. It's kind of weird that I have to do it like that, but maybe I could just use default. Is something like default a good thing to use in here? Maybe it is. So we can try to just like do something like default. But at the same time, it may not work because this is like a runtime function, and calling runtime function in a context may be not a good thing. So I don't know, let's try to compile this entire thing and maybe hope for the best, right? As usual, as freaking, yeah, of course. So it's a non-const associated function, blah, 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 yap, 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 excuses, 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 like const expression hard, blah, blah, blah. Okay, okay, I see how it is. I see how it fucking is. Anyways, so, well, we could probably do that, but it would be kind of nice. Like, I really like how in Rust I can just like allocate something on the stack and just do zeroed. And it just works. It just like works like in C, and it's so freaking convenient. And it's like, how the fuck like unsafe is more convenient than safe, even though they're explicitly trying to make it less convenient. I don't freaking know. I don't freaking know. But anyway, so this entire thing seems to be compiling, right? So which is a goodie. So the next thing we want to have in here is this is the stream header, right? So let's copy paste this in here, and this is more of a default AV stream header, but it's specifically vids, right? So it's for the videos, right? So I'm going to put in here AV stream header, like so, AV stream header, and in here we'll probably do something different in here. So when I do 4cc, I can construct it from U32, so that means I can do something like 4cc. Stupid Emacs, shut the fuck up. So from U32, this is what I want to put in here, and it probably won't work because it's a runtime thing. So one of the things I'll probably have to do in here is something like const or const-fn. I don't quite know how exactly it works, but let's not put that in here. I want the compiler to tell me that I'm doing something wrong in here. So, and in here, this one is also rather interesting. So maybe I have to do 4cc from U32, and this one we already have that. So this is vids. right? So this is more like width, and this is basically the same function. So let's try to compile this entire thing and hope that, well, this is not compilation, by the way, this is just running the entire thing. Of course, it is non-const function, just exactly as I said. All right, so can I just say, bruv, const? I can. I'm not really sure why default is not const. Maybe because for some of the types it might be not trivial, but it would be kind of cool to be able to just do that. Here's the thing: in Jai, in Jai, you can literally call functions of from other C libraries at compile time. Think about that. You can do that. It's totally fine. So here, the function that is like that the source code of which the compiler knows, you can't easily run it. You can't freaking easily run it. Anyways, so too bad Jai doesn't exist yet. Too bad Jai doesn't exist. I wonder if I can just do something like const in here. Is it going to work? It is going to work. Another interesting question: can I do const in here as well? Nah, can't do that. Can't do that because this one is non-const. Trying to convert, yeah, that's kind of bizarre, right? So, like, you could have just said that, okay, S has to be known at compile time, right? Must be known at compile time, so just convert it or something. But we could try to maybe like have this as a generic with a string. Is that something possible to do in here? So because I do remember, like, wait a second, Rust, const generic parameter. Do you guys remember there was like a const generic parameter? Can I have string literals in there? Generic parameters. So what the fuck is this? I don't want constant items. Okay, can I have something like that? Brovskis. Right, so const in generics, bro. You know what the fuck I'm talking about. Const generics. Okay, Rust by practice. Show me something that is kind of relevant to what I'm doing right now. Okay, it is banned in Russia. Fuck that shit. Const generic, how to build type safe. Okay, so there's this thing. Yeah, this is what I'm talking about, bro. Just give me that. This is what I'm talking about. Can you have string slices in there? This is the real question that I have. Can you have string slices in there? Probably not. It's probably boo-hoo too difficult. We only support primitive types. Boo-hoo, unsafe, difficult, excuses. Probably you can't do that, but we can try. So let's actually give it a try. So this is going to be this kind of thing, right? And let's just say that we're returning and will that thing compile? So let's return const. All right, so it doesn't, not a value even. Oh, it has to be const. Okay. So it can support that. Now, the moment of truth. The moment of truth. Can you do that? Explicit lifetime. Okay, so this is not outright rejection of this idea. This is not outright rejection. Okay, so we can actually say it must be static. It must be static. Okay, expected you. Okay. So, and then can I just return static str? All right. And forbidden a step con. Boo-hoo hard, non-primitive parameters. Okay, like I didn't expect anything else, honestly. Didn't expect anything else. So very well then. So that means it has to be a priori runtime thing. Has to be a priori runtime thing. So all right, let's continue. Continue programming. I worked with the shitty languages, right? So, tiny bit disappointed, not surprised. Memtransmute is const. Ooh, this one is interesting actually. So you're suggesting interesting things. Memtransmute. So memtransmute. Let's see. It is in fact const. That's very interesting. So, but in str as bytes, is it const as well? It is const. Slice as ptr. Const as well. I mean, we can do something about that, but we don't need it right now, right? We don't need it right now, so I'll keep that in mind. Thank you for the suggestion. All right, so let me now, so all of that compiles now, right? So all of that compiles, that's pretty cool. So, but this is only header bits. This is only header bits. Now, I want to do that one more time. All right, so how to do that from this thing. So this is just bits, and this is bitmap header, right? So this is the bitmap header. Let's copy paste this entire stuff. So this is going to be const, and this is the default bitmap info header, right? So that's what we have in here, and this is the type. I'm going to put it in here. This is equal like so. This is equal like so. All right. So Emacs, shut the fuck up. Emacs, shut the fuck up. So let's try to recompile. Seems to be compiled. That's cool. So the next one is out. I'm not really sure what is FCC. Wait, FCC handler is basically the number of the stream, right? That's what it is. It's the number of the stream, and this is like 0, and this is 1. And this is the number that is probably used with movie chunks, right? Inside of the movie chunk, you have this like sequences of chunks, which is 00 DC, 001 WB, and whatnot. You guys know what I'm talking about, right? So you guys know what I'm talking about. I can even show it, right? So for anyone who doesn't know what I'm talking about. So if I just dump the v3, so let's just do that. Yeah, there we go. So here they are. So 00 in here means the first stream, and 01 means the second stream. And this is the type of the data that is stored in here. So that's probably what it is. I never realized what is FCC handler. Though we can look at the official documentation, right? So let's find bitmap info header. Let's find bitmap info header. So here it is, and FCC handler. So and it's not what I wanted actually. So it's the vstream header. Vstream header, FCC handler, FCC handler. Optionally contains a forcc that identifies a specific data handler. The data handler is preferred handler for the stream. For audio and video streams, this specifies the codec for decoding the stream. Ooh, this one is interesting. So, but in both of the cases, we're using like row. So, yeah. It's kind of interesting. So, okay, but we're going to be keeping like the same things, right? So we're going to be keeping the same things. Doesn't really matter. Okay, so let's go back to here. Hack a v file. Hack a v file, and so this is going to be parse v. This is going to be parse v. There we go. Parse v. Parse v. Okay, so outs. So, and this one, let's copy paste this thing in here. So, am I in the right place? Where is the video? Where is the video? So, here is the video. Here is going to be the audio. And I want to copy paste the whole thing in here. Right, so this is AV stream vids, and this one is outs. Outs. That's what it is. It's just outs. I'm going to remove that. I'm going to put that stuff in here. And then for CC from u32 outs, let's remove that. This is value 1, so we can also do something like from u32. This is going to be 1, like so, and that's basically it. That's basically it. So we got the audio. I would like to maybe put it after this entire thing. I'm going to put it after. All right. So what else do we have in here? So the last one is a wave format X, but we have to be a little bit careful in here, in a sense that whatever we have in the file is actually kind of extended, so it contains a little bit more. And what I'm thinking is that what if we try to save a shortened version of wave format X? Right, do you guys remember what I'm talking about? Those who were on the previous stream. So wave format X. So in the documentation specifically, they say if SB size is equal or more than 22, right, so they explicitly actually talk about the size 22. Yeah. So when the structure is included in wave format extensible structure, this value must be at least, right, so 22. So, and it is exactly 22. So, yeah, maybe we can try to actually include only shortened version, because I don't really know full version, and maybe it is not even needed. maybe it is not even needed. So let's try to do something like that. Let's put it in here. And here is an interesting thing. If you just print the size of this structure, so waveformat X, and we can go in here and say like a size of this is equal to size, and the size is size of waveformat X, like so. Waveformat X. Let's actually just like do something like this, 20. Yeah, so it is in fact 20. And by the way, I hope that size of is const, right? It must be const, right? So otherwise it would have been kind of useless. Yeah, it is const, so that means I can just like literally initialize it like that. Default wave thingy, and let's actually do something like that. In here we just do size of that wave format like this. So that is basically it. I think we have all of the necessary things collected in here. So size of so what you don't like, it has to be U16. Okay, so I can say as U16. There we go. So we have everything collected, and it doesn't even work because I commented out hack a v file. All right, so that seems to be working. So now we need to somehow recreate the same structure. We have to somehow recreate the same structure. Okay, so how are we going to be doing all of that? So hack a v file. Here, let's say fabricate a v file, right? And we're gonna start doing something like that, right? So just start fabricating the AV file. Right, so I'm gonna start something like this. Here is going to be file path, and this is going to be str. And we're not gonna return anything yet, so we'll see how it goes. So the first thing we have to do, according to le specification, it's kind of interesting. We spent 2 days breaking the AV file apart. Now we reconstructing it back, right? So it's kind of interesting. So this is literally like a reverse process. This is a reverse process, and which means that I'll have to have opposite operations to things like chop, if you know what I'm talking about, right? So things like chop U32, right? So that just reads stuff out of the slice. Now I need something that writes that stuff into maybe some sort of a buffer. It's probably going to be a vector of U8s. Unchop, yeah, maybe something like unchop. But in our case, we're not going to be working with the slices of the bytes. We're going to be working with buffers, which is like vector and stuff like that. So let's call it a buffer. Right, so it's U8, and this one is going to be just a vector new. Cheers, by the way. So how a v format starts? So it's basically ref. All right, which means that I can do something like buffer. So I remember somebody said in the previous stream, and I kind of missed that in the chat, that in a vector you have things like extend from slice or whatever. Right, so you have extend from slice, and this is something that we can do, extend from slice. And for instance, I can take a ref, which is U32, right? If you take a look at, yeah, so this is a U32, and I can convert it to le bytes, right? I'm converting it to le bytes, au chocolat, and I'm taking this slice and I'm just like extending that buffer from the slice, and now after that I can maybe just write that file, right? So I suppose file path, this is le buffer, taking a slice out of that and also unwrapping and so on and so forth. We might as well even just something like generated file path, like so. So let's actually try to run this entire thing. I did that in the wrong place. That's understandable, so it has to be mutable. All right, let's make it mutable, freaking Rust. Okay, so we generated a v file. I can look inside of the AV file and it has ref. And here is an interesting question. What if I do file on it? It's a ref little endian data. So file already recognizes that as a ref file. So Kinslayers, thank you so much for the sub. Right, if I put something like your mom, will it actually recognize it as something else? Right, so it's just an ASCII. But if I put ref in here, it recognizes this as a ref format. That's already enough for file to think that it's a video file. This is interesting, isn't it? Right? I didn't think that it's going to be enough, but apparently it is enough. Okay. So how we're going to be doing the rest of this stuff? So after that, we have a freaking file size, bruskis. A fucking file size, mate. So you know what that means? You know what that fucking means? That means we have to know it up front. So we have to upfront generate that data first, save it somewhere in a buffer, and right, only then do this kind of thing. But I mean, right now we don't really have any data. What we can do, we can just do buffer extend. So extend from the slice 0u32 to le bytes au chocolat, and then take this slice. So we can just try to do something like this, or patch it up. Like, also sounds like a good idea, but I don't freaking know. So we're having like a very beefy computer, so we can hold half of a gigabyte of the data in the memory, no problem. How much memory do I have? I have. Can you please human readable? Okay. So I have 14, actually I have 16. Where is my 2 gigabytes? Motherfucker stole my 2. Oh, it's, yeah, it's supposed to have 16 gigabytes. They stole 2 gigabytes out of me. Or is that the gigabytes? I don't fucking know. I just like, all of that is so sketchy. GPU memory? No, this is a CPU memory. This is a CPU memory. Anyways. So we can just save this shit like that, right? So, and just like, let's see how, like, what kind of file it will generate. Look, this file is now 8 bytes. So let's take a look inside of this file. Let's take a look inside of this file. And in fact, yeah, so this is the first 4 bytes. And this is the last 4 bytes, which are 0. This is how Emacs denotes a 0. It's a caret, I don't fucking know, at. Right. So let's take a look at the file description. Still ref little endian. Let's try to open it with MPV. So file to recognize file format. Failed to recognize file format. I've got an idea. So one of the important thing about a V is that after the first 8 bytes, it has an AV for 4C, not 4C, 4CC. Right. So, which means that what we can do in here, we can just take a V, right? So we take a V and put in here. But here's the thing, that means we have to include the size of that AV in here, and the size of the AV is 4. So we just have to put 4 in here, and this is basically 12 bytes now, right? Let's try to generate that shit now. Okay, let's fucking go. So this is 12 bytes, as you can see, this is 12 bytes, and this is how it looks like. So this is already more or less valid AV format, I think. It just doesn't have any chunks, right? So we have ref, we have file size, and file size, so what does this say? So the value of file size includes the size of the file type plus the size of the data. It does not include a ref and the file size itself, right? So as you see, file size contains the size of the file type, but there is no data. So this must be already a valid AV. Caret notation, Karen annotation. So without that AV, this is not an AV file yet, it's just a ref file. But as soon as you put AV space, this could be a valid AV file actually. So that additional 4 bytes might be actually it. And in fact, look at that, it is an AV file. That's interesting, isn't it? That's interesting. So what if I change it to something like dick? So it's also 4 bytes. Imagine having imagine having a type of the chunk called dick. Technically it is possible. It is not against the spec of a ref format. You can have a chunk identifier literally dick, all capital letters. So it's totally fine. So I wonder how exactly is it going to recognize that. So if I put a file, it didn't recognize the dick file format. Unfortunately, it doesn't exist, but it does recognize AV space. Specifically, do not forget the space because it has to be 4 bytes. And do not forget the space. So if I put AV, as you can see, it recognizes it as AV. Dot dick, yeah. You can't use dot dick because it's already 5 characters. So it has to be specifically 4. I'm sorry about that. So dick is not the part of the infrastructure. Oh, you follow me on Twitter? Okay, so. I mean, I also said that on the stream. Yeah. So I recently posted a clip about infrastructure as a software as an infrastructure in Twitter. So, but anyway, so this is a valid AV file, which means that we can try to play it with MPV. I mean, why not? Sounds interesting. So AV format open input failed. File to recognize file, but it's a valid one. It's a valid one. Where did they say that data cannot be zero? Well, I mean, okay, they explicitly said that because there are mandatory lists and chunks. Okay, so that's understandable, right? So, and by the way, AV format is FFmpeg. FFmpeg could not handle our AV file. FFmpeg cannot comprehend this 12 bytes. Anyways, I'm sorry. Zlomiroch, thank you so much for tier 1. Thank you. Back it up, we're better than... nah, not really. So it's very easy to generate some garbage that nobody understands. So anyways, so what's the next thing? We have to generate, so the main header, right? So that's what we have to do. We have to just generate a main header. So and on top of that, it has to be list, by the way. So we have to create list HDRL. This one is interesting. This one is interesting because how do you even create a list? How do you even create a list? Let's take a look. List is a list for CC. Okay, so what we can do, look at that chat. Extend from slice. So we take list for CC, converting it to le bytes au chocolat. Right, le bytes au chocolat. So what is the what am I even looking at? Const ref, where is it? Yeah, so here's the list. Okay, so after that we have to specify list size. Again, we need to know it freaking up front. We have to know it up front. So I'm gonna specify something like extend from slice. So let's put size 0 because we don't freaking know it yet. So this is the size, and we have to specify the list type. And in our case, since it has to be HDRL, right, so that's the list type. This one is actually easy because we do have a value for HDRL, right, so we converted it to le bytes au chocolat. And and that's it, I suppose, right? So you have list type, where is the... list type, and then comes the list data. All right, so and what we need to do, I feel like we need maybe some sort of functions that simply like save list data into some sort of a sink, right? So we can do something like well, somebody suggested to call it unchop. Let's call it unchop, like unchop list. And in here we're gonna accept the buffer, right? And it's gonna be mutable buffer to U8 bytes. But I'm not even sure if that's a good idea to use buffer, right? Because it implies that you can only like put it into a vector. We can make it a little bit more generic by saying that it's an implementation of write interface from IO, right? Write implementation from IO. So let's actually take a look at this. It has a method write, which accepts the slice of bytes. And what's interesting is that vector of bytes also implements these traits. So this makes this function more generic. You can put an open file in there. You can put an open file in there, or you can put a buffer, so it doesn't care anymore. So yeah. And this is something that we'll already kind of do in a renderer, I think. Yeah, this is literally what we do. So this is the renderer that generates like the video and stuff like that. It uses write as the sink. Right, so use write as a sink, and it doesn't really care, and it just writes the bytes. This is what we should do, chat. This is what we should do. So, and let's also call it sink. Freaking neighbors. Anyways, and by the way, we already have a structure for list. Look at that. We already have a structure for list, which means that we can accept that list in here. Who said we cannot? We can. Right, so, but that requires to have a slice and everything, okay, a lifetime. So let's put lifetime in here. So thank you so much for all this up. Thank you. Really appreciate all that. Let's do something like that. So we have to do write. We write list to le byte so chocolat, and then we now, since we have this list, we sort of pre-collected that list. We know the size of that list because it has a content, it has a length. There you go. Here is the list. So I can do as u32, which lets me to convert it to le bytes. And then I take a basically slice of that, and there you go. So I just wrote the size, and I'm not even sure if the size comes after that. It's the, yeah, so size actually comes after that. Then comes the types. So it's going to be sync write. And the type is located in literally here. So here is the type, which I can convert to le bytes, and then take a slice of that and just write all this thing. And our type, if I'm not mistaken, is 4cc, right? It is 4cc. And by the way, we don't have 2 le bytes in 4cc. We probably have to convert it to u32 before we can even write all that stuff. So, and by the way, write operation may fail. So because of that, we probably have to return something like IO result, right? Then just do these kind of things, and then just okay like that. Just okay like that. Just okay like that. Okay, that's pretty cool. So now, if I want to write a list with some sort of like amount of data, I can do unchop list, right? I can do unchop list, then take a mutable reference to the buffer. It fits into this definition in here perfectly, right? It fits there. And then I can probably create a new list where type is equal to HDRL, right? So that's HDRL. And then I can have some sort of a content in here. So for now, it can be empty slice, but I can put more stuff in here if I want to. Right, and then here it may fail, so we probably want to unwrap this entire thing. Or maybe we can even return result, IO result, IO in here. So something like that. Something like that. So, and yeah. So since it is that, we can, well, it's not generated yet, so let's call it generating this file, right? And then we're returning the result of write. Okay, so this is roughly, we're starting to building up like opposite operations of like deconstructing the AV file, right? So this is opposite operation now, and this is going in the right direction, in my opinion. So, and by the way, I suppose maybe ref should also be kind of like a slice of like a chunk, right? So because if you take a look at the definition of chunk is a ID and size. It is ID and size, and then comes the data. But whatever breaks this pattern is this AV ref, right? Which is kind of weird, but yeah, I don't really know what to do about that. I really don't know what to do about that. I suppose, yeah, we'll need to pre-collect the internal data of this thing and then wrap it into a ref chunk. In fact, let's create unchop chunk, and it's going to be kind of similar to unchop list. In fact, I'm going to copy paste this entire stuff. I'm going to slowly copy paste this entire stuff. Yeah, list size. And you know what I forgot? Chat, you know what I forgot? I forgot to actually save the content of the list. Right. Content is already sliced, so I don't have to do anything in here. So it's totally fine. So this is going to be chunk. And instead of accepting list, we accept the chunk. Right. So this is the chunk. And here we're writing the identifier of the chunk. So essentially it's going to be chunk ID. And it's, I think it's 4cc, so I have to do 2u32, then 2 le bytes of chocolat, and there you go. So similar to the content, right? I just write in content, content length, and then I just write the content right away, right? So that's the main difference between lists and chunks. Lists have additional type, right? So list has an additional type, which means that ref is a freaking list. So that's what it is. But it's not really, okay, this is really interesting. So ref is a list where It's a special kind of list where the chunk ID is not list but ref, but it acts like a list. It acts like a list, which means that maybe it's a special kind of entry. Like, I know it's kind of difficult to feed this entire thing, but anyway. So we can always maybe just have something like unchop. I don't know how to feed that. A root list. Yeah, it's more of like a root list. It's more of a like a root list. So, but at the same time, yeah. So, but it's more of a chunk. Yeah, I think it's more of a chunk. So let's have a buffer. This is more like a V buffer. So this is a V. We are saving a V. So since we're going to be using write everywhere, let's just use write. So this is going to be write. So this is the AV buffer. Into here I'm writing bytes, and then into that AV I'm also writing HDR list, right? HDR list. And after that, what I have to do, I have to have more like a ref, which is also vector u8, vector new, and then I can try to unchop chunk into the final bigger ref, where chunk has ID equal to ref, and the content is this AV in here, something like that. Right. I think this is how we're going to do that. And when I'm writing, I'm actually writing ref in here. So first I'm generating the internal sort of AV. Right, so then I'm embedding it into ref chunk, and that should be correct. So it's kind of like it's going to be nested. The whole format is like Sexper, but harder. Yeah, I guess. So finally, maybe we can even do something like generate a V. Right, so just like, let's call it fabricate a V. And here we're gonna like literally return u8, and I can just put this entire thing in here and just return a V. So I'm gonna be moving out of the function, right? And in here is the ref, and I can just try to fabricate a V, and just taking a slice out of that, and I treat it as a chunk, and I save it into ref, right? And then I just save it like that. So let's see if this entire thing compiles, right? So I'm yapping a lot, but I haven't tried to compile whatever so it doesn't compile, obviously, but we probably have to put something like this in here. What else do we want? IO, right, does not exist. We probably have to use something like IO, like this. Can I just do something like self, so it imports this entire thing in here? I think I should be able to do that. Okay, so list it doesn't like, because this is not a list, this is a chunk, and this is also the chunk. And all of that stuff, we kind of moving this chunk inside of it. We probably should not move it. We should probably take it by the reference, like that. It should be also probably be a reference. So let's actually see if it's going to work like that. So a V operator didn't like blah blah blah. This is because we probably also have to do something like result in here. So which means that when we return this entire thing, it has to be okay, dokie, karaoke. So what else do we have in here? So HDR, L expected for CC, but found that's understandable for CC, not force, for CC from U32. For CC from U32. What else do we have in here? List has to be a reference, understandable. What else do you want from me? Yep, for CC from U32. Let's go. What else do we have in here? So fabricated. Okay. Unwrap that. Take reference of that. Holy shit! I'm surprised this motherfucker worked. Yeah, so it kind of works. Look at this one. Like, bro, Perl is more readable than that. Like, developers of this compilers, you do realize that Perl is more readable than this mess. It's just, what the fuck is that? This is not a real language, I'm telling you. Like I can't believe this is a real language. Anyways, let's continue. Let's freaking continue, brovskis. So if I try to run this entire thing, it generated output AV. It generated output AV. So let's take a look at it. Okay, that's pretty cool. Perl is better too, I do agree with that. So here's ref. Here's the size of the entire file. I don't know if it works or not. This is AV, and inside of AV we have list with HDRL. And by the way, this is Bullscheiße, meine Freunde. As far as I know, list has to also include the size of the type. Right, so list, yeah, it has to include the size of the type. We found the bug. We found the bug. Let me see. So I can do unchop list. I can do unchop list, and in here we have to add the size of the content, right? Plus size of I suppose 4cc. Yeah, size of 4cc. And both of these things, by the way, has to be U32, right? We might as well, okay, so just say content length, content maybe size, or maybe even list size. So it's going to be let list size, we put it in here. Right, so it's a sum of the content length plus the type of this entire thing, plus the type, and there you go. So that's basically what we have in here. And to be fair, list is basically like a sub-chunk. I don't really know why I'm separating them, but it's kind of like a sub-chunk. I feel like I'm making it a little bit more complicated than it should have been, but I think it's fine for now. Yeah. Okay. So let me see. Yeah, so now it contains this size specifically. It contains this size. So when it comes to the chunk, so this is the chunk size. Yeah, so it just doesn't contain anything, and I can save it as is. So there is no problem with any of that stuff. We can take a look at hexel mode. So hexel mode, and so this is ref, and this is more like 10. All right, so it's 16. Right, so if I disable text mode, yeah, 16. So 1, 2, 3, 4. Is it really 16? I don't think it is 16. Right, so this is, yeah, this is 16 character. Yeah, so 4x4 is 16. So everything checks out. Everything checks out so far, which is great, in my opinion, which is great. I kind of don't like unchop list, right? So let's actually do something like replace write list. I think it's like a little bit easier for my mental model to think about, right? And this one is going to be write chunk. It's kind of funny for a meme value, right? But when it comes to actually writing code, I don't want to call it like that, honestly. Okay, so HDRL. Let me try to hack a V file format one more time, just to see how HDRL looks like. Even I can't see Scheiße in this mist. Ah, this is because it's a wrong AV. Yeah, I overwrote that AV file. Okay, fuck. So I probably have to have like a separate copy of AV that I'm generating. So when I'm fabricating, let's call it fab. Right, so let's just call it fab so it doesn't overwrite the file format that is like a legit one. So let's do render. Right, so let's recreate AV file that we were working with. Right, so that seems to be working. So here it is. So now if I do not really AV, well, yeah, AV. Let's do AV. So here it is. Here it actually is. So instead of HDRL, maybe let's not hack it per se, not parse it, but more like dump it as a tree. Let's dump it as a tree. So, okay, and inside of HDRL, we have the first chunk, which is a Vih chunk, So, all right, that's kind of interesting. And by the way, we completely forgot that chunks must be aligned. Right. So chunks must be aligned by 2 bytes. So we'll need to take that into account in write chunk function. So where is the write chunk? So it doesn't have to be the case for lists, because the list consists of chunks. So if they are aligned, the whole list is aligned anyway. So it's totally fine. But in here, so the size might be unaligned, but the actual content of the chunk must be aligned. So let's maybe grab this thing. I'm going to call it chunk size, right? So this is the chunk size, and this is chunk size, like so. We're writing that chunk size. Okay, so if it is unaligned, chunk size mod 2, right? So we're aligning them by 2, is not going to be equal to 0, right? So if it's not equal to 0, right? If it's not equal to 0, I suppose we can just write an extra byte, right? So sync write 0. That's it. So to align it. If it is equal to 0, that means everything is aligned. Yeah, we're aligning them by word. So pad size. Yeah, so here's the pad size. And we put 2 in there. Okay, so I suppose it is correct. So everything's fine. So this is a good way to align it. I think. What do you guys think? I think it's a good way to align it. Anyway, so fabricating a vih. So now, I suppose maybe I can actually release the plebs already. So we've been coding long enough. So plebs, feel free to say something if you want to, of course. So we need to do the chunk, and chunk, a vih chunk contains the main header. Okay. What I want to do is rather interesting. So this is HDRL. Can I have something like fabricate HDRL, which is also going to be IO result vec u8 HDRL, and this is how we are writing the whole thing, but this is the content of HDRL. So that means what I have to do, fabricate HDRL, fabricate. So we need to say fabricate. So this is 9. I'm just fabricating that, and I'm taking slice of that. All right. So when I'm fabricating this entire thing, I have to write a vih in there. So write chunk. So this one is going to be mutable HDRL, which is a vector. Can I just say equal to vec new and expect it to automatically infer the type? I think I should be able to do that. So this is a mutable HDRL. This is not particularly efficient way to construct this file because I'm creating too many copies of the vectors. But this is just like one way to do that. So I don't really care about efficiency right now, I think. So inside of this thing we have a vih, which is basically ID for cc from u32 a vih. And the content, this is the most interesting part now, by the way. This is the most interesting part. We have to, yeah, we have to write it. So I think it's going to be totally fine. So we have to take the default main header, default AV stream, default main header. So that's what it has to be. All right. So I take that. So this is the thing that we have in here. But I want to transmute that to a slice. So I need to somehow maybe, I don't know, let me think. Can I just literally refer it as a pointer? Right. So I'm just referring to it as a pointer. And then I transmute this thing to to just const, I suppose, const u8. So that's what I want. I want to transmit it to const, and obviously it's unsafe, but it doesn't matter. So it's going to be mem transmute. So I reinterpret casting it and stuff like that. So, and then I should be able to construct all that shit from raw parts, right? So from raw parts. Construct this shit from raw parts. So I should be able to construct the slice from raw parts. Yeah. So let me see. So this is the slice, slice from raw parts. The data is this shit. The data is this shit. The size, though, the size is the size is the size of the structure, the size of the type of that structure, and the type of that structure is what? It's a v main header. That's what it is. Size of, let's put it in here, and this is the slice, right? So that's the content that you can put in here, like so. Yep, that's the content. So which is very interesting. It feels like something that should be in a, like factored out in a separate function of some sort. We already have transmute chunk. Yeah, this one is interesting. So transmute chunk, but this is kind of an opposite thing. We have chunk and we are turning it into a struct. So this is literally like an opposite operation. This is literally an opposite operation. Maybe, oh my god, can you just jump back to that transmute chunk? Maybe we need to have something like transmute struct. So we say that it accepts lifetime and it will accept that struct, pointer to that struct. So I'm gonna call it just s, and this is that. And it will return me the chunk itself, right? So this specific chunk like that. So yeah, and let me just grab that. So this is t, and this is the thing I'm taking in here. I'm transmitting it as a pointer to the slice, and then I'm constructing slice out of this entire stuff like this. And obviously this one has to be t. So transmute struct. And because of that, maybe this kind of stuff should be called transmute struct to chunk, right? And this one has to be transmute chunk to struct. Yeah, something like that. So let me query replace the whole thing like to struct. Not even struct, but more like type. But okay, so I already called it struct, so I'm not going to change it. So, and I'm not even sure if this has to be, yeah, so that's roughly the operation I want. Aren't you transmitting? Whatever works. Okay, so here, what I'm gonna be doing, I also need to provide the 4cc, so it has to be more like ID. 4cc, so this one has to be more like chunk. So this is ID, and this is the content, right? And save. All right, so might as well actually maybe call that a content. Something like that, and just like this. So I'm not really don't like that here is the reference and here is by value, but maybe that's fine for now at least. So yeah, well, yeah, I think it's fine for this specific case. All right, let's go through the compilation errors. What do we have in here? Fabricate HDRL. So in here, what I have to do is just transmute struct to chunk, right? So here is the default AV stream header and maybe main. Is it not AV? What was the whole main header? Yeah. So I'm taking the reference to this entire thing, and I also, so the ID was first in here. So the ID is HDRL, and this is more like a 4cc from U32. I'm doing too much Tetris type Tetris, and I don't like it, like how much type Tetris I'm doing. It's like too fucking much type Tetris, which like anyway, whatever. Okay, so what else do we have in here? So cannot shadow constants. Well, I mean, we can call it results. It's kind of weird that you can't shadow constants though. Unresolved create slice. Use std slice. Okay, so mem transmute one generic parameter. So function takes two generic parameters, but one was provided. This is not true. Oh yeah, so from which to which? Yeah, we're constructing. So it has to be the other way around. So we're taking that, we're translating that to the pointer, then constructing a slice out of that, and that's the slice that we get essentially. And yeah, so lifetime of that slice is kind of unclear, but that's fine. Sync right, can you just make it like this? Right chunk mismatch type, so it has to be an error. So it's not really right chunk, it's, yeah, so question mark, and we just return OK result. Ah, fucking, I hate Rust. Such a stupid ass language. Anyway, so it's too much fucking bureaucracy, like that has nothing to do with what I want to. It's just like, holy fuck. Such a stupid ass language, I swear to God. Anyway, what do we have? So we do HDRL. So we're writing that HDRL into the list and so on and so forth. Let's try to now fabricate a V file. Fabricate a V file. So it fabricated the AV file more or less. Look at that. It now contains HDRL, right? It now contains HDRL and so on and so forth. I want to be able to maybe inspect that file as well. So I want to be able to just pass it into hack AV file and just like dump it and see what's inside of it and so on and so forth. Unfortunately, it's not that freaking easy. Though, okay, so hack AV file. So here we're hacking AV file. Yeah, so let's dump it as that. I'm gonna change it to fab AV. All right, so let's inspect. Okay, this one is interesting. Looks like shit. This has nothing to, so it has HDRL. It has HDRL twice, right? So, which we already caught an error, by the way. We already caught an error, and the error is when I do, so this is that, and then inside of the HDRL, this has to be avich. There we go. So let me maybe, yeah, we can do something like that. We can fabricate a file and then we can hack it right away. Who said we can't do that? We can do that. Yeah, there we go. So generating fab AV, read this file, and this file is HDRL avich. So yeah, so you have list, and inside of that list you have one avich file. So which already kind of makes that fabricated file more or less like a, look at that! So this is the meta information that we got from the main header file. So this is the main information. So and we can already read that. So we can try to maybe play with MPV. It still couldn't open it up, unfortunately. It still couldn't open it up. So, but anyways, so let me see. I can try to now just hack this file, right? Just like, let's look inside of the main file that we have in here. So, and now we're having lists for streams. So the first one for the video stream and the second one for the audio stream. So that's what we need to have in here. So we also have a lot of junk in here, NVPRP or whatever. I wonder what that junk contains. We can try to inspect that. But maybe it's just FFmpeg just like leaving its traces, so like they know that it was generated with FFmpeg, so they can cancel somebody on Twitter, right? So specifically, they keep all of that information in the junk chunks. But from the specification, right? From the specification, I don't see that these junk chunks need to be there, right? So we're not going to be generating them. And by the way, this VPRP also not needed anywhere. So we're probably not going to be generating all of that stuff. Okay. So let me see. So let's try to generate the first like a video stream chunk. Oh, by the way, maybe we should try to do a probe on a fabricated one. So ffprobe, invalid data when processing. Okay, so it couldn't even open it up. So, but that's fine. It's just like it doesn't have enough stuff. Alrighty. So what do we have in here? So fabricate a V. As we are fabricating a V, so we are fabricating HDRL, and so here is the HDRL. And honestly, so am I doing it correctly? So what if I, yeah. Maybe that's fine. Just like it buzzes me that this one is a value and this one is a reference. But anyway, so let me pour some water. Just a second. Let me pour some water and we're gonna continue. All right. So struct to le chunk. Structure chunk. So HDRL. So we need to fabricate STRL for video, right? So video STRL. So we need to fabricate that. So this one's going to be that. And we need to have an audio STRL. So that's what we're going to have. Fabricate video and audio. So then I need to save them. I need to write those chunks. So I'm writing them into the result. Right, so here is the result. And I'm writing that as a chunk. So this is just a content. So let's comment it out, because what I need right now, oh yeah, it wasn't here. So strl, it's actually a list, right? It's actually a list, but I mean, nah, it's fine. Fabricate strl. So this is the list, and the type of the list is strl, right? It's that, and the content is that. So we're just writing not really chunk but list. So this is first list strl, and then the second one is going to be for the audio. The second one is going to be for the audio, and that's it. Junk is not needed in here. Info, I have no idea what the fuck is that, and not a junk, we don't care about that stuff. All right, so let me see. So is it going to even compile? It's not going to compile, obviously, right? So, but strl mismatch. So it's a 4cc. Can I do something like that? 4cc from U32. Right. So this is fabricate video strl. That's understandable. This is IO result. Vec U8, so this is to do, and then going to be audio strl. That's the things we're doing. So list has to be a reference. Obviously, this has to be a reference. Blah blah blah. Yap. So okay, now we need to do strl. So I probably want to actually save the trace of the thing in here. So here we're just fabricating, but then I want to hack it. Right, so okay. So I want to save this trace because it's immensely useful for what I'm doing here. So av, so output av trace txt. So I'm gonna just save it in here, right? Because I'm constantly referring to that, and I don't want to be rerunning like a different program over and over again as I'm fabricating this entire thing. All right. So yeah. So here's the trace, and we need to start generating strh, which is the stream header, which is the stream header. So strh, and it's a chunk. So we should be able to now transmute something interesting. So we are transmuting. We're gonna fucking transmute. We're gonna fucking transmute. So strh, right? So this is strh. And instead of default AV header, we have to do default stream header for the video, right? So we're transmitting that, and we're getting the chunk. So the result is obviously going to be a vector new, and what we're simply doing is we are returning that final vector. So OK result. Okay, result. So we're going to transmute this entire thing. So this is strh, and I'm writing that as a chunk. I'm writing that as a chunk into the result. I'm constantly having like a strange feeling that maybe there is a simpler way to organize that, because chunks and lists feel like the same thing. And if I realize what kind of same thing it is, it will become easier to manage all of that stuff. But I have no time for that. Like I already spent way too much time like messing with all of this stuff. So anyways, so this one is strf, and this one has to be default bitmap thing, because this is a video format. So this is a bitmap thing. All right, that should be enough, and which makes it super easy to implement the audio. Right, it's just like instead of widths we have outs, and this is wave format X. Right, so this is what we have in here, and I should be able to now maybe go through the compilation errors. Right, so this is that, and this is that. So this has to be a reference to the chunk. This has to be a reference to the chunk. What else do we have in here? It's that, it's that, it's that. Okay, so we fabricated another file, and it's now bigger. As you can see, our file becomes bigger and bigger and bigger. So it starts to have strl, strh, which is weird, honestly. It doesn't have to be like that. Or does it? Yeah, it may be like that. So because here is the list, here is the size of the list, here is the list type. And then inside of the list tab, you have a strh, and this is internal vids and strf. So you may, I feel like you may have this combination of like sequence of characters in a V file. I think it is a valid sequence of characters. If we take a look at the real AV file, we may probably see it, but I do not know for sure. So it's half of a gigabyte, so Emacs is having a little bit of a trouble, like opening it up, but I mean, whatever, just open it up. Convert hexel. Can you just disable hexel? Emacs, shut the fuck up, Emacs. Stop asking questions and just do what I told you to do. Okay, so what is it called? Just open the freaking file. I know it's big. Just open the file. Okay, thank you. So yeah, here they are, strh, strh8. So that's a thing that may happen in here. So that is totally understandable. Perfect. All right. So we're slowly building up that file. So hdrl avih and so on and so forth. That is also looks like a AV file. If I take a look at this kind of thing. All right. So uncompressed. So video uncompressed, audio mono 48 Hertz, and so on and so forth. That's the data basically of the metadata. So that's pretty cool. Furthermore, we can try to maybe use our tool to trace the fabricated file that we just generated, right? So I can put fab in here, and hack file, when it's tracing that specific file, is just like a dumping it as a tree. All right, so what do we have in here? I have to build everything from scratch now. To FFmpeg for you, what it was called AV. Okay, all right. So here it is. So this is the structure that we generated. So this is the structure that we just generated. It doesn't have any junk files, junk chunks or anything. So info chunks or whatever FFmpeg generated in there. So it doesn't have any of that stuff. At some point, we'll need to look inside of them, I think, just to know what exactly FFmpeg puts into those junk chunks. I'm pretty sure it's some sort of breadcrumbs, like some sort of maybe watermarks, right? So again, if somebody's claiming that they created like FFmpeg from scratch or whatever, they're just FFmpeg wrapper, they can look inside of the file. Okay, here are the junk chunks generated by FFmpeg. You are a liar. Cancel them on Twitter. So I think that's what it's meant for, maybe. Or maybe it's just for some sort of like a memory alignment. It's a junk is alignment. Okay, so very well then. So, but we're not going to be aligning anything. But what's the point of alignment? So to have a better memory access patterns? Maybe that's the reason. That could be the reason. So what's the next thing? The next thing, chat, is to freaking generate movie chunks. It's to generate movie chunks. Let's take a look at the trace. Where is the trace? Here is the trace. Because we generated everything basically up until this moment. Right. So we need to start doing movie chunks. So here's the thing. What is this? Is that a single frame? Or, for example, what is this? Is that... So I know this is a video chunk. This is video chunk, and this is audio chunk. I suppose these are frames. Okay, let's do a little bit of a back of a napkin calculation. So a single, so we have 48,000 samples per second, right? So that's the frequency, like a sample rate of audio. If we have 30 FPS divided by 30, that's how many samples you have per frame, audio samples. Let's actually, well, I mean, yeah, I was thinking maybe I need to do integer division, but it's not needed in here. It's actually divisible perfectly. Now multiply that by 4, because each individual sample is 32-bit floating point in our case, and it's actually 6, so it doesn't line up. So what is 4 kilobytes specifically then? What is 4 kilobytes specifically? I'm not quite sure. And what is like how do you even divide them up? Like how do you divide them up? So 800 by 600 multiplied by 3, that adds up. Okay, I'll give you that. That adds up. What's up with audio? What's up with audio though? Or is it really 4? So I don't remember actually, honestly, in terms of like audio. Is it 3? Where did they get the 4 kilobytes? Honestly, I'm actually not sure. So this is obviously a frame. As you said, EZP is it is a frame. It's kind of clear. But with the audio, I'm not sure. I'm actually not sure. So let me see. Audio terminology is so annoying because samples can mean multiple samples due to channel count. Oh yeah, we have also multiple channels. I forgot about that. So let's take a look at how we render the whole thing. So here's the PCM F32, you know, the thing. The usual thing. So that means it has to be 4 bytes. Each sample has to be 4 bytes. So I'm not quite sure. So what exactly are we doing here? But let's take a look at the renderer. So when I'm doing the render, so there's also audio sync. Alright, so this is the renderer of the animation. We take samples and convert them to the bytes. And where are the sample? It's a single sample. You have a sound. You have a sound. Where do you get the sound? It's a vector of... Okay, that's understandable. It's just a vector. It's just a vector of floats. Okay. F32s, and we just put them in there. We just put them in there. So for each individual frame like that, we can try to just put them in like frame by frame. Just put them frame by frame. Who said we can't do that? We can try to do that. It's not that big of a deal. So, and like every time we have a frame, we just like put two chunks. We can have in here movie, which is going to be like a vector of U8. Vector of U8, and let's actually do something like that. So that's pretty cool. And so we just take the vector and we save the thing in there. Okay, I think I need to make a small break, chat. So we're already coming to the point. Where we're like basically need to just generate the chunks, and we're super close. But I'm a little bit tired dealing with the Rust bullshit, so I definitely need to make a small break. I need to make a cup of tea, right? So, and after the break, we're gonna finally generate the video, hopefully, without using FFmpeg, completely from scratch, hopefully. So the problem here is that it's gonna be a little bit hard-coded, right? So, because we literally just like took out the headers out of the generated video and we just like put it in there. So that means if we change the parameters of the video, it's not going to work anymore. But I think that's totally fine. All of that can be unhard coded later. Always can be unhard coded later. So it's not that big of a deal in my opinion. All right, let's make some break and we're back. So let's go ahead and just try to generate the frames. So we'll need to generate frames in BGR 24, right? So that's one of the things we'll have to do. So we have state render, and we have a canvas, by the way, right? So we have a canvas, and canvas is just I don't even know what's the type, U32, I suppose, right? So it is U32. We have a function canvas as frame, and a frame is YCBCR frame. Right, so this is a YCBCR frame. So we need to have a different kind of frame for BGR. So I want to introduce something like this. So how can I call it? Frame BGR24. It would be nice to also rename this to YCBCR, YCBCR frame. But then renaming it is going to be pain in the ass. But maybe this is something that I should do anyway. This one, so this is a single frame. How are we going to be storing all of them? That's a very interesting question. I suppose we can just say that it's just basically pixels. It's a vector of U8, right? So it's a vector of U8. And in here, so it's a frame YCBCR, right? So this is a YCBCR, and we need to have something like a canvas as frame BGR24, and it's kind of similar to this. So this is going to be that frame BGR24. Put underscore in here. Put to do in here. Let's try to recompile this entire thing. Just recompile. All right, so this is a frame. Let me query replace each individual frame with YCBCR. Super quick, hopefully. All right, so this is a frame YCBCR. All right, so and another one that is important for us is going to be BGR24. So when it is mutable, and how does it reset the frame? Right, so it saves the frame in here, and then it probably maybe does that in a canvas as a yeah, it does the clear in here. That's totally understandable. That's totally understandable. Okay, that's cool. So this one is let me also query replace this kind of thing. I'm going to be query replacing that with YCBCR. YCBCR is just a color space that like RGB and whatnot, right? So that's what it is for those who's curious about this kind of stuff. All right, so YCBCR, and we're saving the frame. We're saving the frame to here. This one is interesting because we're saving the frame as specifically U4mpeg. I forgot the name of this stupid thing. It's U for FFmpeg 2, right? So you have to read it like in an opposite direction. So, and the name, yeah, U for FFmpeg. The name of that format, the container specifically, is this. So we might as well just call it like that. Save frame FFmpeg, all right. So, and it is implied that the frame is in this particular color space, right? So it is kind of implied in here. Okay, so now I'm gonna just do something like that, and this is a frame YCBCR, and we're saving the frame as FFmpeg blah blah blah. Shit. Okay, so and that's fine. So that seems to be working. That seems to be working more or less. Okay, that's cool. So what I want to be able to do, I want to now call this thing here on each individual frame too. So I provide the canvas, and I provide the BGR24 frame or whatnot. And then we're going to be saving that frame to a V. So that means we'll have to have a separate sync for this entire thing. And it's going to be like a video sync in here, as you can see. It's kind of a video sync. So I'm not 100% sure. So yeah, let's call it just movie. So I already created movie, right? No, I already removed it, I suppose. So it's going to be movie vec u8, and it's a movie list chunk of the AV. So that's what it is. So, and when I'm saving the AV frame, I'm going to be providing literally just movie. So I don't have to provide that stuff in here, right? So none of that stuff is needed, but a BGR24 is in fact needed. BGR24. And by the way, saving the raw version of the video, I think is not a thing that is needed anymore. Right, so I'm going to remove that, and I'm going to remove the rest of the related to that code in a compiler assisted refactoring session. So that's going to be the idea. So we also sometimes save audio into sync, right? So in this one is rather interesting. So this is the sample for a single frame. What I want to do in here, so in here is just like, this is audio sync. This is just an audio sync, but what we have to have in here is a save. Let's call it this video frame AV. So then later I can say audio frame AV, and we're also saving it into movie. And what I'm doing in here, I just provide the samples, right, that we got in here, and we convert them to bytes. But it says so it's a sound, right? So I'm not really sure what is a sound. Right, so what is a sound? Sound must be, yeah. So let's just take a reference of this entire thing, and obviously this probably will return. So this is roughly what I want. So save video frame. So what was that? Frame AV. Did I lose that? Save frame. Yeah, let's just recompile and see what we need to have in here, right? So video sync row is not needed anymore, right? So this is not a thing that we should be doing. So let's remove the row sync. Removing the row sync, so row sync is not needed anymore. That's completely fine. Mute. So what does it say? Mismatched type. Canvas as BGR24. BGR24. I see. BGR24. Let's go. So what else do we have in here? So it doesn't have default. That's totally understandable. Like, why do we even have to like do this stupid bureaucracy with derived default and like why? Why do you force your users to do that? Can you just like detect then in the context when I create a variable and request a default value and just automatically generate that thing for me? And if I don't request, do not generate it for me? Or is that against some sort of a philosophy, just like everything has to be explicit or some bullshit like that? Just like, I don't fucking know. Why you for like, it's too much fucking manual labor. Too much manual labor. Okay, so save, save frame. Save video frame v. Right, and we're gonna have obviously sync. So this is the sync, and we are accepting the frame BGR24 IO results, something like that. So this is to do. All right, and then we need to have the audio frame. So this is going to be audio frame. So this is a sync, and so on and so forth. So sync. So this is going to be just a sound, and I expect the sound to be just a sequence of F32s. So that's kind of roughly the idea that we have in here. Sync 32s. Thinks 32s. All right, so pixels are not used. That's understandable, and that's because we never really generated any of that stuff. Okay, so let me try to maybe run FFmpeg for you, and we're gonna just say render, and obviously it panics in here. So we're trying to save BGR24. Cool. So we're getting places, and I want to save a frame. If I take a look at the trace, here is a single frame that I need to save, and is going to have an ID 00DC, right? So that's totally fine. We might have as well even hardcode that, or well, I mean, we have 4cc to like from str to do that. Save, yeah, canvas. Oh, it actually, yeah, it fails in here. So that means, yeah, we need to convert canvas to something else. Okay, cool. So I'm iterating each individual pixel in a canvas. So that's what I'm doing, each individual pixel in the canvas. And as I'm iterating this entire stuff, I probably need to clear the frame, but not really, like pixels of the frame. So I need to extract RG and B. How do we extract RG and B from here? So here are the RG and B, and this one is actually rather interesting because we're converting it right away to floats, which is probably not something that we want to do in here, right? Which probably not something. We probably want to keep this thing as U8. That makes sense to me. So this is going to be RGB. And since it's a BGR, I suppose what I want to do with pixels in here is just push BGR. That's it. So that's basically my conversion of the frame to BGR24. So we just sort of like packing them together. All right, so let me rebuild the whole thing. Fuck, forgot the dot in here. Okay, so it's failing here. So save video frame AV. That's very cool. This is what I want in here. Cool. So this is a sync, and this is le frame. Ooh, chocolat. So trace. We need to write chunk. We go into AV, write chunk. So that's our chunk. So we take the sync. We already have the sync. We need to construct chunk. The idea of that chunk is 0DC. I can always do something like 4cc from str. That's what we have in here. So that's what we're constructing. And the content, the very interesting part, content is going to be the pixels. And it's already bytes, actually. So it's already bytes, so I can just do something like this. And that should write that specific chunk correctly, hopefully. And that's already IO result. So that should be compilable nicely. But here's the thing. We don't have any of that shit. So what we probably need to do is to directly try to access a V, and it's actually kind of cool how nicely it names spaces, all of them already, right? So but none of those things are public. So resolve to unresolved module AV, unlinked crate AV, blah blah blah, blah 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 blah. So I probably have to do something like super AV. Is that what I have to do? Feels like what I have to do. Right chunk is private. And of course, what that means, I have to go and now for each individual fucking stupid thing that I used to use totally fine, I have to humiliatingly put pub. Yes, yes, I do want it to be public. Yes, 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 I do want it to be public. Fuck's sake. Such a fucking annoying language. It is, I'm telling you, it is specifically designed to be as annoying as possible for no good reason. And every time you say that there's no good reason, they just say, safety, safety, shut the fuck up, shut the fuck up, safety, safety. It's like, it's so also very fucking abusive as well, right? Insane. Fucking insane. So anyways, so from str is also private, obviously. Now go through all of these stupid little things. So mismatch type option. Okay, so this one may fail. Let's do unwrap in this specific case, but I mean, it should be const, right? So it should just like fail at const time. Right, there we go. So it fails now at audio. Okay, that is very cool. So that is very cool. AV, write chunk, sync, and we have AV chunk. So the ID in here, according to our trace, and again, so this has to be more flexible. We're hard coding too much. But as soon as we get something working, we can start unhard coding those things. Right. So the goal right now is to have something working. So here's the content, frame au chocolat. So, and this is the sound. And I need to reinterpret this slice into bytes. So Eskil Steinberg had an interesting rant about safety security. I've seen the video, but I haven't watched it. Yet. So yeah. So it's just like they're using security and safety as a ways of promoting the language. Right, because now it's not an engineering question, it's a moral question, right? So they basically turning an engineering question into a moral question. So they're trying to get rid of the engineering as much as possible. I swear, with Rust, I can almost understand the thinking behind Rust decision, but also why. Yeah. I fully understand Rust, by the way. So I criticize Rust all the time, and you cannot use skill issue on me because I wrote a lot of complicated and cool shit in Rust. I definitely do not have skill issue with Rust. Like I've been using Rust pretty efficiently. I fully understand every single little decision behind Rust, and I disagree. Like, I fully fucking understand that. I disagree. I don't think this language should be like that. Like, I don't think serious system language should be like that. I just don't. So, yeah, sorry. So what we need to, is there like a way to easily convert, like transmute slice though? Is there any like easy way to transmute slice without using unsafe or anything like that? Transmute slice. I feel like there's no, like you have to go through this, yeah. You buffer struct and, well, I mean, this is not what we want though. This is not what we want. So what I'm thinking essentially, right, so I need to do sound sound as PTR, right? So I'm taking a pointer to this specific slice, and then I'm trying to essentially transmit. Well, I mean, I can do something like as const u8. Well, it has to be something like this. And then I do slice from row parts, right? So slice from row parts. And the base pointer is this, but the size is rather interesting because it's going to be length multiplied by the size of the type inside of this entire thing. Something like this. So this is the slice that I need to basically construct, and I think there is no simpler way, right? So because it has to be like, you know, annoying like that, because you do an unsafe operation, right? So it has to be annoying like that, unsafe, and obviously I can do it like that. All right, so here's the chunk, and so on and so forth. We're writing all of these chunks. We're collecting all of these chunks. So yeah, it's pretty cool. Okay, so let me try to. So this is the slice. It doesn't have the slice. Use std slice. Yep, it is rendering, and it's rendering into the memory, by the way. So it generated in the like a YCBCR format, right? So, but it also generated in BGR AV format. We just didn't save it to the file, which is kind of funny, isn't it? All right. So what we need to do in here. So as we are generating, okay. So we're generating everything on the fly with this format that we already worked with. We're generating everything on the fly, but with AV, we kind of pre-buffering all of that stuff, and that is because of the skill issue of mine. Well, I mean, not really a skill issue, it's less like I don't have time, but maybe the reason why I don't have time to do that properly is because of the skill issue. Who fucking knows? Maybe that's the reason. Anyways, so let's start lithofabrication. I didn't actually check when I do these kind of things. So microsec per frame is that. Maximum bytes per second, whatever. There's some flags. Here's the thing. Total frames. So we have to, we have to parameterize that. So because of that, we need to refactor this thing into a function which accepts total frames. Total frames, which is, I don't remember what it is. What is it? D-word. Okay, so let's call it D-word then. D-word, and it returns AV header, and yeah, that's what it returns. That's what it literally returns. So yeah, so that's one thing we have to like literally customize. And now if I go through the compilation errors, so what do we have? Yeah, probably have to be like that. I do enjoy programming in Jai, insanely. You won't believe how much I fucking enjoy programming in Jai. But at the same time, like I can't do that. So I actually, yeah, because not everybody who watches me has Jai. So, and John doesn't give a shit. Well, he kind of does. Okay, so that's unfair to say that John doesn't give a shit. He kind of does, but at the same time, he's really want to like do a good job on the language, right? It's just like it's the like 9 women can't make a baby in 1 month situation, right? It's just like the dish is ready when it's ready, so you can't make it cook faster if you just crank up the heat. You can only make it worse. You can only ruin the dish by doing that. So I don't know. And at the same time, he's not working on the language, only on the language. He was also making a game in that language, right? So it's like 2 projects simultaneously. And I think, honestly, that's the right way to do language. Because if you're making a language and you don't use it for anything, there is no reason for your language to exist. You might as well not do a language, right? So language has to be grounded in reality. So Doc40 is always great. So if I ever gonna create a language, I'm not gonna be creating it like for nothing. I'm gonna be creating it for a very specific purpose. That's for sure. Because I think we have already way too many general purpose languages. Me looking at Huya. Well, I mean, Huya was created for a very specific purpose, for a meme. So yeah, and it worked great. So Huya is perfect language for what it was designed, for a meme. So yeah. Porth is also was designed with a very specific purpose in mind to learn like language development in general, and also to learn how to do self-hosted languages. So that was another thing. Yeah, Tula, another language of mine. I think like this is one of my favorite languages that I created, honestly. But only nerds can appreciate this language. Only nerds can appreciate the language. It was created to actually explore Turing machines, and the fact that I managed to implement a Turing machine in Turing machine actually means that I understood how they work. I understood this computational model. Tula is insanely cool language. Like I really like it, and it just breaks my heart that I can't sell it to a general audience. It's too fucking nerdy. It's too fucking nerdy. But CS students, when they discover this language, at least from my experience, they go nuts about it. Like when they understand how this language works and what it's doing, it's actually really fun to play with, right? So if you are into CS, give this language a try. You may like it. It's a very cool language. Does it have? It doesn't really have. I didn't come around to do any busy beaver examples, but it has rule 110. Does that count as a good example in Turing machine? Right, so there's also Turing machine. In Turing machine, I also implemented bubble sort. So that's the bubble sort in Tula. So there's a lot of... Oh, wait, there is a BZB. Holy shit, I forgot. There's a BB2. Wait, did I? Yeah, I think I edited it. What the fuck? I don't remember that. I could... All right, there is a busy beaver. If that's what you want, there's a busy beaver too. Like, I mean, it's a very small busy beaver, but anyway, nonetheless. Oh, I even solved a couple of like Euler problems in Tula. Yeah, you can solve Euler problems in it, so it's kind of like suitable for that as well. As soon as you slap set theory on Tula on Turing machine, it becomes like a legit language that is usable, surprisingly. As soon as you have a mechanism to mass define rules, it is a very useful language. And that's what Tula is trying to do, right? It's a bare bones Turing machine, but on top of Turing machine, there's a mathematical mechanism to mass define rules, right? And it's actually super cool how it works. So you can define sets, and through universal quantifiers, you can generate rules in a generic form, right? Not just like write each individual rule, you can generate them. And it's still finite amount of rules. Well, there's some magical sets that kind of act like infinite sets, but I mean, we're talking about computers, so they are finite nonetheless. Anyway, I'm really sorry for that nerdy shit. So let's actually continue writing the like AV stuff. Anyways, so what do we have in here? So this one is more private, and this is because this entire thing is not private. Okay, so let's put it like that. So this thing, so it doesn't like that this AV header is like this. We can make it public. And I suppose maybe we have to make this thing private. Well, since we're constructing the structure out of the like function, maybe that's totally fine. So I just finished my CS degree, so all this stuff is fresh in my mind. I have to check out Tula now. Yeah, check it out. It's pretty cool. Check it out. Okay, so what so special do we have? So this is a V. Wait, is FPS 60 FPS? Do we generate with 60 FPS? I thought we're generating with 30 FPS. Wait, renderer. So what is FPS? Where is the FPS? I don't see FPS. Chat, I don't feel my FPS. FPS. It's 60. $48. This one, I can even put something like that. Divide by 60. Multiplied by 4. Nah, doesn't add up anyway. Doesn't add up anyway, so not sure what the fuck is. Something fucky-wackish going on. Something fucky-wackish. But anyway, we're gonna just ignore that, right? So we're gonna just ignore that. Maybe it's like aligned or something, but anyways. When I write the chunk, do we align chunk? Yeah, we do. Yeah, we do align chunk, so everything seems to be fine. Everything seems to be fine. Everything seems to be fine. So fabricate the video. So I don't think we need to customize this thing. Right, so this is just a frames length. Yeah, fuck. This is length in terms of the frames. So that means we need to customize that. This is just like a parameter bit count and whatnot, so 24 bits or whatever. So the audio length is that stuff. It's just like amount of samples. And if we have 60 frames per second, okay, 360 divided by 60, this is how many seconds we have. So this is 6 seconds multiplied by this amount of stuff. Checks out, I guess. Checks out. So this is the length. So default AV, default stream. We also need to customize them. Yeah, we also need to customize them. So let's quickly do that then. Yeah, FN. So public FN default AV stream had widths, and this one has to be DW length, which is D word. So D word, and let's put this stuff in here. Well, I mean, we don't have to return that, that's for sure. D length, boom. All right, so that's what we have in here. That's what we have. And this is a bitmap. Bitmap doesn't require any customization. This one does require customization. Pub FN, so default widths, W length, D word. Return that. So this is that, DW length. Put that in here. All right, so let's try to recompile this entire thing. Let's try to recompile. Oh boy. Okay, so this is a return. This one is a return as well. So this is vids. So this is gonna be 0, right? This is gonna be 0, and this is just that. What's next one? For the audio, this is just that. But interestingly is that we can basically maybe accept DW length in here just to pass it to the corresponding things. DW length, D word, not D length, D word. So let's grab that, DW length. So now every time we do that, fabricate HDRL, so this is the amount of, so this is the amount of frames. Okay, so the idea here is the following. So we can have frames count and, yeah, frames count, and maybe that's it. I have a feeling that that should be it. We just accept the frames count. Because the default AV main header, so total frames, we just give you the frames count. And now in a video stream, it's the same frames count as like frames count. And audio frames count is basically frames multiplied by the frequency. That's what we need in here, actually. That's what we need. Because, so what's the frequency per frame? Fuck. It may not actually work that easily. So I'm not sure about the audio, chat. I'm not sure about the audio. Do we understand the audio right? Do we understand the audio right? So what was the value in here? It was... In your there is a 2 consequent chunks. Thank you, Captain. Why do we have VIP? Sometimes I really like ask the question, why do we have VIP? All right. So DW6. What you guys talking about? I forgot what was the value. I need to double check the numbers, chats. I need to double check the numbers. Just a second. So let me go through all of that stuff. So this has to be as d word. As d word. As d word. So in this one, let's put a to do in here. I wonder if we can put to do in here. Can't I put unreachable? Fuck. Yeah, it's just like whatever. So 69 just to do figure out the DW length. I already kind of figured out, like, but I just need to double check that. So you know, I need to double check that. So this one was basically 0. So when we're fabricating, we're just doing that. When we are fabricating, we're just doing that. Okay, so cool. So what is it saying? So it's more private than this thing. So this stream header. So this is that. All right. Okay. Okay. So that's already, like, look how many lines we have in here. Look how many lines we have. I need to go back to hacking the AV file, but I want to hack specifically the original one that we generated in here. So I want to do something like that. FFmpeg for you, AV. Yeah. So, and this is not hacking. Well, it is hacking, but it's just traversing. I want to parse it. Just want to parse it. I want to look inside of it. Stupid dot. Okay. So this is length is that. W frequency. Yeah, that was the original W frequency. Audio. Odes. Go there, please. Thank you. DW. Yeah, it was that. I know that I already did that. I need to double check that. So this is per second. We have 360 frames divided by FPS, 6 seconds multiplied for 48,000. That's amount of samples. Yeah, that's amount of samples, which is, I guess, fine. So this is the rate. This is the scale. Suggested buffer, and it's a suggested buffer size. So why did it speak specifically that buffer size? Because, like, I don't understand. Again, divide by 60, 80. So this is how many samples per second. Many samples per second multiplied by 4 bytes. And yeah, maybe it's because of memory page size. Maybe it is to align with CPU. So that means the chunks do not correspond, the audio chunks do not correspond one-to-one to video. They're kind of drifting. So since the buffer is a bit bigger, it contains a little bit of the audio for the next frame. Because of that, I have a feeling that the amount of video and audio chunks is not going to align in that specific video. Right. So, and I want to confirm that because it bothers me so much. Like when the numbers don't add up, like I don't feel confident to like continue doing anything. Oh, and by the way, W sample size in here. Yeah. So what we want to do in here, we want to parse some things. So this is hack. I want to go here, and as we're parsing thing, right? So we are in fact parsing a V. Then we search for movie. Then we parse in the movie, and dump all chunks with ID. Okay, that is fair. Generated You know what I want to do? I want to count the amount of chunks. Chunk count, obviously mutable. All right. So, and the chunk count, okay, generated file. File. So chunk count chunks with ID, where ID is actually 4cc from U32 ID. Now I feel more or less confident. There's less audio chunks than video chunks. So the audio is in fact drifting. Each individual audio chunk contains a little bit of audio for the next frame. Why? I have no idea. But that confused the shit out of me. It's just like probably, as somebody said in the chat, for the page alignment memory stuff situation, so it's a little bit faster, memory access is faster and stuff like that. And man, that got me a little bit scared, because this is a very sort of a delicate thing. We're working with a very delicate thing. This is bytes, this is binary stuff, right? So you fuck up something, something is unaligned, it's just like it falls apart, right? So you want to be 100% sure, like what the fuck you are doing. So, and I'm not really sure, do we want to generate one-to-one or also make it drifting? I kind of want to generate it one-to-one, and if we're going to be generating it one-to-one, maybe what we have to do is also customize suggested buffer size. 1 bit shit away from random noise, yeah, exactly. So let's actually customize the suggested buffer size, which is going to be let me see. So what is it? What's type? It's a D word. So this is for the audio, but for the video, it's this one. But I mean, yeah, we can actually do something like that. Is a real way to ensure memory safety by double checking the numbers. Well, I mean, yeah, not really sure. Ensuring memory safety is actually hard, even in Rust. So, yeah. I don't think there is mandate on like any of that stuff. But yeah. And also this particular thing is hard-coded. So size image, by the way. So this is the size, but is it a correct size? Yeah, it is correct size, so everything's fine. It's a BGR. If you double check 386, yeah, it is correct, so everything's fine. So we're gonna be hard coding that, but I'm not sure about this one. So for this one, we can, okay, so let's hard code it. Let's hard code it. This is original. So what was that? 48. Suggested buffer size. 48. I'm already kind of phasing out. 60 multiplied by 4. Let's say that this is the new size now, because that's going to be the size that we're going to be generating. So this is the size generated by the renderer. Yeah. Okay, so let's go with that approach. So that means we don't want to do. Actually, I don't want to call them default. Let's call this hard-coded. I'm gonna query replace default. Query replace default hard-coded. Not this one, but this one, this one, this one, this one, this one, this one, this one. Because that's what it is, right? So it's a hard-coded one, and we're not unhard-coding it yet. We're not unhard-coding it yet. Okay, cool. So we have fabricate AV file. Interestingly, what we can do, we can accept movie as a parameter in here. So something like that. Fabricate AV file, which also means that we have to pass the AV in here. All right, so here's mismatch type. What are you fucking talking about? Why are you having mismatch type? So because movie is this thing. Okay, so movie bytes, and this is movie bytes. Let's call it movie bytes. No big deal. So this is a movie bytes. Cool. And we're not using it for anything. So this is HDRL, right? So fabricated HDRL and trace. Neighbors are doing something, I don't know what. HDRL, and here's movie. Which means I can do the following thing: write list AV list. The type of this is 4cc from U32 movie, and then content is movie bytes. Look at that. Content is movie bytes. So we generate HDRL, movie, and that's it. So that's the final thing in here. But this requires knowing the amount of frames. And by the way, what we can do in here, finally fix this to do frames count as the word. And here is the interesting part. We have to, if we have how many frames? 360 multiplied by 8. Yes. So that means this has to be like this. Am I doing that correctly? I think. Because 48, 60, multiply the whole amount, that's the samples, and that's what we saw in the data in here. So that's a correct way to do that. So we pass in a frames count, and we also need to accept frames count in here. So it's going to be use size, so that means we pass in that frames count here. So let's go through the rest of the compilation errors. So when I'm fabricating a V file, I also need frames count, which I'm also going to be accepting in here. Use size. The rest of the compilation errors. Unused result, that's understandable. That's pretty cool. So do we, that's kind of weird. Yeah, we never really used this function, because we never called it. So this is where we have to supply movie and the amount of frames. So that's what we have to do here. Yeah. So this is the function that we're going to be using to generate the final AV file with chunks and shit. So this function must be public. It must be public. So this is a frames count, the file path, and this is a movie chunk. We do in fact have movie chunk, hopefully. Let's fucking go, my friend, fucking go. All right. So here's the movie. So we just have to call this function. So fabricate AV file. And let's say that this specific file is going to be output AV. Fabricated one, because why not? Movie bytes is simply movie. Take that. Frame count. Do we have a frame count already? Yeah, we do. There you go. We have a frame count. Holy shit. So that means I can just straight up pass it in here, and there you go. All right, so this is IO result, which means that I can do probably something like that. So fabricate file. Fabricate file. Okay. So let's try to rebuild the whole thing. Fabricate AV. Okay, so this is going to be AV. It is compilable. Okay, now here is the moment of truth. I'm going to go to render.sh and I'm actually commented out FFmpeg. We don't use FFmpeg anymore, like at all. And now if I try to render this entire thing, it is rendering things and it's not going to call to FFmpeg. Okay, it generated output fab AV, and output fab AV is actually as big as the one that we generated with FFmpeg. It is as big as that. So, and I can open a file in here and it is recognized correctly and stuff like that. And if I open it with MPV, it is a working file. It doesn't have a sound though. So, yeah. So failed to initialize a decoder for a codec. That's very interesting. So it kind of worked, right? So it kind of worked, but we just fucked up the audio. And audio, as you can see, no audio. All right, so let's try to troubleshoot that. Let's absolute sharding. I do agree with that, actually, absolute sharding. So let's actually release the plebs so they can celebrate with us. So that was actually super cool. Yeah, absolute badjuding. Huh. All right, and yeah, 2.5 hours. So anyway, so let's try to understand what is going on. I'm going to go to AV in here, right? And we can try to hack the file, right? And we can try to specifically hack the fabricated file. So as we hack in the fabricated file, let's just dump it as a AV tree. So let's just dump it as a AV tree. What I'm going to do to unpack, what is it, AV, right? So, and yeah, look at that. So it looks all right. So here is the size of the stuff and so on and so forth, right? So that seems to be all right. That seems to be all right. So the main problem that I see probably is that we use an unfinished wave X something. You guys know what I'm talking about, right? So wave X is actually extended, right? So wave format X, right? So it has like 22, size of 22. Maybe, yeah, maybe it just doesn't contain the correct thing. So it's kind of difficult to say. So maybe like we're missing some information. Okay, so let me try to maybe ffprob the fabricated file. And what does it say? It says that unsupported codec with ID 0 for input stream 1. Huh. Fascinating. Fascinating. Let me pour some water, chat. Let me pour some water. Yeah. But I think we're pretty close, honestly. Okay. So let's go back to maybe hacking the thing. So we're already hacking. Okay, so now let's do the parse AV, and we're parsing specifically non-fabricated one. Right, I just want to see what's up with that. Okay. So what do we have? It's something with the sound specifically. So do we have anything about the sound codec or whatnot? So maybe it has something with FCC handler. Total frames, DW. Where does it store the codec? Wait format X. Extensible, and in an extensible we have valid bits per pixels format. I'm honestly not sure. I'm honestly not sure because when I do wave format, here's that stuff. Yeah, here it is. I just print it as it is, but I never really trace the chunk. Maybe one of the things we have to do, we have to dump the chunk. So how do I dump the chunk? I don't remember. So I provide the chunk and the level. Okay, so chunk, level, and also take the reference of this whole thing. Yeah. Wave format. Size of the chunk is 40. Size of the chunk is 40, so obviously it contains more. But funny enough is that it says that it also has 22, so it's extended in a sense. So in here as well, I want to do println padding level 2 here, size of web for wave format x is equal to that size of wave format x. All right, what do we have? Size of, I don't see it. Did you print it or not? Oh, because I didn't put underscore. Yeah. So, and there is no need for extra thing in here. So, okay. That's the main discrepancy that like, this is the thing that kind of bothers me. Right, so the thing that kind of bothers me. The size of the structure we're dealing with is 20 bytes. The declared size of this thing is 22. So that means it is extended. But the actual size in a file format is 40. There's like a lot of additional information in here, and it's just like, where's it all coming from? Excuse me? It's just like, what's, right, how, like, we need to read that. I don't believe as B size is inclusive of the wave format X. Yeah, I think 22 is the size of the extension, doesn't include the actual size. Ah, okay, but in that case, it has to be 42. Shouldn't be 42. Let's actually read this documentation, right? So let's read that. So structure defines the format of a waveform audio data, only format information. Though, wait a second. So it could be, if it is extensible. If it is extensible, so here is 2, 6. What's the size of the GUID? What's the size of the GUID? Okay, so we can reinterpret this thing actually as extensible, because why not? Let's interpret it as extensible just to see what the fuck is going on. Yeah, and you can't even do that because the structure is 48. You can't even fucking do that. Mainly because we have this weird sample union, which could have been just word. Okay, so I think sample union could have been just word. Let's keep it that way. Now it's 44. Yeah. Maybe it has to be packed in a certain way. So we can packed one. Let's say that it is packed. So what you don't like. Does it have to be, like, how do you do that? Repr cpacked, repr cpacked. I think that's how you do that. I forgot how to do that, chat. Oh, yeah, yeah, so it also has to be wave format. Are you gonna be okay? So now cannot move out of the shared, yeah, clone copy. I have to now do this stuff everywhere because Rust. That worked. Okay. That actually explains it. This motherfucker worked. All right. So, and we have samples, and sample is 32, right? So what is samples? And it could be valid bits per pixels, samples per block, or reserved, or whatever. We just call it samples, right? So this is just samples. And sub format. And what is a sub format? Subformat of the data such as KD data format sub-CCM. The subformat information is similar to that provided by the tag in a format tag. Well, I mean, yeah, here's the format tag. And it's literally GUID. So maybe we just have to copy paste that GUID then. Could it be that? Could it be this kind of situation? It could be. All right, so let's start using this as the default format. Outs, where is the outs? Not really. Wave, yeah. So this is a hard-coded one. This is a hard-coded one. Let's put this thing in here. So this is a new hard-coded one. So this is GUID. I feel like maybe it's GUID that identifies the codec or something like that. It could be actually. Channel max. Okay, so maybe there should be channel max. So maybe this is the information that was actually missing in here. Maybe that's the information that was actually missing. So this is 48, and this is more like hard-coded extensible. Yeah, so hard-coded extensible. Extensible. Okay. So let's try to recompile the whole thing. So and in here we're saving hard-coded and extensible. All right, that's cool. So, but we don't really have to do it like that. So now we are actually saving. We're actually saving the extended one, right? So it's actually much bigger. So let's go ahead and try to render the whole thing. Let's try to render the whole thing. Okay, it's generated output fab AV. All right, so let's take a look at the file. Okay, so audio is at least recognized that it's mono 48 something something. Then I can do FFprop. Let's take a look at the FFprop. And so there is an audio. So that was the problem. That was the problem. So, and now let's take a look at this kind of stuff. Chat, let's make an intro. Let's make an intro. We need to make an intro to bait people into watching this entire thing. All right, so let's actually now try to test that. So I'm gonna remove FFmpeg. We're removing FFmpeg from the entire project, right? I'm gonna be recompiling the whole thing, and then I'm rendering the entire thing. And it is rendering, and the most important thing, it produces output fab.avi, and that's the final avi file that we generated from scratch. We generated it from scratch, and it is fucking working. The thing about this file, this is a very interesting file. We generated that avi file without any third-party dependencies at all. All of the video is generated pixel by pixel in memory. All of the audio that you just heard generated sample by sample in memory, and the final AV file was assembled chunk by chunk in memory, completely from scratch, without using FFmpeg or anything like that. It doesn't use any compression or any encoding, right? But we did that for the simplicity. And it works. It took us 3 days. It was horrible. I had to do that in fucking Rust. But I did it anyway. And I think this project, this journey, was actually a pretty good demonstration of how much of a God's job FFmpeg developers are doing. This is just a container, without any special codec or anything like that. And it was very fucking hard. Very fucking hard. But FFmpeg developers have to deal with several containers, several codecs, right? And some containers may not support some codecs, and also different pixel formats. And some codecs may not support a particular pixel formats, and some of the containers may not support particular pixel formats. And this is like a combinatorial cube that they have to somehow architecture into nice little CLI and also a library. And that doesn't include the sound, right? So not only the codecs themselves, they can be patented, they can be very complicated, they can be very mathy, right? So you will have to probably reverse engineer them. Just like architecturing this entire system to contain all of that is extremely hard. So, and yeah, I did this entire project not to like sort of like a dunk on FFmpeg people and say, oh, I can replace you or anything like that. I did this specific project, this 3-day session, to just make people appreciate like what kind of job they're doing. Just think about it. And like they have to support all variety of containers and all variety of codecs and stuff like that. Honestly, another interesting thing would be to maybe try to implement a simple codec, something very old from 80s or something like that. So something like maybe H261, right? So it's a very old codec. So yeah, so from 88, before I was born. And it's a pretty shitty codec. But we already have a V container. That's the thing. We already have a code that can generate a V container. And as far as I know, a V container does support this shitty codec. So we can try to maybe do another session where we explore how to make simple codecs. And there is a technical descriptions of this codec, so it's not, we don't really have to reverse engineer anything. Right, so yeah, it was a very cool journey. It was a very fucking cool journey. So yeah, we generated, like, it's kind of insane, like generating an entire AV file completely from scratch, and it's playable by MPV. That's kind of fucking insane. I never thought I'll be able to actually do that. So, but yeah, I did it. We had coded a lot of stuff, honestly, granted. We had coded a lot of stuff, but once we have something hard-coded, it's very easy to start working towards unhard-coding it, right? So because as soon as you start unhard-coding it, right, so you may encounter an error, you can test it out and smooth it out, and it's just like you have something to work with. You already have something to work with, so it's amazing. I'm really proud of what I did. So yeah, I guess that's it for today. Thank you everyone who's watching right now. Thank you everyone who stayed with me for this entire 3 days. That was an amazing journey. It was more of a spiritual journey, honestly, right? So doing this kind of stuff, it's pretty much a spiritual journey, and I really appreciate everyone who stayed with me the entire time. So yeah, that's it for today. Thanks everyone who's watching right now, I really appreciate it. Have a good one, and I see you all on the next spiritual journey with Mr. Azuzin. I love you. Mwah.